Well, good morning, everybody. Good morning to the people in the audience. I mean, it's Sunday. It's Sunday, 9 a.m. It's raining outside.
Give yourself a round of applause.
Yeah.
That's commitment.
That's commitment. You guys mean it. Thank you for being here with us. It's my pleasant duty to introduce the first speaker of today's session. Hilmar Orth, co-founder and a legendary member of Gelato, and he's going to talk about how to decentralize the Web3 backend. So this is a developer-focused talk. So I'll just sit here with the audience and listen in quietly. But now, please, one more clap for Hilmar. Thank you so much.
Great. Okay, we have microphone is working quite well, so thanks everyone for coming. Because we are a highly concentrated crowd, we can make it very interactive. So if there are any questions in the middle or something, just try to interrupt me and ask me. What this talk is basically about is just I want to give you a quick overview about Gelato, what we do. Our mission, which is helping projects decentralizing their Web3 backend, realizing the need for not only having smart contracts be run by a decentralized network like Ethereum, but also some other components that are quite necessary for your application to be used by users and you not becoming the central point of failure when you're actually the developers or the projects themselves building the applications. Yeah, so if you have questions, definitely just interrupt me. We can talk about it. Let me just see if the clicker works. Yeah, it's this one. Cool. So we will very briefly go through sort of like backend architecture of Web3 applications today. They sort of assume still this notion of not being on your own chain, like not on your own application-specific chain. I think there are certain things that get added if you go into that area as well. But it focuses more on, like, let's say, if you deploy on Ethereum or Polygon, for example, and then basically the services that we offer yeah, how you can decentralize your backend using Gelato, what we do, what we don't do, etc. Cool. So this is sort of, I think, many people when they join the space and they, let's say, on the hackathon like here, they think about how their application will look like from an architecture point of view. They got their front end, they got a couple of smart contracts, and they think, okay, hey, the smart contracts will be my backend, and that's sort of it for most parts. I can write my business logic in there, I can get my data storage in there, but of course we all know this isn't really everything that is needed, and sophisticated applications look quite different to that. And there are several problems with smart contracts, or not problems, but limitations from smart contracts that make it so that you need a bunch of other things actually to build really scalable, sophisticated, and user-friendly Web3 applications. And so the first one that we realized with Gelato very early on is that, yeah, smart contracts are actually not that smart. They're quite dumb. They just store some business logic, they store some data, some state, but they don't really self-execute their business logic, or they don't have this notion of event-driven execution or recurring execution, cron jobs, these type of things. And so for a lot of use cases, you need that sort of outside, you require an outside impulse to your smart contracts and actually to move data from A to B and to change state and to actually execute the business logic that you define within them. And this is actually quite interesting because smart contracts, they're not smart. Then, of course, we all know blockchains are very isolated environments. You need that sort of deterministic nature of an EVM or any other sort of contained virtual machine. And that means that you can't have them talk to, or it's not natively supported to talk to the outside world because you would introduce a bunch of uncertainty to the underlying blockchain. And so you need, again, other middleware to actually enable you to communicate to, let's say, a Web2 server or something else. Then we all know the user experience is terrible because we still require users to interact directly with the blockchain rather than sort of making it so we have this abstraction layer and we interact on their behalf on the blockchain, which is sort of like letting users directly write in your database or something in Web2 world using some queries or whatever, or calling APIs themselves, even though through like a Chrome extension, but sounds also weird. And then of course, data is really, really difficult to actually get, especially historical data for your applications. If you want to show what happened a year ago, yeah, making that interacting straight with the blockchain is very cumbersome and very, very inefficient. So how it turns out, there are probably some other things as well, but this is sort of like how it usually looks like if you build an application. These are like a bunch of things that you require in order to have a truly scalable, user-friendly Web3 applications in place. So first of all, you have like to index the data of the blockchain sort of in parallel to new blocks being created, to then be able to, let's say, go back in time 100 days and see from 100 days to now what was the return that someone got by investing in a certain pool, let's say, right? This sort of like helps you solve this issue about data indexing and making it available. For that, you of course need databases. Sometimes you can opt in for centralized ones. Then there are of course like IPFSs or Arwees, which hope to be a bit more decentralized. And then you have this notion of, okay, these smart contracts, they can't trigger themselves, right? You can't update their state programmatically based on certain events happening. And so for that, you need like job schedulers, you need like event-driven transaction services, and you combine this job scheduler aspect with like transaction relaying, which is just a matter of, okay, how can I write to the blockchain in order to update its state, right? And you combine these together, and then you make your smart contracts actually smart and reactive and event-driven. Then, of course, you need off-chain data, fetching to fetch data from off-chain. You need a private key vault or some notion of someone sending transactions and signing transactions in order to actually update the state on-chain, right? And then, of course, you want notifications and alerting because, let's say, you run an investment sort of pool or a vehicle and something goes wrong or there's a hack or something weird happens, there's a deep hack, right? You want to get alerted as a team. Your customers should get alerted if something happens, like a transaction, an order was executed on their behalf, right? All these sort of notions are things you have to work and build in parallel to the underlying system, the underlying blockchain. And this is just like an example. Arrakis is this decentralized market-making service in Web3, and this is sort of how like some of the functionalities they need to do in order to actually off-chain, which is not supported by like the smart contracts themselves, to actually build the applications in the right way. They have to do a bunch of computation off-chain. They're building these very sophisticated strategies where they get the price data, volatility, volume. They run AI models to then define when to rebalance basically liquidity and when to rebalance money in Uniswap v3. And of course, they need to execute these strategies automatically, right? They need to send the rebalance transactions and they need to send alerts to the team so the team knows when something is maybe not rebalancing correctly. They have to have emergency stops, right? If some sort of weird thing happens, they need to stop maybe and send a transaction to their smart contracts. And yeah, then of course on the UI, they need to display to users, hey, what is actually the current price? What are the current prices? What are the APRs that you as a customer have gotten over the past 30 days, let's say? When did you deposit? When did you withdraw? And this is just a lot of data, a lot of calculations that have to happen off-chain in order to actually make it work. So a bunch of things. And yeah, there are of course a bunch of problems if you want to do all of that yourself. Just from a like managerial point of view, like the first ones, but then at the end, like the sort of notion of centralization. So of course you need to manage, scale, and maintain a bunch of server resources, especially if you go multi-chain. You basically have to sort of like replicate that, and it grows linearly for every new chain you add that you want to support, especially if you go to more sort of exotic chains. RPCs are still a huge issue. You can't really rely on a single provider, right? You need to have two, three RPCs to have redundancy in order to actually connect or even run your own node to have like a stable connection to a certain certain network, and even then it's not really guaranteed. And then you need to, maybe if you use other providers, you need to pay a bunch of them in different tokens and deposit them here, and your money is fragmented. Of course, there's this notion of private key storage, which is always very sensitive. But then if you do that all yourself, then, well, you basically become the central point of failure within your system. I think Michael from Liquidity did a great talk 2 days ago about like why decentralization matters, right? Your application, the goal is your application shouldn't be just be able to switch off if someone comes in, right? Or demands that you do something. But if you control all the data, if you control the system that actually sends transactions to updates the state, then basically the application will be made useless if you don't have a more decentralized system where it can withstand some sort of censorship attack. Yeah, and this is what we try to do at Gelato. We try to help you with that and build your smart contract Web3 applications in a more reliable, user-friendly, and scalable way without trying to sacrifice decentralization and censorship resistance. This is like the high-level goal. And for that, we really have like 3 main services that try to solve that or solve parts of the aspects. We don't do everything. There are other really cool middleware providers in the space that do a bunch of other really useful and interesting things. What we are really focusing on is like the smart contract automation part, helping you to do this event-driven, recurring transaction, like writing to the blockchain system. So whenever an event gets fired, you want to react to it and send a transaction. You want to check certain conditions off-chain every minute or so. This is what our automation service helps you. Web3 functions, I think I had a talk on Friday about it. It's really about bringing that notion of like writing to the blockchain programmatically on your behalf, but like using off-chain computation and data. Like you used to just be able to define smart contracts, and these smart contracts where you are like on-chain sort of computation environments that would tell Gelato when to execute a transaction. But now with Web3 functions, you can write like a TypeScript file off-chain that you deploy to IPFS, let's say. You say to the Gelato nodes, please run that particular basically back-end sort of Lambda function for me based on certain events happening or every minute. And then if the logic is met, please execute. That's, for example, what Arrakis is using. If they are running strategies off-chain, they're using these functions that are being called, let's say, every time someone swaps in Uniswap, they will trigger this logic off-chain, which then sees, okay, can I rebalance my liquidity to now, again, like create some spread in the market that I want to achieve, right? This is all based also on like transaction relaying, which is just this notion of like, hey, help me get transactions written to the blockchain. And next to that, of course, you still need a bunch of other things. You need data storage, like an IPFS or Arweave. You need like indexing, like the graph, for example, right? You can actually, on top of Web3 functions, also add for more data integrity stuff like pull-based oracles, where you can actually pull data from oracles in and then run some logic on this and see if you want to send a transaction on-chain to update the price actually, and then you can do it, right? So it's really focused on this computation and then writing to the blockchain for you. And this is sort of like how it works. Gelato consists of a bunch of validator nodes, Gelato nodes. These are right now whitelisted parties that we onboard case by case. Some of them are, for example, like staking facilities that they're, I think, also the biggest Lido node operators, Beware Labs, and some others. And what they do is they run this sort of like base client where they have to stake gel in order to get whitelisted and have to undergo some sort of whitelisting criteria. And then they can choose that they want to run some of these services. They can run like an automation service, just a transaction relaying service, Web3 function service. They all have different sort of, it's like a microservices-based system, so you can sort of opt in what you want to do. But if you want to optimize and increase your, or maximize your revenue, you basically want to run all of them because it provides you with most work. And for all of this work that you run, you actually get paid as a node operator. So there are 2 sort of fees in the Gelato system. They depend also on the services. There's one is a computation-based fee and one is transaction-based fee. Every time, let's say, you need to run a Web3 function, which is like this Lambda function, right? off-chain on behalf of a project, you incur, of course, some CPU costs, some memory, some RPC costs, and so on. And for that, you basically charge the project. We built this whole like payment system, like an off-chain payment system, which is super efficient, where you deposit USDC on Polygon, and you can pay for computation, and you can pay for transaction on all chains, on Ethereum, on Binance Chain, Avalanche, Arbitrum, whatever, just with depositing USDC on Polygon. Or you can deposit USDC on Arbitrum, and you can pay for transaction on Optimism, right? So it's all handled and abstracted from you under the hood, with Gelato basically fronting the network token always. And that money basically gets deducted for all users in certain intervals. So we push basically Merkle routes that define the state of everyone's balance on Gelato every like half an hour or so to all the chains, and this updates their cost basically that they incur with us. And yeah, if you basically run this computation off chain, and then you might end up in sending a transaction on chain, and this is really what Gelato is about. Then you actually sign a message, you send it to another party, which are executor node operators, and these executor node operators, they are just very sort of simple, dumb parties. They just like take transactions, and they have to follow certain rules, like go via flashbots, go via this private gateway, or go there, and then they get the transaction mined on chain. The goal for us right now is to make it so that everyone in the world can run these executors to actually send the transactions on chains, and then the validator set is a bit harder to make completely permissionless because there's some non-deterministic nature to that, and some data integrity that is important to uphold. So there, yeah, we are right now basically making this approach of whitelisting people, whitelisting individuals, companies and projects in the space that have reputation that will run this according to our spec. But yeah, as soon as the transaction gets on chain, you hit the protocol, it does some checks like, hey, does this node have sufficient stake and stuff, sends it to the target contract, which might be MakerDAO, let's say, and then gets it mined. To give you a bit of context for like our automation service, let's say, you have these, let's say, like 3 customers that you probably know, like Yearn. Like, how does Yearn use it? Yearn uses our automate system to just harvest the rewards and fees of these vaults that they run, right? So they pool DAI from everyone, they put it into Aave or another protocol, they harvest some yield farming rewards there and some fees, and then they sell them all in one batch every day or so, and then recompound it into the pool. And so your assets increase in value over time there. MakerDAO has a bunch of in-protocol related tasks they have to do. They have to change parameters based on votes and do a lot of like cleanup, sell fees that are incurred and burned to Maker and these sort of things, all these operations that have to happen under the hood. That's what they use Gelato for, to automate that. They actually build a very nice sort of protocol-specific automation system where they can just plug into Gelato and just easily create all of these on-chain. It's actually quite cool. And then Optimism, what they do use it for is they have to constantly push, they have these sequences, right? They have to constantly push transactions on-chain, on Ethereum, right? With all the data of the transactions that are being executed on their L2. And this means they're burning through a lot of ETH. I think, yeah, the L2 sort of sequencers, they are burning through a lot of ETH. I think they're like the biggest ETH consumers on Ethereum, actually. And so these nodes that do that have to be constantly topped up and have to be constantly monitored to have sufficient ETH to pay for transactions. And so what they have the centralized smart contract. This is where they collect all the fees that they collect and all the ETH from their system. And then they have Gelato basically monitor the balances of all these nodes that send transactions, and then they send them to the nodes and top them up periodically in order to make sure their system isn't down and transactions get executed on chain. So this is like a common use case there, topping up systems, monitoring this, and then they can actually send alerts when these transactions are sent and so on. Yeah, for transaction relaying, this is really more about like UX. So this is really how can you level up the UX on your application. You might have, it's very, like you might have heard about the concept of account abstraction, right? Transaction relaying is a big part of it. And especially the problem here is not really like how can I get my transaction included in the chain, right? You have like concepts like use operations in ERC-4337 that you can use. You can use traditional just transactions where you just send a transaction via the regular, like ERC-4337 is just a different mempool that you can use, so to say, to get transactions mined. You can also use the regular mempool, or you can use flashbots, right? But it's really about the payment. So how do you pay for these transactions, and how can you as a project sponsor a transaction? How can users use tokens, let's say, that are in their Nozosafe to send transactions and pay for transactions? And this is where like this whole relay system comes together. It has a multi-chain payment system which works across many chains. And as a couple of use cases, for example, the Safe team, I think it was actually 2 days ago or 3 days ago, integrated Gelato Relay on their UI. So you can now, I think they're starting with Gnosis Chain, you can now basically rather than having some signer of your Nozosafe multisig have to send the transaction, you can just like click a button and then Gelato will send it on your behalf if all the signatures have been collected. So you don't, especially if you have safes on multiple chains, you don't always want to like bridge your funds over to all the chains to then have someone that can click the button and send the transaction. So yeah, you can basically just click a button and have Gelato do it, and they will roll it out on all the other chains, right? So at some point, no one has to pay for transactions anymore when sending transactions on the Safe app. And we're actually working on a system right now. They're sponsoring it, so the Safe team is sponsoring all these transactions. Gnosis Chain is quite cheap, so I think it's not breaking their bank. But we were actually working with them on a way where we can use the funds in your Nozosafe to pay for the transaction. So you just have to collect the funds in your Safe, and then you pay Gelato in the transaction with that. Connext is basically doing the same. They have this cross-chain messaging protocol or bridge. If you send a transaction on the home chain, they will send a transaction for you on the destination chain to bridge your assets, let's say, and they actually use Gelato's relay system under the hood. So the only thing they have to do is they have to deal with the liquidity of having sufficient assets on chain A and chain B. And they have to deal with the security of the system to make sure that the data is correct, and the user is actually allowed to mint tokens here and burn them here. And for all the transaction part, I use our relay system. And then, of course, you have like gasless NFT drops. Renault did one with us last year in December, for example. And this is just very cool, especially if you combine it with like smart contract wallets and Web3 auth, to have really like a super seamless user experience. I demoed it in the workshop on Friday, where you can literally just sign up with like your Gmail and then mint some NFT and they pay for it, right? So it's really cool. Web3 Functions is our like newest system, right? And there I'm super excited about, and we just like rolled it out very recently. But there, what we are seeing is that projects leverage it to basically what you can do is you can call off-chain APIs, right? And then run some computations and transactions based on that. And how projects are using it is before something like Web3 Functions, if you wanted to, let's say, periodically sell, let's say you accrue fees in your protocol and you want to sell them, right, to your native token, to USDC, let's say, right? You had to build like a smart contract that routes through SushiSwap, Uniswap, Curve, whatever, to always tap into like liquidity. And now this whole routing, you can just do off-chain with like 1inch, call the 1inch API, and then just like send the transaction on-chain. And you basically save a ton of smart contracts. And this is actually something we see more and more. The more like they are all outsourcing logic that is not core to their protocol to off-chain, and just do everything they can do off-chain and then just send a transaction that includes a route and a payload on-chain and just do it. And I think this is actually where this space is going. I think protocols might actually look like just like Nososafes, and then you just do all the computation that you want to do off-chain and then send a transaction, and then you, if your application is nothing else than just enabling people to go from Aave to Compound and then swap on Uniswap and then go back. Like back in the past, you had to build these smart contract systems that do that all, right? And these were like then Yearn or whatever, but you can do all of this off-chain and just send a transaction on-chain and then do it in one transaction and then have the funds be in the user's safe, right? I think this is actually what we're seeing, and this will actually make a bunch of protocols not that interesting anymore. But yeah, other use cases other than like 1inch APIs are calling subgraphs, right? Iterating through millions of NFTs and then sending transactions to buy or sweep the floor and do something like that. So yeah, these are a bunch of use cases we see, but also like prediction markets, dynamic NFTs, etc. So yeah, this is sort of like the Web3 function service and some use cases there. Yeah, and what's the mission here for us over the long run is we tried with Gelato to get as close as possible to Ethereum's security and decentralization. You should not be able to stop. If you set up a task with Gelato that should, for your protocol, update certain state periodically, you shouldn't be able to stop it. Like, no one should be able to stop this process. Right now, I think we are not quite there yet, but we are looking into a lot of different ways of achieving this. One thing that actually goes live right now is the gel staking, slashing not quite yet, but also this year, where node operators have to stake, and so they have some more they have some crypto economic incentives to actually do what they're supposed to do, not only like off-chain contracts. Then we're actually looking into having Ethereum nodes run Gelato clients as well through something like EigenLayer, let's say, where we would like open up the system to not only allow gel stakers to run nodes, but also ETH stakers, basically. And this would really enable us to get as close as possible to Ethereum's decentralization. So this is something we're discussing quite heavily. And then, of course, you have the whole notion of ZK proofs, especially if you deal with deterministic off-chain computation that we are very much looking into. Though most of the cool stuff that developers are doing right now with Gelato is with like non-deterministic stuff and like off-chain data that is very hard to like ZK-fy. So that's why I think this is still a bit out there in terms of actual like real applications. Yeah, I think we're also like right on time. So this is some of our ecosystem map, a bunch of projects that we work with. Maybe one of your projects is also on there. Yeah, and if you are building something and need something like what we do, definitely reach out to us, let us know. And yeah, I think that's already it. Thanks for coming here this morning, guys. And if you have questions, just shoot at me.
Thank you so much, Hilmar. We are right on a schedule, so if you have any questions, I guess people can find you here.
Yes.
So thank you so much again. Please, one round of applause for Hilmar and his Sunday morning talk.
Well, more people than I expected.
Amazing, thank you. So next up, we have a slight change in the schedule. The next talk is actually moved from the execution stage over because the speaker didn't arrive. So we decided to switch. Oh, you're here.
I'm here.
Oh, okay. So sorry. Well, okay. Well, then we couldn't find you.
Sitting in the audience.
Okay. Well, then please give us 3 minutes for us just to reshape things, and I'll just talk to the production to figure what's now on the schedule. So just 2 minutes. Sorry for the disruption here. So next up, actually, according to the schedule, we have Real-Time White Hacks by Arthur Gervais. He's a R&D. Oh, that's sorry. I just prepared. just prepared the other guy. So Arthur is an associate professor of the information security at the University College London, but he did his PhD here in Zurich at the ETH of Zurich. So please, one round of applause for Arthur.
Thanks so much. Awesome. Yeah, sorry, I should have gone to the green room, but yeah, missed that. So thank you for your understanding. Today we're going to discuss white hat hacks. So who lost money in hacks? Really? Nobody? So who made money in hacks? Also nobody? Okay, this is a surprise. But so in general, like we don't really have a clear definition of what a hack is. At least not a formal definition, right? So I kind of would like to put it in the bucket of MEV for now, right? So we have this minor extractable value that most of you, I guess, are familiar with. It's this concept where, well, you do have a blockchain state, right? Different liquidity pools, different amounts that can be traded, different bonding curves, and you can extract value from that. One possible MEV source is arbitrage, right? Liquidation, sandwich attacks, all these sources are really MEV. And attacks are somewhat in between. They are maybe also arbitrage, and they may also be partly liquidations, right? So we don't really have any formal definition, right? So really take this with a grain of salt when I speak about attacks. Don't take it too formally, because we don't really know so far. Okay, so how many of these attacks are actually happening out there in the real world? We did look into the last 4 years of DeFi, and we found about 181 DeFi attacks. So these are not all the attacks, so this is not an exhaustive study, but we've tried to be as, let's say, scientific as possible. So we try to categorize attacks in this so-called SOK paper, Systemization of Knowledge paper. We have big tables there and a lot of analyses. I won't bore you with the details. Today we're just going to discuss about a few key points that are interesting, but I do invite you to check out the paper if you want to look deeper. The total amount of losses are about $3.24 billion US, so that's not a small amount. And the practitioners community has equally published numbers that are quite helpful. So here, for example, I'm citing DeFi Llama, which has a great interface, and they're also trying to categorize attacks in similar time frames. But again, we don't really know what an attack is, right? So typically when some people are losing money and they're crying about losing money and somebody is winning money, then sometimes this is labeled as an attack. But again, we do not have any formal definition of what an attack really is. So how does an attack actually look like, right? So what is the kind of the architecture of an attack, so to speak, right? So I'm just going to depict one example. It's a bit a more ancient example. It's actually one of the very first flash loan attacks. Maybe you've heard about it. BZX was attacked twice, actually, in the beginning of 2020. And this is actually one example of how an attack looks like. I don't really want to go too deep into the details here, but we can if you want, if you have any questions here. But on a high level, right, the attacker is taking a flash loan in point number 1. He's doing some exchanges, then a lending position, and then he's paying back the flash loan. Right? So that's on a very high level what this attack does. So the attacker in this particular attack had to spend about $120 US in transaction fees. And he got out $634,000 roughly. Do you think he took all the money he could have taken? He didn't, right? So we tried to analyze this attack back then, and here's also the link to the paper. He could have gotten 1.1 million if he would have executed the attack with the optimal parameters. So please, if you do execute an attack, at least optimize your parameters, right? Don't leave money on the table for the backrunners, right? It's just no point. All right, so this is just like how an attack looks like, how the architecture of an attack looks like in this particular example of a flash loan. And many similar attacks nowadays that are flash loan based are really similar in the overall architecture. Right, so, but now you may wonder, well, there are these flashbots and peer-to-peer and frontrunners, so how are these attacks actually executed nowadays, right? Back in the day, there was no flashbots, actually, so everything went over the peer-to-peer network. But how does the supply chain, so to speak, look like today, right? How is an attack executed nowadays? If you look at the x-axis here, we have the time, and if you have an attacker, if he's submitting a transaction to the network, you can see here that this transaction TXA may be visible to everyone, right? So that's not a private transaction. If an attacker goes over the public peer-to-peer network, that's a publicly visible attack. And this is still happening today, by the way. We have, I think just 2 or 3 days ago, there was one attack that went over the public peer-to-peer network. Can't recall the name right now, but roughly 50% of the attackers nowadays go over so-called private relayers. Okay, but here in this particular example, right, if we see an attack on the peer-to-peer network, what could happen? Well, an arbitrageur or frontrunner could detect this transaction and then perform 2 things. Either a backrunning bundle, so bundling the attack and backrunning the transaction with an arbitrage, or the frontrunner could try to replace the attack with its own attack and diverting the revenue towards its own address instead of giving it to the original attacker. Okay? This is also something called generalized frontrunning or imitation attacks if you want to look this up. And what's interesting here is why do we have here this part where these transactions may also be sent over the public peer-to-peer layer? Anybody an idea why we would do that? Why wouldn't we just go over private relayers? It's much safer, no? It's not public. Any idea why we would, even if we're using private relayers such as flashbots, BlockXRoute, etc., why would we still try to want to go over the public peer-to-peer network anyhow? It's because of the market share of the relayers. So roughly 90% are using this proposer-builder separation nowadays, this PBS. So 10% of the miners are still, or validators, are still vanilla, so to speak, validators, right? So if you want to increase our odds of actually making it into the next block, we should still go onto the public peer-to-peer network, right? Okay, cool. So we've looked into these 181 attacks that I mentioned at the beginning, and we found that 81 are effectively executed over the Flashbots API. That accounts for roughly $600 million US, so it's not a small amount. But some of these attacks, I may note here, for example, Sorbet Finance, this was rather a white hat hack. So the project at the time found the bug and then executed it themselves. And they went over Flashbots in order to prevent these generalized frontrunners, right? So they used the private infrastructure, so to speak, to secure their rescue operation, if you will. But what's funny is we found that 6 out of these 18 were effectively accelerated by arbitrage traders. So the attacker, we don't have any ground truth, right? So whatever I'm presenting today is based on my evidence, but maybe that's wrong, right? So I don't have the ground truth. The attacker didn't tell me that, yes, they did that. So, but based on our evidence, we found that 6 out of these 18 accelerated attacks were bundled by an arbitrage bot and backrun over, for example, a Flashbots relay. So they got kind of helped. They got help from the arbitrage trader. And here again, this brings us back to the initial attack. If you perform an attack, not only you should optimize your parameters, but please also do arbitrage behind. Right? Why leave money on the table? Right? Okay. So another interesting insight that we found from the study is that the 56% of the attacks are not executed atomically. So even if you use a flash loan, the attack itself may not be atomic because maybe you first deploy an attacker contract that I could detect, right? Minutes before you do execute the attack. So and there's this life cycle where we have initially we have a contract deployment, then after some time, typically minutes, sometimes days even, there is the first attack transaction, and then there may be many attack transactions until the last attack transaction. So just to give you an example, the Euler finance hack, I'm sure you heard it, right? Roughly 200 million lost. Luckily, everything went back recently. The first attacker transaction of the Euler hack only took about $9 million. And I think the second transaction hit after 10 minutes or so. 10 minutes is an awful long time, right? Why didn't we exit the liquidity pools, right? It just doesn't make any sense. Like, why did we watch what happened and what unfolded in front of our eyes, right? I mean, we should have had automated intrusion detection and prevention systems here, right, in place that automatically remove liquidity from these pools. Okay, and I mentioned to you, well, we can observe when the attacker is deploying a contract, but you may say, well, it's hard to understand what the contract is doing without having a transaction that executes one of the functions and so on. Yeah, sure, I understand. But what we can do is we can learn from past attacks by conducting a similarity analysis, right, between past attacker contracts and past vulnerable contracts as well, and then try to somewhat see whether there's some similarity and then ring the bells. We did a very simple study. I'm sure you can't come up with much more fancy and probably more accurate schemes, but we took the bytecode of these, for example, victim contracts as well as adversary contracts. We chopped them into n-grams. We created some embeddings and then tried to see how similar they are. Right? And at least according to our naive analysis here, we do see that quite a few of these adversary contracts and victim contracts are very similar. Right? So again, what are we doing, right? Why are we not looking at the data and trying to correlate it to past events? Right? We can really improve security by quite a bit. All right, so I want to dive into two case studies. The first one is a bit more elaborate, the second a bit quicker. And we will start with actually, so to speak, a cross-chain attack. Maybe you've heard about the Elastic Swap attack in December 13th of last year. It happened on Avalanche and on Ethereum. Elastic Swap had a vulnerable contract, a similar contract deployed on two chains, and it got first attacked on Avalanche, right? So here, this red logo is Avalanche, this here is Ethereum, and we have 4 transactions. The green checkmark indicates that the transaction executed successfully. The red checkmark indicates that the transaction failed. So in what we saw first here is transaction 0, that we have a function name called go. I labeled this as an attacker. I don't know whether it's the original attacker, but I assume based on the evidence that I have that this is the original attacker. And we have found then 3 transactions on Ethereum here. So why do you think that transaction 1 failed? Based on the evidence provided here.
Maybe some network-specific configuration that was correct for Avalanche, not for Ethereum.
So the attacker was successful on Avalanche, right? And he was apparently the only one, right? There was only one entity, so to speak, right? So he had success there, right? And you're right that on On Ethereum, there was a bit different setting. It's not about the configuration, but rather competition. So we have here on Ethereum, we have what we labeled as the original attacker. Then we have a white hat hacker, labeled as white hat hacker. Again, we don't have ground truth, but that's what we believe there is. And the attacker here tried to execute apparently a similar function, similar to the attack that he previously did on Avalanche. Maybe this indication helps you? Yeah?
I guess that the white hacker used fastmode like the other relayer, not the public, and this first.
Absolutely. So transaction 2 here was front-running transaction 1 because it went over a relayer. It went over a private relay in this particular example. And due to the fact that transaction 2 was mined before transaction 1, which I understand may not be visible in this representation, but from an on-chain perspective, transaction 2 is effectively front-running transaction 1. Therefore, transaction 1 can no longer execute with the parameters that it wanted to, right? Because probably it touched some liquidity pools that were empty then. But then why do we have this third transaction, this fourth transaction here, transaction 4? This goes back to the previous slides where we discussed why should we go over both networks, the relayer networks and the public peer networks. Do you remember? So this transaction here went over the peer-to-peer network, and this transaction went over a relayer. So it seems like we have an adversary here who's playing two games, right? He's going once over the public peer-to-peer network and once over a relayer network. Okay? I want to emphasize that this time difference here is quite important. What we found is that the attacker and the white hat hacker, they only appeared within 250 milliseconds, right? So what we conclude from this is that we have a white hat hacker who is bilingual, so he can both speak peer-to-peer network and private relayer, right? He's apparently doing some generalized front running because 250 milliseconds is rather quick, right? That's automated for sure. It's still not high-frequency trading fast, maybe, but it's quick. And he's quite good at bribing, too. So out of the 523 Ether that were vulnerable in this particular attack, he paid 15% as a bribe. It's not little, right? And then he took a 10% bounty, and he paid back the rest. That's why we label him white hat hacker, right? Don't ask me where this 10% comes from. It's somewhat a decentralized agreement among white hat hackers and victims, apparently at the moment. Yeah. Okay, what about the second incident? So the second incident was the Saddle case in April 30th last year. Saddle is similar to Curve. It's a packed coin AMM. And so here, an attacker took money. And then later, a bit later, the Blocksec team were able to secure another $3.8 million. And if we look on-chain, this is what we can see. Now, I have a question for you. Why can the white hat, in this case, extract another 3.8 million, although the attacker already took 9.2 million? What the hell happened here again? Yeah?
Maybe, as you said before, some arbitrage which was not collected.
Very good point. So the attacker probably didn't take the arbitrage that it could have taken. But in this particular case, it was actually the parameters, again, from the attack that were not chosen optimally. Right? So again, the attacker here just left money on the table. And by tweaking the parameters, we investigated this attack, actually. There were like 2 or 3 parameters that you needed to tweak to get the remaining 3.8 million. And due to the 24-minute time difference, This was apparently not executed automatically through some program, but through very quick manual inspection and reaction, like really fast for humans. All right, cool. Thank you so much for your attention.
Thank you so much. There's still some time, so if people in the audience have any questions, now is the right time. So we have there.
As you mentioned, that there are sometimes like test hacks on chain before doing a big hack. What could be the reason? I mean, the attacker could do this locally on a local fork to test the hack. Why hackers do like test hacks on chain?
Right. It's beyond my understanding. I'm not sure why. Like, you can so easily connect to an archive. Okay, I mean, maybe they don't have access to an archive node, but even that would be weird, so to speak, right? I mean, there's no reason why not to connect to an archive node, fetch a later state, and see how much profit you can extract. Or even as an attacker, right? You can, over time, you can estimate, okay, should I hit today, or maybe tomorrow is the all-time high, or, right? I mean, like, you don't know how much liquidity there will be tomorrow in the pools, right? So I'm not sure to understand and why they're not optimizing attacks and why they're not executing them atomically. Yeah, I mean, I don't want to give tips to hackers, but we need to understand what we can do to prevent the attacks, and that's why we need to understand where they default to, right? It's a cat and mouse game at the end of the day, at least when doing these kinds of white hat hacks. Yeah.
Any more questions? Oh, there's one. Yep. Can you, sorry, can you wait for the microphone?
Hi, so you mentioned we need to prevent attacks. What can we do to prevent attacks?
Thank you. They're very, very relevant question. So security is an in-depth, defense in-depth approach, really, right? So the more layers you have, the more likely is that you will defend your assets. And that means an audit is the first layer, but it's only the first, right? And it's not the only, it shouldn't be only the only layer. So in DeFi in particular, I believe it's crucial to have real-time defense mechanisms. So for example, you can have a monitoring system where if there's a certain amount of liquidity being extracted from a pool that you're invested in, right, then you should have an automated process to take that money out, right? Or if you see an incoming transaction on the network layer, you need to have some kind of intrusion detection system that classifies how abnormal is that transaction. Right? And then you may want to trigger an emergency pause of the DeFi protocol if you can. Right? So 50% of the DeFi protocols we looked at are having emergency pause mechanisms. They are often, unfortunately, very centralized. But according to our data, they triggered, on average, in 6 hours only the pause after an attack. So there's literally seemingly no automation so far. And I think if we just have more layers, more defense layers really, and we don't just like naively stand by an attack being executed over hours, we should be much better off in DeFi and secure the space.
Very cool presentation. And based on your data, which DeFi protocols are being attacked most often? And which users, like normal traders, LPs, arbitrageurs?
Excellent question. So we have a table actually in the paper where we categorize which DeFi protocol type is being attacked the most often in terms of frequency, as well as in value lost. I think in both dimensions, bridges are the most brittle. So both in terms of the yield farming, I think, has the most hits, but the same lost value as bridges, while bridges have roughly half of the number of hits in terms of attacks as yield farming protocols. Yeah. Roughly speaking, these are the worst. Yeah.
So I think we have time for 1 or 2 more questions, if there are any. Oh, there is one.
Do you think that all math attacks are bad? Because you might also think about them like, they are like a Robin Hood. They are like robbing the rich and giving back to the poor, especially if the rewards are distributed through liquid staking to others.
Right. I'll try to not judge whether an attack is good or bad. I'm sorry. Like it's like asking, is a sandwich attack good or bad? Right? Is it okay to take money away from sandwich attackers or not? I'm not sure. So I'll refrain from judging. But it's true. That's a good question that everybody should ask themselves. And yeah, it's not clear. I think it's very subjective, so to speak, as a question. Yeah.
So how would you judge the security of DeFi as compared to traditional finance then?
I'm not an expert in traditional finance, so I wouldn't want to pretend I am there. So, but I see the space being very amateurish still with respect to real-time security, really, right? Because audits, I think the community has gotten really good at doing audits, but through the experience that we've seen, through the empirical data that we've seen, it should be very clear that can't be everything, right? And it doesn't make sense that the bridge, for example, is allowed, or a user is allowed to take out all the money of a bridge in one single transaction, right? Why not have like some kind of a circuit breaker there? So they're very simple means to improve overall DeFi security through these different layers. So circuit breakers, real-time intrusion detection systems, real-time pause activations if your protocol already has it, why not, and so on, right? So I feel it's still very amateurish at the moment. Yeah.
Well, thank you so much again.
Thank you.
If you can stand like in the middle. So next up, we're going to continue on the smart contract hack side, or rather smart contract security side, with Roman Böhringer from Solidified and Oak Security. Roman has discovered over 100 different bugs in a variety of smart contracts, so he's an experienced bug hunter. Yeah, I think like for everybody in the room now, the talk should be pretty interesting because it follows up on what was said in the previous one. So please give it up for Roman.
Hello everyone to this talk about smart contract vulnerabilities from first principles. I think you've already heard a bit about DeFi security, and now I want to talk a bit more from the code side. How are these vulnerabilities actually caused? How can you find them as an auditor, or how can you avoid them as a developer? Let me briefly introduce myself. I'm Roman. I've studied at ETH Zurich, so pretty close to here. I work as a smart contract developer for various protocols, mainly in the DeFi space I worked in the past, and as a security researcher. In my spare time, I also participate in bug bounty competitions and auditing competitions. And if you don't know these kind of formats, basically you have to find rare vulnerabilities there to maximize your payout and to maximize your rank, because this depends on how many rare vulnerabilities you find. And I noticed after finding many vulnerabilities over the years, I noticed that while the bugs are somewhat different, the underlying issues are always kind of similar. So at some point, I started to think, what are really the underlying issues of these vulnerabilities and also of the hacks that everyone reads about. And I started to compile a list for them that you can use as a mental heuristic, as a developer, or also as a security researcher, or even as a DeFi user, depending on your role in the ecosystem. Just as a small warning, these are all heuristics, so they can help you a lot to get ideas where to look for exploits and what to look for in a code base. But of course, you cannot directly apply them to every code base and find directly 10 vulnerabilities. Would be nice if something like that would exist, but sadly it doesn't at the moment. So let's start by the first one. I think everyone that has programmed at some point knows about off-by-one errors. It's like one of the most common errors that you see when programming, when iterating over array, or in general that you're just off by one, either one too high or one too low. And surprisingly, this is also very common for vulnerabilities or for bugs that then can be turned into vulnerabilities. Because of that, I always recommend when a comparison is made, you should always think about what happens at the boundaries, so directly when the value is reached. For instance, I've shown here an example that I've seen in an audit in the wild. And this was an auction platform, and basically they had a modifier for the time before the auction has ended and the time afterwards. And these two phases should be distinct, and the developer actually assumed that they are distinct. However, it turns out that when the block timestamp is exactly equal to the auction end, this contract was in a very weird state where it was the auction has already ended, but it also hasn't ended yet. And this was actually exploitable here to buy a free NFT in that case. And this code was actually audited before, and it wasn't caught there. So I think just with this mental heuristic, you can catch this error, because I mean here I also just thought about what happens if the block timestamp is exactly equal to auction. And this was actually a major issue here, because you could have exploited that to get a free NFT. So in that case, it was quite a financial loss that could have occurred because of this bug. Another thing that is very common for smart contracts is that you have a source and a destination address. I mean, if you think about tokens, for instance, that's of course the obvious example. But in many protocols, you want to do transfers, you want to specify sources and destinations. And many programmers, when they code this, they assume implicitly that the source will not be equal to the destination. And I think that's a pretty normal and human thing to do when we talk about the source and the destination. We always mean that they are not equal. I think that that's pretty normal to do as a human. But of course, when you don't ensure that in the code, the user may be able to specify the same address. And for some protocols, this can result in huge vulnerabilities. And this snippet that I've shown here, I've not seen this in only one audit. I think in 4 or 5 audits actually, a very similar vulnerability to that one, where the balance is cached before, and then you use on source, you don't use the cache balance, but on the destination update, you use the cache balance. And basically, what this results in is that you can inflate your own balance. If you just specify source and destination, you can inflate your own balance as you wish and completely break a protocol like that. And I mean, also, like, these kind of vulnerabilities aren't that hard to catch as a developer or as a security researcher if you just have this mental heuristic in mind that you should think about what happens if the source is equal to the destination. Another thing that's very common for DeFi protocols and in general smart contracts is that you have symmetric code function pairs. I mean, the obvious example here are deposit and withdraw functions, but this can also be administrative functions, for instance, a pause and an unpause function. And when you have these kind of functions, they should always be symmetric, or most of the time they should be symmetric. There are a few exemptions, but most of the time they should be symmetric. So this means that a withdraw function, for instance, should undo all side effects that a deposit function did. And surprisingly, this is also quite common that one of the side effects is forgotten. Maybe it's only a small side effect, but oftentimes this can lead to other problems down the road. And I've given a very simple toy example here. Basically, deposit and a withdraw function, and the deposit function marks addresses over a certain balance as premium addresses. And I mean, these kind of patterns are relatively common, that you may have a side effect depending on the balance or depending on the amount. And then when you look at this code, or when you develop this code, I really recommend to compare like both functions, maybe even line by line, because then this is extremely easy to catch. When you don't do that, this can be very hard to catch because it may be a small side effect, but when you really compare them side by side, things like that are easy to catch. And but if you don't catch them, they can have like pretty major consequences depending on the exact code. In smart contracts, I mean, it's pretty normal that there are rounding errors, and in general, this is not a problem. However, it can become very problematic if these rounding errors are amplifiable in some way. And I've shown a small example here. There's actually, there are parentheses missing here. There should be parentheses here, but let's assume that there are parentheses in the days delta line, and then what this function does is it first calculates how many days have passed since the last interest accrual, and then it uses this value to calculate the interest that is due for the use or for the position. I mean, this is a very common pattern. This is also actually more or less from a production code base where a similar code was in. And this generally works if you accrue very rarely. I mean, if you accrue interest every 200 days, for instance, this isn't too problematic to do it like that. But of course, the problem is that the days delta, that this calculation rounds down. So if you call this after 23.9 hours, for instance, the days delta will be 0 and the whole interest will be 0. And this was actually the vulnerability in this protocol. This was a mortgage protocol, so pretty high values, million or a few millions. And then, of course, if you take out the mortgage there, you have an incentive to just call this function every 23.9 hours because you get a free mortgage like that. And I mean, paying $5 or $10 for the gas fees isn't too bad to get a free mortgage. So I think that's a deal that most people would take. And also this error, this was tested, this function, and it worked well in the tests, but the problem was they only tested it with whole days, and they didn't think about rounding errors or what happens if values are rounded down. And I think that that's always a good thing to have this in mind. And I mean, it's especially problematic if you divide before multiplication. These are usually the scenarios where things like that happen, where you have these amplifiable rounding errors, where suddenly instead of one way, you lose one ether or things like that. So Solidity is kind of special because it doesn't have an option type. So you don't have none or null like in other languages. And a very common pattern to check if a state is uninitialized or if some variable is uninitialized or if some mapping key is uninitialized is to check if it has the default value. So 0, for instance, in the case of an int, or address 0 if it's an address. And I mean, this pattern is generally fine, but it can become problematic if there is a way for the user to set this value to 0. Because, I mean, then you execute the initialization logic, but then the user can reset the value to 0 or address 0 or whatever the default value for this particular type is. And then if this code is executed the second time, the init logic is executed the second time as well. And I mean, as you can probably imagine, this logic is usually written with in the mind that this should only be executed once. So this can often lead to quite large problems, not only security problems, but sometimes it just leads to a denial of service and leads the smart contract in some weird state where it doesn't function anymore, simply because this was never intended. So this is also something to keep in mind when you see such logic. Always think about, is it possible that the value will have this default value again? And if so, the recommendation is to use an explicit initialization flag. So just a Boolean, you set that once, and when it's set, you do not execute the logic again. It has a certain overhead, but sometimes it's unavoidable. And something that's more testing heuristic is that for many functions, n function calls with the value x should be more or less equal to one function call with the value n times x. For instance, if you think about the deposit function in a smart contract, if you call this function 10 times with 1 ETH, or if you call it 1 times with 10 ETH, the resulting system state should usually be quite similar. There may be small differences, and there might be valid reasons that there are large differences, but in most cases the state should be similar, and that's also what you would expect as a user. And I mean, this is very easy to test. This is also very easy to test with fuzz tests. You just split up a given test and run a small loop and compare the two states. Nevertheless, it's often able to catch some errors. For instance, it might be able to catch rounding errors, or it might be able to catch wrong init logic. This mostly because I've seen like test reads that only call a function once, and the system completely breaks if the function is called the second time, but they don't test this. And I mean, of course, this is also something that you should test. Don't only call your function once, call it multiple times in your test read and check that nothing breaks like this. Another thing that is common in quite a few smart contracts and that leads to a lot of vulnerabilities are the handling of duplicates. And this is all the snippet that I've shown here. This is also from an audit I did, was also not catched in quite a few prior audits. And basically what the problem here is that the developer first cached all the balances of a user-provided token array, and then paid out these cached balances. And this generally works fine, but it becomes problematic if the user provides a duplicate in this list, because then his balance will be there 2 times, and he will get paid out 2 times or even multiple times. And I mean, you may wonder why the programmer even used this weird pattern or this weird code, why he didn't initiate the transfer directly. The reason here was that he wanted to follow the check effects interaction pattern very closely. So he wanted to do all interactions in the end for security reasons, which is generally a good thing to do because of reentrancy attacks. But he actually introduced another vulnerability when refactoring the code to address this first vulnerability. So, and I mean, this is something that is relatively common, that you see a lot, because oftentimes also developers do this implicit assumption, a list they won't have duplicates, but then they forgot to check for it or to disallow lists that actually contain duplicates. And as you probably noticed by now, many vulnerabilities are caused by assumptions that a developer makes, by implicit assumptions that he doesn't then explicitly check in the code. And also this one is the same. Basically, something that you often see is that a developer assumes he can just query the ERC20 balance or the Ethereum balance of the contract to get the sum of all deposits that were done, for instance, over a function. However, the problem is you can always just manually transfer tokens to a contract, and you can also always manually transfer ETH to a contract, even if it doesn't have a receive function. And this can cause some problems because when it may result in situations where some variables are out of sync, where the developer assumed that his manually kept variable with the deposits is equal to the balance of. And these discrepancies can be quite problematic and actually have caused major problems in the past. Also when calculating exchange rates, for instance, that you were able to transfer a few tokens before the calculation and things like that. So if you see this, that the balance is queried either of tokens or of ETH, always think about if this becomes a problem when a user just manually transfers tokens to the contract, or if this is properly handled. I mean, it's not always a problem. It can be that these tokens are just lost or just transferred to all depositors, which is generally fine, but it can cause major problems. So these were a few mental heuristics and common things to look for when you as a developer or you as a security researcher or even as a DeFi user that just checks the code on Etherscan looks at a smart contract. In the GitHub repository that I linked here, you can also find all of these heuristics and also a few more. And you can also use that when you are developing yourself contracts or when you are looking for vulnerabilities yourself in a contract to use basically as a reference sheet and to check if you find one type of these vulnerabilities or attack patterns in the smart contracts you are looking at. Thanks a lot for your attention.
Thank you so much, Roman. So there's time for questions. There is one hand already there.
Yeah, thanks for the presentation. It was very interesting. You seem to have some experience with C4 audits. So for people that also want to kind of like participate in these type of contests, what advice would you give?
Yeah, I mean, I think for C4 specifically, so basically first you have to, you have to get to a certain level to just find the basic vulnerabilities. But afterwards, like I said, C4 is kind of special because your payout and your rank is determined on how many other security researchers find the vulnerabilities. So I would try to really focus on finding rare vulnerabilities. Try to get creative, maybe use a few of these patterns. I personally used these in the past to get attack ideas. And a few of the vulnerabilities that I've shown here were actually solo findings then on C4. I mean, they weren't so obvious like here on a large slide in font size 20. They were more hidden. But for C4 and this kind of contest format, my recommendation after you have like the basic security knowledge and participated in CTFs is to really try to get creative, try to think about how could this contract be exploited in maybe even some exotic ways, and this usually helps a lot in these kind of contests.
Are there more questions? If not, then, well, thanks again, Roman. So in about 10 minutes, we'll have a talk by Amr Taki, Anonymous Engineering Paradigm, Modular ZK and Geometric Proofs. So if you're interested in that, when I talked to Amr yesterday, he asked me if I understand math. I don't know what that means in particular, but he only said to come if I understand math. We'll see what he'll bring to stage. By the way, just one kind of technical question is Robin Kunz among the attendees here? No, just in case anyone knows him, can you please send him a message to go to the speaker's room to get set up? But thank you. See you in 10 minutes. So welcome back, everybody. The next talk is going to be about anonymous engineering paradigm, modular ZK, and geometric proofs by Amir Taki. I'll only say 2 words to introduce Amir. He's a DarkFi dev. So please, 1 round of applause for Amir Taki.
Yeah, hi. I don't see the screen going on. Okay. Okay, I guess that's it then. Oh, okay, brilliant. Okay. ETH Zurich. Make that bigger. Let me just do that here. Oops. Okay, there's my presentation. It's just generating the LaTeX, and I have. Oops. Hi, thanks. Nice to talk with everyone. Okay, so yeah, so crypto is the birth of Agorist parallel economic network, and right now, transparent crypto is crypto that is fragile. So fragility, it means that in an adverse environment, it's infrastructure that cannot survive, and transparent systems, they break under pressure. But in an anonymous system, this is reversed, where attacks against anti-fragile systems only vindicate their value proposition, and it drives more and more users into anti-fragile crypto. So you have this side of crypto where there are projects that, you know, the way that they're built, that they're fragile. When they come under attack, users end up exiting from the system. And then you have crypto projects which are anti-fragile, and the more they come under attack, the stronger they become. And crypto is under attack from all sides. They're increasingly using the language of war. Elizabeth Warren last week announced that she was forming an anti-crypto army to fight against crypto. So we've really reached a new phase in the escalation of the war against crypto, and the inevitable endpoint of this fragile, anti-fragile sides of crypto is evolution into what we call a RegFi and a DarkFi. And a RegFi is a side of crypto which is meaningless, it's powerless, it's completely encumbered, and nearly impossible to use, and everything interesting is like driven into oblivion. And then there's the underground, unregulated side of crypto that is free and unencumbered to properly explore the true destiny of crypto as a major historical invention on par with the printing press or gunpowder, a new asset that cannot be is immune to seizure by the states, that essentially makes the nation-state economic model obsolete. And, you know, DarkFi, we're building, we're creating the infrastructure for this movement to stand its ground, to innovate and to push forwards. So a bit about DarkFi. You know, DarkFi is not just an L1 for ZK contracts. It's we're into the entire concept of anonymous engineering paradigm, where we see that all of the developments in cryptography can be used to construct a new paradigm of computing, a self-sovereign paradigm. Also, we have as far as I know, the only L1 which has censorship-resistant validators. So like the OFAC censorship, which happened on ETH, it can't happen because our validators are anonymous. And no trusted setup because we're using Halo 2. And then anonymous network level privacy via Tor or NIM. You can add any other transport. So, and right now, so I mentioned anonymous engineering. So, yeah, and so in particular, now, in this last decade, there has been really some huge breakthroughs in consensus algorithms, distributed systems, and cryptography. You know, ZK obviously is a very important technique, but also, you know, there's MPC and HE, and then more exotic things, VDFs, functional encryption. Even in the mathematical side, which is what in this talk maybe I'm going to explore more, we're increasingly going away from, like before, cryptography used to use a lot of simple number theoretic concepts. Now it's going increasingly more into stuff like arithmetic geometry and like advanced abstract concepts. So, so we're trying to conceptualize this this paradigm of how we construct anonymous applications. Yeah, and so anonymity actually expands the design space of what's possible. So an example of that is, you know, we made an anonymous DAO, and that was, you know, because of our experience with Assange DAO, where we raised 55 million to free Assange by all means necessary. But then it was a weird situation where we had this treasury that was on-chain, and people, you know, were participating, and it was for a political prisoner, so there's a lot of risk for people there. So then, and not only that, but also we were participating in an auction to bid on an NFT, but our treasury was on-chain and completely public. So it just led to this very inorganic situation where nobody wanted to bid against us. So it just completely broke the game theory of the entire thing. So that's why we made an anonymous DAO. And, you know, if, for example, I give the example of voting in the anonymous DAO, you know, you create a vote, which is you make a commitment using a homomorphic commitment scheme, and then people post that, and then at the end, somebody comes and adds all them up together, and they publish a proof of the votes passing a threshold, which is set in the DAO, and then that allows the money to be debited from the DAO's treasury on chain. So already there, you can see a whole different bunch of techniques being used: homomorphic commitments, verifiable encryption, ZK proofs, anonymous protocol and liquidity. So those combination of techniques is like how you can conceptualize anonymous engineering. And in particular, in ZK, or in general in the cryptography now, we're going increasingly, I think the endpoint will be modular systems where you will be able to chain together different pipelines or different cryptography systems, or for example in ZK, different proving systems that are specialized for different tasks. So, and I was talking about this exploration that's happening now, which, you know, honestly, like a lot of the constructs we use is very simple schemes around polynomials, but there's a vast universe out there that we're only just beginning to explore. So I wanted to give example of construct that can be used for set proofs. So there's another talk after that's interesting about that. But for example, if I show here, this is a circuit layout, and you can see the big vertical green column, and that's a lookup table. And unfortunately, when I use that lookup table, it forces me to it forced me to double my circuit size, so I get all this wasted space that you can see below. So that's kind of awkward, especially for smaller circuits. So one idea that people are talking about is that you can do curve trees, which is a elegant construction. But the main slowdown in curve trees is you need an elliptic curve inner product proof, which is a Pedersen proof. And so what's interesting is there is this paper, which is called Zero Knowledge Proofs of Elliptic Curve Inner Products. And in the paper, he says, this is in the intro in the second section, he says many discussions of elliptic curves, so this is by Liam Egan, by the way, many discussions of elliptic curves avoid delving into the details of how the group law is actually derived. So a lot of cryptographers, or a lot of people in crypto in general, they're using this group law of elliptic curves, but there's no motivation for where did that group law come from. Preferring instead to define the group law in terms of an opaque collection of axioms, and it's not apparent why these define a group, but for the purposes of programmers and cryptographers, they treat the elliptic curves as a black box, and they typically don't have a deeper understanding. So this computational-oriented view of elliptic curves is the starting point for zero-knowledge proofs of elliptic curve operations have tended to be defined. So, however, using the Picard group, one can show that the collection of curve points sum to zero by demonstrating the existence of an element of a function field of the curve and how it intersects these points. So this asymmetry between what is necessary to compute and what is necessary to verify computation was carried out correctly is fundamental to computer science, and reframing other problems in this way may lead to more performant zero-knowledge proof systems. So I found that very interesting. So I'm going to talk a bit more about how this is constructed. So an important problem in number theory that people talk about is, okay, there's a prime number that is equal to the sums of two squares. Okay, how can we find all of the set of numbers that have this property? And maybe you can set it to a specific prime number. But one way to do this is actually to view it not as an equation over the rationals or over the integers, but to actually view it as Q adjoint I, where we can split it into the product of these two factors. And people who know this stuff will know then you can conceptualize it in terms of prime ideals. And then there's a very elegant proof that you can use to say, okay, these are all the numbers that fit that factorization, x plus iy, x minus iy. So this is broadly, I think this is called Pell's equation, but it's a broad class of problems that mathematicians like to think about in number theory. But then a crucial part of this proof is that you need to be able to guarantee that whenever you have a number alpha in this field, that it can be factorized uniquely. So that's when we start talking about unique factorization. This becomes like a very important problem in number theory. So there is this concept of a Euclidean domain. So Euclidean domain is like as you know with normal numbers. So I put this equation at the bottom. But another way to look at this is that when you have a number alpha and when you have a number beta and when you when you do alpha divided by beta, then the remainder will be some fractional amount that is less than 1. So, I can actually give a diagram of that here, and you can see if I zoom in. So you see this is the field that is Q adjoined with square root of -3, and if I where's my mouse? How do I get there? Oh fuck. One sec. Shit. I need to be able to move my mouse to that screen, but but it's okay. No. Okay. Should work. Yes. Okay. So if I put my mouse here, then you can. So just to explain, this is a lattice of all the white things are the actual integer points in this field. It's like a generalization of integers to this field, which allows us to kind of do similar things as we do with integers. And so then we can say, okay, is every point in this field close? What's the closest point there? Is there a closest integer point? So in this, what the fuck? What the fuck? Where's my presentation? Okay, cool. So yeah, in this equation here, the equation at the bottom, it says that, okay, when there's alpha and there's a beta, so for example, if alpha was the number 10 and beta was like the number 3, then there is some integer, like for example, the number 3, such that 10 is equal to 3 times 3 plus a remainder. And that remainder would be less than the number 3. So as I said, if you rearrange that, you can also think about that 10 divided by 3, and the remainder would be 0.333, which is less than 1. So when we look at it in this lattice here, we go, okay, all of the points in this plane, is there, like, in this bounded region, are the numbers less than 1? So if I move my mouse, you can see the top calculation, which is calculating the distance or the norm, you can see is 0.5. And as I, let's see if I remember how to do this. Oh yeah, as I increase the numbers, I get to this one, which is 15. And if I put my mouse here, you see it's still 1. But as soon as I increase it here, then now it's greater than 1. So this field stops being Euclidean. It loses that property. And so then, in the number fields, then we can start, because it's a Dedekind domain, then we can start to look at, okay, we can't use this Euclidean property to prove that there's unique factorization, but we can actually look at it in terms of, we can actually look at it in another way to see, is this domain principal? And so then there's this construct called the ideal class group, and what that is we define an ideal basically as a principal if it can be if there's this if the ideal is principal, then they're equivalent, and so if the size of this group, so when I look at a number and we look at the factorization of that number, we will look at it not in terms of numbers, but in terms of this construct called ideals. And so we want to be able to see that it can be factorized uniquely by looking at, can it be factorized in terms of ideals that are principal. When we say principal, it means defined by a single element, which means then it can be the factorization of a bunch of elements. And so we define this property of principality, and then we look at like the total deconstruction of all the elements. in this field, and we quotient it out in this equivalency relation by the set of ideals that are principal. And so then we can actually look at, okay, what's the size of this group? And if the size of the group is 1, then we know it's a principal ideal domain, and so therefore we know it has unique factorization. But if it's greater than 1, it tells us how far away does this field deviate from being a unique factorization domain. And so this is a construct that people use in cryptography for like unknown order groups, for example, like Chia, they're using it for their thing. And actually, and the way that they define it is you have these tuple of 3 integers. And so actually this group that I just constructed, which is a very algebraic group, there's actually a computational way of defining it. And so you can construct this ideal class group where there's an equivalency between these tuples of integers that represent a type of quadratic form where you use matrices from this group called SL2, and this group is defined by forms of it has 2 subgroups. One subgroup is of order 4, so it's S, and you see it just does a rotation along like by 90 degrees, and you see S inverse does a rotation in the opposite direction. And then the other one is T, and T is an infinite size subgroup. You can see this is T going in that direction. You can see it's T going that way. So if you look at the tuple which says A, B, C, that's the coefficients of the quadratic form. And so there is actually, for every quadratic form where the discriminant is the same, which is -12, then there's a way of doing certain operations where, you know, I mean, like, I won't do it here, but there's a certain algorithm that you do that if you give me any tuple that represents a form, you will always get a unique representative of that class. And actually, this abstract thing can be computed using those quadratic forms, and you can do a lot of cryptography, interesting cryptography with it. But this construct generalizes to elliptic curves, and you might know this from pairings. It's used a lot in pairings, the divisors. And so broadly speaking, you have a function that's defined over an elliptic curve, and you can construct these divisors that are a representation of the zeros of a function, and you know that these divisors, when they can be represented by a function, we call them principal, but when they don't represent a function, they're just normal divisors. So again, we construct this class group where divisors are principal if they can be represented by a function. And so you can do a lot of interesting things in that. But one of the property which you can actually compute using resultants is this Weyl reciprocity, where the f of diff g is equal to the g of diff f. And so what you could do is you can construct a protocol where the verifier gives you a random line that intersects your function that you're trying to prove is a function that has these zeros. And if this function has these zeros, then it means that those points on the elliptic curve, they add up to the identity. And so that is an interpolation of those points. And so you know, there's this resultant, and you can see that it's got this dualism, symmetry property, which happens a lot in geometry. So if you take, for example, your function that you're trying to prove, interpolate these points q1 up to qn, then if you calculate the resultant on f and g, you will see that f of the zeros of g is actually equal to g of the zeros of f. And so you have this identity that you can use where I have a function f with zeros of that I'm trying to prove has zeros of q1 up to qn, which then means that q1, the sum of q1 up to qn is equal to the identity on the elliptic curve, which then you can use to construct in a product proof, and then what the verifier does, they construct a random line, which has 3 zeros, because that's a line going through an elliptic curve. And then I evaluate my function f on all of those zeros, and then we check if it's equal to the line evaluated at my zeros. And so then that's the protocol. But actually, we can use this thing called discrete log, which, if you look, the discrete log is equal to differentiating u and divided it by u, but it takes that statement, which is multiplicative inside of the brackets, and it turns it into an additive statement. So then that statement, which was multiplicative, we can actually make it more efficient by turning it into an additive statement and making a statement about the structure of that group. And then you can use that to construct an elliptic curve in a product proof. And it's interesting because also it allows us to construct more abstract statements inside of our ZK proofs. So for example, you can construct statements about divisor class groups inside of the ZK proof. And if you can do that, then potentially you can model things like hyperelliptic curve divisor groups, which have an unknown order for genus 3 or above, but genus 3 is recommended. And it's part of this trend, which I think is very interesting inside ZK, which is about extending the operators the developers have access to inside of ZK. Like right now we use addition and multiplication, and you can extend that with custom gates, but having access to potentially more high-level properties is interesting. And so the ZK development itself, or this paradigm, is fundamentally algebraic, and so part of that is like, how do we construct tooling which allow anonymous engineers to construct an application and then schematize it and formalize it and be able to implement it. And so that's also part of that investigation, which we're still very early in terms of how do we build or construct tool chains or compilers that will be able to do the optimization of circuits. And there's a lot of stuff about like dependent types and type theory, etc. Because I showed you that table earlier, which had that row, and there is a gadget, and I snap it in, and it's a fixed number of rows. I can't optimize it, and also I have to add like a certain number of columns, and I can't use less columns. So all of that optimization is done by hand. It's predefined in the libraries. So all of the tooling is very primitive. So and so all of this tools or techniques are things that we can wield, that we can use to hack and to construct applications. They give us a huge amount of power. And our thesis that we published more than 2 years ago is we're seeing it happen more and more constantly. The really necessity is going to drive the value proposition of Darkfire, which and like our thesis is just being vindicated more and more. Like it's at this point it's practically inevitable that, and in that case, like Darkfire will be strong market leader. Our triumph is guaranteed. And yeah, I leave you with this quote by Satoshi, who gifted us free software money. Thanks, everyone.
Thank you, Amir. I guess people can find you here in a hallway in case they have questions. Yep. So thanks, everybody, for being here. Next up, we have... Whom do we have? Can you actually... So next up, we have a gas-efficient zero-knowledge set membership protocol presented by Veiko and Andrea. So please, one round of applause for Veiko and Andrea.
Go with the clicker and I'll just go there.
Is this the...
Yeah, so you can stand like in the center of the room.
Is this
yeah, I'll join after he finishes.
Okay, hi. Hi everybody, my name is Wei Jie, and my colleague Andrea from Geometry. How's everything good with the video? Oh.
Hi, it's on.
It's on? Are we good? Testing. Okay. Testing 1, 2, 3. Okay, hi. Thanks so much for coming. My name is Wei Jie. That's Andrea from my colleague Andrea. We are both from Geometry, and just a brief background is that we are VC invested in startups that are deep into cryptography and mathematics, and we're on the research team. And this is our latest project called Semacoq, which is something that we built to address a problem that we see in the EVM and Web3 space, is that in many privacy applications we see today, we have to choose between choose 2 out of 3 of these things. So just a bit of a correction here, it should say low cost. So in many applications where you want to insert an identity on chain so that you can prove membership of your identity without revealing which one you are later on, you have to choose 2 out of 3. So for example, if you choose to have low cost deposits but high privacy, you're going to trade off prover efficiency, which means that you're going to take a long time to generate proofs. The second option is that let's say you want high privacy, but you want to have decent prover efficiency. What is going to happen is that you're going to be using ZK-friendly hash functions. But if you use ZK-friendly hash functions, you have to pay a lot of high gas fee at the start when you deposit your identity. And that's because the ZK-friendly hash functions cost a lot of gas. You need to do it every time you perform a hash to compute a Merkle root, and that's why it's expensive. And the third option is if you have low-cost deposits, and if your prover time is efficient, what's going to happen is that some applications outsource the proof generation to a third-party centralized server, and that means that you lose privacy. And in certain applications, that's not acceptable. So what do we do with Semacoq? So with Semacoq is a gas-efficient ZK protocol for set membership. And the key benefit that Semacoq brings is that inserting identities to your on-chain accumulator is 90% cheaper compared to using traditional techniques of Merkle trees on-chain. The gas cost is 68,000 per insertion. Proving time is competitive with ZK Graph16 proofs on-chain, and it's very similar to to Semaphore, and which uses Merkle trees, except that the gas cost is cheaper. So the first benefit is lower gas cost. Second benefit is that with Semacoq we use advancements in lookup arguments such that you can perform pre-computation of proof data. And if you combine that pre-computation with private information retrieval, you can get better UX for users because the bulk of the proof generation could be done ahead of time or in the background of a client application. And if you choose to use PIR to privately retrieve proof information from a third-party server, that can be done without revealing which member of the set you are. And lastly, another benefit of Semacoq is that we don't need a new trusted setup for every circuit or every instance of Semacoq that you have. You can just use a phase 1 trusted setup output, which already exists for Ethereum. Okay, so back to basics about what exactly is a set membership proof. So let's take a really simple example where Alice knows secret numbers 1, 2, and 3, 4, and Bob knows his secret numbers 5, 6, and 7, 8. The public leaf or identity commitment that Alice owns is a hash of is a hash of the values that she owns. And the public leaf that Bob has, it is the hash of 5, 6, and 7, 8. There's a bit of an error here. It should be Alice knows 1, 2, and 3, 4. So we want Alice to be able to prove that she knows her secret numbers, 1, 2, and 3, 4, without revealing that she owns index 0, which is the first element of the set. So with semaphore and semacoq, you can do this with ZK proofs. The key figures behind this is that with semacoq 68,000 gas, when you produce a proof, it takes roughly 15 to 20 seconds in total on a slow laptop. It could be faster on modern hardware. And proof verification in semacoq is 305,000 gas. And this is regardless of the capacity of the set. So the lower bound for semacoq is 1024, and the upper bound is the limit set by the trusted setup output to the power of 28. And so traditionally, and before I go into the details of how we do, before we go into details of how we achieve this, I'm just going to give a bit of a brief a refresher on how existing approaches use Merkle trees to accumulate these leaves. So we have this, we have a function on chain that computes a Merkle root, and this involves computing multiple hashes. So each node is a hash of the 2 nodes below it, and you hash it up to the top of the Merkle root. And because for applications like semaphore, you use ZK-friendly hash functions like MIMC or Poseidon. Each hash is around 20,000 to 28,000 gas. Multiply that by the depth of the tree, you have to pay like 1 million gas to deposit if your capacity of the set is 1 million, for example. But with semacoq, we use a different technique, and I give the floor to Andrew.
Yeah. So I'll speak roughly about how we achieve this and which techniques we needed to use. So first, natural approach to changing the Merkle trees is like with KZG commitments, and those commitments are very good and used widely today, as I guess all of you might heard for them. So you have very nice properties of like additive homomorphicity, and you can compute a lot of stuff directly on commitments. So we are using like Ethereum-friendly curve BN 254, and this will allow us to very efficiently update the vector that we store in the chain. So now, instead of having the whole very deep Merkle tree, which Vijay was explaining, you have just this one vector of commitments that you need to update. And you can do it very efficiently with just a few elliptic curve operations, which gets very cheap. Because you don't have to do any hashing or no repeated work. The only problem is that since we want these vectors to be very large, like 2 to the 20, even 2 to the 30, you cannot store this like Lagrange basis commitments in the contract. It's very expensive, and you need to have the access of them in order to compute to derive next commitment. And here, like maybe like if you just look at the documentation or code, it can be confusing that we actually have some Merkle tree, but that's just like Keccak Merkle tree, which allow whoever inserts the identity to prove that they're using correct Lagrange basis, and we don't need to store those elliptic curve points in the contract, which again makes this very, very cheap, like 68K gas instead of 1 million and something for depth 2 to the 20. And this is like constant, so even if you go to the larger group, it still stays the constant. So I'm not going to go very deep into how this math works, but you just have some like default 0 value of your like position in the vector, and you can very easily update it with all these additive homomorphicity things, which is again very cheap in the contract. And now what is the difference between this, like the most useful and like maybe the most broadly used application semaphore? So the whole idea of ours was not to change a single thing in the semaphore API. So however you used your application now, it stays the same if you switch to using Semacalc. Like there is no new values, everything stays the same, but the machinery underneath is totally changed. And it's based on a few techniques that that we like modified and optimized a little bit. So first of all, we used MIMC hash. And today the most popular hash is Poseidon, and it was just because like MIMC was easier to do with what we wanted. With just some small engineering effort, you can switch to Poseidon if you are considered about MIMC security or something like that. And three main techniques that we're using are calc plus lookup arguments. That's like the new work, which is very popular and very useful from the like set of these lookup argument papers. Why is it important? It gives us zero knowledge, and we had to change it a little bit on the IOP level in order to make it compatible with our custom prover. So our custom prover is based on like similar techniques that you see in Plonk, like with all the Lagrange bases, and the IOP is very similar, but it's very customized to just proving this MIMC round hashes, and you don't need the whole Plonk machinery as like lookups or a permutation argument. So you just have a few polynomials that you need to prove, and that's why it also makes it very fast. And then it's compatible with the calc plus modification that we did. And finally, as you might know, the Grot16 is still very popular because its verifier is very cheap in the contract. And to be honest, it was very hard to beat the Grot16 verifier in gas cost. Like just by counting the pairings, it seemed that our approach will be much more expensive. We took this Halo 2 multi-open argument, which is similar to Splunk, and we also like modified it a little bit and pre-computed some stuff. And then we finally were able to, even with more pairings, to get to the same cost as Grot16 verifier. So now when you look at the cost, we save like more than 1 million gas just on the insertion part, which I think is very good result. Like more than 90%. Okay, so this calc plus argument and all this new lookup work is based on this stuff, like when you need to pre-compute something. And we also have to do that, of course, in order to run this calc plus. So this pre-computation part takes a good amount of work if you want to set up everything. But then your proofs are extremely fast. Like it's roughly 50 milliseconds, but probably can be like it can probably be even less. And it's constant. Like it does not depend on how huge your group size is. Whereas trying to do Grot16 of Poseidon to like 2 to the 30, like with 3 of depth 30, can take very long time. Whereas here, it's just constant after you do this pre-computation step. So I'm not going to go into that pre-computation step. It's quite complex what you need to do with polynomials. But what we are enabling users to do, there are 2 ways how you can use it. So you can pre-compute those stuff, and it's not just pre-computing once. So once the group gets updated and you want to be like on the live set and use the biggest anonymity as possible, you also need to like again pre-compute some stuff in the commitment. And sometimes if you want to have like very light client, that can also be the problem. Like maybe you need to run its secure extension, you need to download some data, you need to store somewhere, you need to make sure that it's secure, because anyway, if somebody even learns which member you are, even if they don't learn your secret, you're kind of losing privacy and it's breaking the zero knowledge property. So we did something with this new library Bliss, which enables like private information retrieval. So there is a bunch of techniques based on this like vector commitments where you can pre-compute a bunch of stuff and like update very efficiently on commitment level. So we also provide you with the server, which does whole pre-computation and updates all the commitments accordingly, as like that's the only part in the system which should listen to blockchain events and update stuff. You as a client don't need to care about that. And this server is completely trustless. Like it's just working with commitments, and it cannot do anything with your identity maliciously or even find anything about your secret. It's all just public data. And then what you can do, you have like this very nice API that the Bliss allows you, and we just did a few modifications. So you can have very light client where you can just download all these like new data and like new quotient polynomials that you need for the proof, and you do it completely privately. So nobody learns nothing about your index even, which also like breaks the zero knowledge property. So you can do it very like efficiently. It does not affect your proving time, and you have like kind of a blobs from which you can download stuff based on how huge group you want to be. And when you put this all, just to say again, so I guess that membership proofs are still one of the most used proofs currently, and we are able to achieve 90% gas savings, even more. We allow like this constant proving time, and it's all based on very well-known arguments that we just did some modification on. So yeah, what do we want to do next with this? So it's just now about building applications and adopting the Semacolc, trying to see how it will be in the wild, like building tools, building maybe some other use cases. But as I said, we try to have the same interface, so there is nothing new on a use case level. It's just good old membership proofs that we're using. Maybe gas can be optimized even more if needed, and like just building clients around it and maybe some secure extension for keeping secrets and stuff like that. We still haven't audited, but that's something that we have in our plan. And yeah, like you can find all the links, documentation and implementation. And if you're interested, feel free to reach us. We are very happy to help someone integrate this in their current system and see some good performance optimizations. Thank you very much.
I think we have some time for questions.
What?
I think we have time for questions.
Amazing.
Oh, yeah.
Thank you so much, gentlemen. There's time for questions. So if there are any questions in the audience, please raise your hand. We'll give you the mic. If there are no questions, then, well, thank you again. And in a couple minutes, they will actually join us again for a panel about exploring the future and potential of zero-knowledge technology, moderated by Lawrence Kirk, the gentleman who was relentlessly running the entire workshop stage yesterday with like two consecutive workshops. So please stay here with us, and in 6 minutes, I will see you again at the panel. Welcome back, everybody. So for the next 40 minutes, we are going to discuss a very important topic. We're going to explore the future and potential of zero-knowledge technology. A panel moderated by Lawrence Kirk, joined by Amir Taki, Veiko, Ignacio, Manzur, Yuda, and Artem. So please give it away to the gentleman here.
All right, hopefully you can hear me okay. Yeah, good. All right, thanks everyone for coming out this morning. We've got a very interesting set of people, extremely interesting topic to discuss. So I think it's best if we just, first of all, if you could just give your names, where you're from, and introduce you to the audience. So,
I'm Yuda, and currently I'm a doctoral student at ETH Zurich, and currently I'm a member of the development team of HyperOracle. We're working on ZK oracles and generating automatically proof instance. Thank you.
Yeah. Hi, my name is Wei Jian. I'm at Geometry, and I'm on the research team as a research associate. Previously I was at EF working on applied ZKP, so thanks for having me.
Yeah, hey everyone, my name is Ignacio. I'm a cryptography researcher at Nethermind, and currently I'm focusing on zero-knowledge proofs and their security mainly.
Hey everyone, my name is Artem. I'm part of Aragon research team, focused on ZK. Currently we're building some private voting solutions, but we also look into private DAOs and related topics. So yeah, also a bit interested in ZKML. That's my little side hobby right now.
I'm Amir Taki from DarkFi, which is an L1 for anonymous engineering. We have our testnet released now, which has generalizable, programmable, anonymous smart contracts.
All right. Thank you, panel. All right. So I'd just like to start off. If you could just think about, the last 6 months, a year, think of any new application in zero knowledge or new piece of research that's really excited you that perhaps maybe the people wouldn't know about. So you can go in any order. So anybody who has a, you like to start off? Yeah. Good.
Okay. I mean, it's a big news not only for our community, it's actually for the order what people are paying more attention on, let's say, artificial general intelligence and large language models. So how to remain the confidentiality of the user data when during the inference time, I mean, it's really important right now because due to the GDPR protection or such kind of violations always happens. So, I mean, particularly we can talk something about maybe ZKML. So how do we use ZK as utilization to protect our user data? And what is the situation of it? I'm quite interested in that.
Yeah. I'll certainly come back to ZKML in a second. Yeah.
I guess for the past 6 months and even past 1 or 2 years, we've seen a lot of focus and development on, I think, scaling solutions. And I think the technology and the fundamental approaches that teams have been doing have been around, for example, recursion or around ZK VMs, using different techniques. And all this has been focused on trying to scale blockchains and trying to scale Ethereum on L2. And I think a lot of interesting teams have started to use these building blocks and build things beyond scaling, such as identity and even ZKML. So I think that's very interesting. And I think there's so much has happened in the last 6 months to the last 1 year. It's very hard to keep up. I think, yeah, so there has definitely been a flurry of activity in these areas.
Great, thank you.
Yeah, actually, it's kind of funny. I was kind of a mix of both previous answers in the sense that very interesting application of ZKML kind of at the intersection of the validity proof of like a certain computation, the privacy preservation of the data, and also the heuristic optimization of machine learning. And one application I was particularly interested in as well is in identity management, actually, and things like ZK credentials and those type of things.
Yeah, it looks like ZKML is the hot topic right now. I guess the reason for that is we just learned about what are the capabilities of big language models about half a year ago, so it's perfect timing for the question. And actually, I already know that, well, for me, part of the problem is that we also need to prove that we did inference correctly to put the model on chain, for example. And right now, the big businesses are making big decisions based on the outputs of these models. So proving that the model was run correctly is quite important. And actually, know there is an effort for doing this with GPT-2 by Daniel Kahn. So yeah, I'm very, very interested where this goes in the future.
Thank you.
There's a common trope in sci-fi, which is contact with an alien civilization. For example, in The Expanse, when they first discovered the ring. And all of this crypto tech, which is coming out now, is honed powerful techniques that is opened up an expanse, which we're only just beginning to peek through the door or scratch on the surface. And there are so many things that we want to make that is really crazy. Like, obviously, there's stuff around markets and building anonymous digital marketplaces. But we also made the world's first fully anonymous DAO, anonymous on-chain treasury, anonymous voting, all the participants anonymous. And that was from our experience with Assange DAO, where we raised 55 million to free Assange by all means necessary. But then it was like a public on-chain treasury where all the participants were public for a political prisoner. So it really just didn't make sense in a transparent context. And then second of all, we were like bidding in a auction, and everybody could see our treasury. And the fact that everybody could see it meant that nobody would bid against us. And it just completely broke the game theory of that auction. So anonymity really expands the design space of financial engineering. And, you know, there's even other stuff like online marketplaces, which are completely anonymous, where you can buy and sell anything, where you can exchange crypto, where you could like local Bitcoins, completely anonymous. Like all of the crypto infrastructure we should be building peer-to-peer and anonymous. Also, there's a load of privacy projects going, oh, we're building privacy tech, but they're on Discord, and they go, oh, link your social media to like authenticate. And it's like, what? Like, how are we going to like really deliver the true promise of crypto when we're not actually building the self-sovereign infrastructure and consuming our own dog food? So we made our own anonymous chat. It's the most anonymous chat on the market. There's nothing that exists like it. All the messages are unlinkable. There's no identity. Like, not even Signal or anything else comes close. We made an anonymous task management system, and we're going to migrate away from GitHub. So we move into a fully anonymous peer-to-peer paradigm. And also, another really cool topic is information marketplaces. Like, you can make a marketplace where people can buy and sell information. Like, you know, like, oh, you have Hollywood movie or secret document, and somebody says, oh, this document's this thing. And you go like, okay, prove it. And then you can have a protocol where a certain random portion of the file gets decrypted, and then it authenticates the claim of what that info is, and then everyone bids in an auction, and the person that bids on it gets the decryption key. And then essentially, you've just destroyed the business model around secrecy for corporations and trade secrets. So it's just so exciting. Like, there's so much to explore. Like, and we need as crypto to like organize and mobilize and work towards that goal, because this is a major historic invention. Like on par with the printing press or gunpowder, it literally renders economic.
Can I move this on a little bit, Amir? Sorry, can we move on? I think we've sort of covered that quite well now. So I'd like to go on to the ZKML side of things, because you know, if you want to get all your buzzwords lined up now, you're going to do zero knowledge and machine learning. Now, obviously, there are problems with this. So doing the inference part, you know, the ZK can do this, but things like, you know, backpropagation, as far as I know, this is not really feasible. But I saw a recent a thing at the ZK Summit where they were doing weightless neural networks, and this was a this seemed to be promising, but I don't know enough about this to judge this. So Artem, can you give us some insight onto that?
I guess I'll give a bit of background. So I was part of the Zero Gravity team on ZK Hack, the winning solution. And what we did, we tried to reimagine how neural networks work. So instead of trying to fit in neural networks into ZK by doing some truncations of the weights, because right now, so that you understand, neural networks work using floating point arithmetics, and what we use in ZK is more field arithmetics, which just don't really work together. There are ways around it, but they lose efficiency and they lose precision, so essentially you get worse models after doing that, and it's very hard to do it. So we tried to reimagine the solution by essentially going away from floating point arithmetic altogether and using one of the previously proposed solutions of weightless neural networks, where you use lookups to optimize how they work. That's what we built. It worked on NIST, but we had about 2 days to make it happen. And right now, actually, there might be future work with the Ethereum Foundation on that, but I cannot say much on how this will develop. But also, in general, what people don't understand is that it's not enough to prove inference. Actually, you need to prove the whole training process, because it has been shown that an adversary can always corrupt the machine learning network from inside when they train it, so that they can always control what it outputs. So it's actually a very big problem for the space, that essentially you need to prove that GPT was trained correctly, and it's already hard to train GPT like that. Imagine how hard is it to prove it. So yeah.
Okay. Sorry, go on. Yeah.
So I also wanted to put some remarks here. So everything you mentioned here is like proving something is like training correctly. Like it is like a trade-off. Sacrifice your utilities for some preservation of the confidentiality or correctness. And most often, and in the other occasions, when we talk about ZKML, we care about the inference, right? So imagine you're talking with the chat GPTs. You want him to compose some letters for you, but actually you don't want to really review what you want to him. So actually what we get here is like, okay, inference this correctly, but do not review my information. Mm-hmm. So actually this is a little bit different from proving, okay, this inference is correct, because if in that case you can like employ this, you see, corrected output as your witness, something information knows to you. But actually, and this is the case in most of the ZKML applications like EasyKL and such kind of stuff. But the question is like, first, if you really want to inference something and output space is really huge, and you cannot do any heuristic optimization inside it, and it will be questioning that which statement you want to prove, right? And another question is that I need to mention is about the feasibilities. I do not know too much about the training time, but for inference time, if we cannot do prove for more than 10 million parameters and the same level of blobs, actually it's not a big model, right, in today's view. But it would take like maybe more than 10 minutes to do so, and which is not affordable really in practice. So that's we're gonna figure out maybe in the futures, both from with joint designs, both from the lower level architectures, operators, and the algorithms and the design as higher level. Mm-hmm. So that's all.
And maybe just to add a bit more, like this is another way to think, and the third way is to add fully harmonic encryption and say that what about we want to prove my, like do inference on my private data without the other person knowing what I'm actually doing inference on, but they have the model, so that's like a third level of complexity. Mm-hmm. And I think this is one of the hardest problems to solve right now.
Yeah.
So that brings me kind of to a more general point, perhaps, in that what are the potential bottlenecks at the moment? Is there any particular things in zero knowledge that you think, well, only if we could, this particular hash function was quicker or something like that, if only we could solve that, then the whole area would open up? What do you think? Ignacio, would you like to, is there anything you can?
Maybe one remark regarding the last point. Yeah. I think something that was quite surprising to me is that many times people, because of this GPT kind of concerns about like using your information when they're doing the inference, people focus on the fact that you can render your input data private. I think what's really interesting is that sometimes in some applications you need your model to be private. Mm-hmm. And you don't care so much what the input is going to be, but you do care that people cannot know the kind of models or the weights that you're using. For example, one example I have in mind is you want to detect symbols in some network, for example, and you've figured out some heuristic way to do it. But if you tell people that's the model we're using, then they will go out their way and kind of evade that model. So that's a cool application that I want to talk about as well.
Yeah, do you want to?
Yeah, something that I'm personally quite excited about and hopeful for is for developments in hardware, especially if hardware that accelerates ZK-proof generation can be on personal devices, as well as like algorithms that can improve performance. I think, generally speaking, if you want to have privacy for users, you want to own your own hardware, you want to own your own data, and therefore you want to be able to generate proofs locally. And if you outsource that, there's always a risk of information leakage and loss of privacy. So I think I'll be very personally excited to see developments in this area.
Okay. So just to come on to that point, I mean, hardware, to get sort of having memory on hardware and this kind of thing and caching, it's as far as I understand it, it's very expensive. Are we at a situation where, the proof sizes and things like that are small enough that it's not going to be too expensive to do all this, or what is the current state of this at the moment? Does anyone have an idea?
I don't have too much information about hardwares, but I do want to talk about some roadmaps for the algorithm, or like generating a really zero knowledge proofs. Like, I think like typically we have like, if we want, we have a algorithm, some kind of accepting some language, and we want to generate proof circuits for that. And a general way to do that is that, okay, so first we translate it into arithmetic circuits. And based on this very basic pieces of gates of the circuits of what is, we call this the witness and instance, we kind of generate a very basic system for that. This is only one typical roadmap. And for the other, we kind of employ the terminology called like ZK virtual machines. Like in this sense, we gonna propose portable, maybe virtual machines or compatible programs that we can understand what we are coding about. It's not truly understand, but actually it's just take our natural programming language, like such as C++ or Rust, that kind of stuff, as the input and to generating the proof circuits. But the question is that the drawbacks here is that they bypass the procedure of, okay, we really design what is basic arithmetic circuit, so it will generate many maybe redundant or like very, in terms of nested indexing, it will requires more computational powers and more larger size of circuits to do so. So, I mean, the questions here is that first, should we figure out maybe a new, we see end-to-end ways to generate such proof circuits, because like a very interesting efforts recently I see is from the EasyKL. They do generate the proof circuits not from the program language, but from the really basic circuits, from these operators in ONNX.
Sorry, who? You mentioned someone, who?
Who?
Yeah, which?
EasyKL.
Ezekiel.
Ezekiel, yeah.
EZKL.
Ah, okay.
Yeah. Yeah, they generate the proof circuits from the ONNX, which is, I mean, some learning architecture like Caffe or like PyTorch. And so that's a good idea. Maybe we can not only do on the very basic level, we can maybe, let's say in learning, we do everything on the tensor level, right? Can we do something on this kind of concepts instead of like focusing on the very fundamental gauges?
Okay. What do people think? Is it?
Well, I think, yeah, like we're seeing a lot of different crypto techniques. So I think the destination that we're going towards is, rather than like a general, for example, ZK proving system, we're going to have very specialized pieces. And part of that is as well related to two things, which is one is the optimization, where right now a lot of that's done very manually by hand. You like predefine, or you have like certain gadgets that are like, for example, like lookup tables, a fixed number of rows, and it's very difficult. So yeah, it's very difficult because you have to like rearrange all this data, and because it's not dynamic, it's like hard coded. You can't have it where the entire tooling is intelligent enough to like generate those tables, for example, that are specific for that proof, so it's optimized. So we're very early in that sense. Like if, for example, you look at GCC, when you use GCC, the reason why it's very good optimizing compilers, there are very many different modules you can load for different architectures, so it would be specialized for different applications. Another thing is abstract operators. Right now we use like mainly addition and multiplication in circuits, and you can predefine gates. But for example, we saw Nova now, which comes from like, I think Spartan and Hyrex, but they added a fold operation. So it would be very interesting when we see, because right now everybody's learned the wrong lesson from history, which is that C is better than Lisp. But that's not the lesson from that history. The lesson is that people preferred C because it more closely matched the underlying systems they're working with. And the systems we're working with are algebraic. So there's like a different paradigm we have to construct rather than trying to create a C-like system. And I see a lot of confusion with people where they're like, oh, so it's computing the value? And I think that's a mistake because we're mixing computation and proving together, and they should be kept separate. And also a very important thing is membership proofs, because a lot of applications, when you start to build them, you see you're doing some kind of statement, which is there is this object, there's in the set of all objects, and this is a commitment to these values, and then there's this value, which is in this set, blah, blah, and you have a lot of statements like that. So set membership proofs, right now, like for the amount that we're doing, they're not like, well, they are quite expensive, but they're like kind of manageable. But, if we could abstract away that cost, potentially the usage of set memberships will become really big. And so we will get these very advanced and interesting circuits. Like, for example, they mentioned the machine learning stuff, which right now there's these big centralized models that are owned by, like these big people. And people are like, okay, well, I'm worried about my privacy by feeding this model. So, like we would like to have like our own models, but where we like pool our power and we compute it collectively. And a big part of that is
on the set membership, that's really what you've been talking about. You did you just done your talk about the gas efficient thing. Do you want to comment on where we're going with that?
I think I'm here to continue because here on the thread is very interesting.
Yeah, the other part is the set non-membership proofs, which I don't know if this is a solvable problem. It maybe isn't, because there's a result from computer science about Bloom filters, and I think it's called approximate membership query filters or something. But it's basically you can create a set membership proof which is constant, but is it possible to create that proof without having the entire set of data? So and there's a lot of isomorphic problems like related to this domain. Like, for example, like if you get two graphs, can you prove that this graph is contained in another graph? Like, is the union of these graphs have a perfect, well-defined ordering? And if you could do that, you can create like very advanced consensus algorithms that are completely anonymous. So, there's a lot to kind of explore.
Go on, Jed, do you want to pick up on that?
So I guess one simple application of set membership proofs is, or one simple development upon set membership proofs is that when you have a private application and you want to be able to comply with being excluded from a certain list of entities that you do not want to be associated with. One application or one development is that you prove that you're in the set, but that also that you're not in in that set of entities that you do not want to be part of. So there are a couple of approaches to this. One approach, which has been popularized recently, is that you use Merkle trees. Another approach that I like to see hackers build on is to use KZG commitments, because with KZG commitments, you could simply do elliptic curve subtraction, and then you've obtained the commitment to a set of entities that exclude what you do not want to be part of. So I would like to see, I think as a developer, I would like to see more research and development in this field. Especially because I see a lot of talent coming into ZK, and they're looking for interesting things to build on. And I think so take a look at the work that Andre and I did on Semacoq, where we use the KZG complements as the accumulator for the set instead of Merkle trees.
Yeah. So to pick up on this point about the operations we have, what would you like to see? In, as well as additional multiplication, what would we want?
Personally, first I'll pick up about the membership proofs, because actually we're building a voting protocol, and basically that's what you need there. You need to prove membership. But there is, in our particular use case, because we are based on ERC20 and NFTs, we need to prove that a person had NFT at some point of time in Ethereum blockchain. And there I would personally like to see connection between storage proofs that then convert to membership proofs, where you can then efficiently prove that you're a member of a set. This is a cool trick we learned, where you don't need to do all the storage proofs all the time, just convert to a friendly format and then do proofs for that. And I think KZG or vertical trees, the new popular term, would be quite efficient there. As for operations, I find that there are two levels of abstractions. One is when you, for example, program something in Hello 2 or very low-level languages, it's like Circum, where essentially all you get is multiplication and addition and some lookups, if you're lucky. But then right now languages, they're high-level languages, we try to abstract it, and I think they're doing a good enough job of just providing you almost all the tools you want. Something like Noir, and Cairo maybe, and other ones. So I think it's getting better. For developers to jump into.
All right, Ignacio, do you have anything you would like to see in that side? Yeah.
Actually, I think that's the direction we're heading to anyway. When you see, for example, how an arithmetization system like TurboPlonk allows essentially for wild custom gates, I think people have identified that this is what we need in order to solve a range of different applications. And ideally, I would like to see any possible gate. I'd like to see everything being built. In any case, I think we're going in that direction. For sure.
What about modularity? It seems that now we're getting different types of proving systems. Picking bits of technologies from others, you can pull Fry into Plonk and things sort of thing. Is that the direction we're going in? Should we be looking at that, or should we stay more insular? What are the advantages for that?
Can we talk about disadvantages?
Yeah, sure.
Potential risks, because voting is a really good mechanism, but in practice it has variations, implemented in different ways. You may vote by your quantities, but you may vote by your, let's say, stake inside a block of a blockchain. And actually, that's how proof of stake works, right? The moderators assign different verification tasks based on what you're assessed with the stakes. And here comes the problems okay, so what about that malicious users, malicious blocks, malicious nodes that have occupied a certain portion of this block? So that's because when we talk about votings, because we are always believe that, okay, so there are some malicious ones, but they are a few. So actually we can believe that the majority vote out the good choice. But the question is that in practice it is not. We can see that if a malicious user has managed to occupy more than 1/3 of this block, there's no block can be or a new attestation can be verified. It can prevent everything. And if this number is far beyond two of thirds, he can decide everything. Because himself, it is the majority. And actually, even if it doesn't reach the threshold of like 1/3, it can still like attack or steal the tokens we need that with very small slash risk. So that is the potential risk. And actually, we have seen recent such kind of incidents in MEV, but mostly it is because of some programming bugs. But
Can other people say what disadvantages they see in these areas? Would you like? I started off on modularity, but
I'm not too sure.
What limitations then do you see in zero knowledge?
I guess from my side, I'm more of like developer using different protocols, but all of them have slightly different implementations. There are too many implementations of the same thing, and sometimes someone forgets something, and it's very hard to audit all the tools to make sure that what you're using is actually secure. Because imagine there's at least 5 different proven systems, and then there are also different commitment schemes, and you can, as you said, do modular combinations of this in different ways, and everyone decides to build, like most of people decide to build their own stuff because they can do it better. But then actually, it's not like I'm not sure if everyone did the audits of that, like very thorough audits. So it's a bit like as a developer, I'm a bit unconfident about the tools right now.
Right.
What I'm using. I'll put it this way. For example, there was a perfect talk about simulation extractability, and that, for example, some tools just forgot to add a few lines, and then that's what happens.
Yeah.
I think that's really a steep learning curve. But something that's really encouraging is that if you look at events like ZK Hack and ZK Summit that happened 2 weeks ago, but a personal observation I have is that there's a lot of new developers coming to the space from different backgrounds. So some just fresh out of college and some with like more than 10 years of experience jumping into ZK because they think that this is a very valuable field. And a lot of developers are not afraid of the learning curve, and I think that's fantastic. There is a lot of chaos, I would say, chaos in terms of lack of documentation, lack of good tutorials and stuff like that. I think an organization that's really helpful in this space is Zero Act Park, which organizes workshops, summits, and online sort of like guided classes. They've done a few of those. Definitely checking them out.
I want to say a few things. I mean, precisely, I think this field is extremely exciting. There's a quantity of things to learn and explore that is maybe unheard of. The thing is, as more people like come into the field, we also need to make sure that they understand what the assumptions are on some of these proof systems, on some of these commitment systems, so that they can use them in a secure way. Because many times, as you said, they come from different fields. Maybe they don't have a mathematics background or they don't have a computer science background. And if we do not state clearly here, we are making this assumption about the security of this protocol when we use it in combination with this, and so on and so forth. Maybe people start like taking pieces of proof systems from here and here, and then it turns out that the resulting protocol is completely insecure. And we need to make sure that the tools we are building are just secure for everybody to use, and everybody understands what the security assumptions are.
On that point, there's zkproof.org that try to build standards around zero knowledge. Do you have experience? Do you follow these? Do you have experience of these? I don't know how widely used these are.
I think it's really early, and standardization is difficult and lengthy. But they do a fantastic job of bringing people together. I've seen the output of those conferences. It's very interesting. Just a general point is that I think we are precisely because we are early, the narrative in the public hasn't been set yet. So, as an example, the narrative for crypto today is not so good because you had a lot of things happen last year where it's now associated with negative things like in the past it was like black market and today it's associated with scams. But we have not seen this with ZK. We have not seen a narrative trend emerge for ZK in the general public, which is a good opportunity, because if you just talk to any person who's not a technologist about what is zero knowledge, it's very intuitive that they see that this technology can protect privacy. And I think that's fantastic, because everybody knows that the traditional system has failed in protecting people's privacy. If you go to the US, like your social security number is already on the dark web. Or like you can type in your name and find your address and the 5 addresses you lived in previously. So people know that their privacy is not protected in traditional systems, and this we need to leverage this moment to establish a strong positive narrative around ZK. Yes.
And you said about the areas that are important. I think right now already with what we have like 80% of what we can use to do a lot of the first like tier of ecosystem expansion. But going forwards from there, a very big important topic is shared computation, like or shared state, etc. So for example, and you know, you've got stuff like homomorphic encryption and MPC, etc., as techniques, and how do these techniques fit together? So one thing I have a design for is anonymous liquidation engine. So if you're trading derivatives with people and you have a position, then when your position gets liquidated, the platform needs to be able to know that info so that it can be able to claim back your position, so that it can build this insurance fund, which actually is a protection against going insolvent. So you can't do that with just purely ZK right now. You need to add in some other techniques. Like one way you could do it is you could say, oh, you know, every position has a bond and there's an incentive when you get liquidated to release your bond, but then that's capital inefficient. And so then that's when you start thinking about things like MPC or shared execution. And a lot of now there's an interest in delegated proving, so that you could have, for example, mobile phones. And the way that it does that is basically with MPC, like additions are free, but multiplications are expensive. So all it does is it uses these algorithms which minimizes all the multiplications to like one step or a minimal number of steps, and it performs the addition on the servers, and then it sends back the result to the wallet, and the wallet does the multiplications and sends that back, and the servers finish the computation.
In terms of the other sort of technologies that we could link with, what do people want to see? What would you like to? I mean, you mentioned some there. What other things would people like to see? Sort of FHE or multi-party computation, or?
I mean, if FHE becomes usable, that would be amazing. Yeah. But wait, was it Sunscreen or they're building this? So hopefully they'll be quite successful. But again, their biggest hurdle right now is zero knowledge proofs. So again, getting more efficient there would be very important. And I think this delegated proving is actually one of the key ones, because it's hard to imagine that every phone will have a hardware specific for ZK proving. So it would be a lot better if special servers somewhere have that, and then your phone just sends it to these servers with the special hardware and does the job. I would like, not on the technology side, but in general, I would really like to see a lot more collaboration between the projects, because again, the space is very new, and it's very important that it stays safe and secure, and there are no big vulnerabilities discovered after the protocols are deployed. So there was a collaboration between Scroll and Polygon Hermes, for example, trying to educate auditors, and that was a great idea what they did, because like it's projects joined together to make sure that what they're building and the grand vision is going to be secure.
Yeah, makes sense. Ignacio,
yeah, for me as well, maybe not on the technology side, but maybe more what I'd like to see in the future. I think everything is kind of a trade-off. You're essentially always in the dilemma between the efficiency of your protocol and the security of the proof system and the parameters you're choosing. For transparent proof systems, for example, this conflict is essentially between the security of your protocol and the verifier time. And I think what I'd like to see in the future is this conflict being resolved in favor of security, actually.
Yeah. Okay. I think we're coming close to the end. Shall I open it up to questions now? If people have any questions for the panel, please go ahead. You have a microphone.
Sorry, lame question, I think. So try to put yourself in the view of both the user who currently uses Ethereum or any of the L2s and who cares about their privacy, and in protocol developer who's deployed something on one of the L2s and cares about the privacy of their users, which currently is obviously horrible at Ethereum, admittedly. So what would you recommend, such kind of people to look at, like the emergent, technologies, whether that's L2s or development toolkits for the, for the protocol author, or for the user, anything that kind of catches your attention that's worth exploring, and feel free to pick just one of these positions. Amir, obviously, you would, pick DarkFi.
No, I'm not saying DarkFi specifically, but I'm saying crypto is very scammy and corrupted. A lot of these VC funds, they are beneficiaries of the Cantillon effect, where the central bank prints money and they LP it into these big funds, and they have a checkbox. Like, when you're in school and there were kids that got A's on all the exams, but they weren't particularly smart. And they go like, shiny website, check. Big team, check. Web shit, Electron GUI, check. But then you dig the fundamentals of the tech and there's nothing there. And a lot of these funds, they invested at overinflated valuations at the peak of hype mania last cycle, and then got burnt, like when these projects went nowhere, and their founders have like 24 million mansion in Lisbon and a private jet. So don't look at the mirage of where everyone's looking. Look for teams that have a strong culture, that they have an idea or a vision of what they're doing, because small teams are like, one good dev is better than 20 shit devs. So that's what you have to look for, is find those corners where they exist in crypto, but they're not the people that are competing to get the money, who know how to trick people, trick the big corporate.
Anyone else to?
I guess, yeah, for me, as a developer, if you just want to integrate with something already working, and that's probably the best approach for you, just, again, Google what you want, and or ask one of the experts, and we'll suggest you exactly what you need for the use case, because there's Semicloak and other good solutions which you can just plug and play, and you don't need to do any ZK, and that's actually good for you, because you can, if you mess up, that's very bad. If you're more hardcore, yeah, like find languages. There are actually about 12 languages. The good to start is usually Circum, because it's old and it's been there for a while and you'll understand how it works, but then it depends how hardcore you can get. You can go to Hello 2, or you can go to full-fledged solutions like, again, Noir and all these fancy languages that just try to abstract it as much as they can.
Okay. Probably got time for just a quick question. Oh, no?
One more question? So I think that one of the reasons why there was such an enormous productivity in the crypto space nearly a decade ago, that the cryptographic toolbox have just boiled down to these two primitives, the hash function and the digital signature, that you need to trust, and everything else can be built on top of those, and we got like marvelous things like Ethereum. And the ZK technology seems to be flowering with primitives, like we have range proofs, we have membership proofs, and so on. And there's always this problem that even though we have some universal primitives, but they're not really efficient, and somebody clever always comes up with something specialized that does it much cheaper and better. And do you think that there's a way out of this forest, and we're going to see some crystallization into some small set of primitives that people can trust, and then people who don't even understand those primitives in depth but know what they actually achieve
in 10 seconds.
can build on top of those?
No, we should go in the opposite direction. it's actually a good thing. It's the architectural level where we need to put the focus, not on the cryptographic algorithmic level, because they have trade-offs, and it's not good. Like, for example, even now there's like functional encryption. So there's a lot of really interesting things with that. It's, for example, that you can create these encrypted field elements, and you can only perform one function on those encrypted elements to get a result that is decrypted to a key. So, but then, and that uses a number of different, like, I mean, there's different constructions, but one I was looking at uses a number of mathematical techniques, but even those techniques are modular, and so you can use them in different.
Time. Sorry, we're going to have to finish, but please, everybody, thank the panel.
Thanks a lot to the panel. If you have further questions, you can still talk to the panelists, I guess, outside. Thanks a lot. So I will take over from here. Happy to be here. So we're just preparing our next speaker. Give us one moment. Can I introduce him? Yes, sure. Okay, so I'm very happy to welcome Pablo Baiocchi here. He's financial engineer at Sentiment. I actually got some socks from you yesterday. Perfect. So Pablo is specializing in Uniswap v3, and he will talk about the back-tested approach to optimize Uniswap v3 liquidity. So please give a hand to Pablo to welcome him here on stage.
Hello. Can y'all hear me? Okay, good. Well, my name's Pablo. I work at Sentiment. And today I'm going to talk about using on-chain data to be smarter about liquidity provision in Uniswap v3. So, overview of Uniswap v3 and its liquidity pools. So Uniswap v3 is an automated market maker. It allows trustless token swaps between swappers and the pool itself. With the new thing about V3 is concentrated liquidity. So the concept of concentrated liquidity, I think, makes more sense if we look at Uniswap v2 and what Uniswap v2 did, or it still does. So in Uniswap v2, liquidity providers provide liquidity to the whole spectrum of prices. What does that mean? So if you provide liquidity to a Uniswap v2 pool, what you're doing, you provide liquidity to, in an ETH USDT pool, for example, you're providing liquidity to the case of 0.01 USDT ETH and 100 million USDT ETH, which is great in the sense that every single price can be traded, but it also has some issues, which we're going to look at here. So the problem is that you assign liquidity to unlikely prices. So we can all agree that in the medium term, short term, ETH is not likely to be worth 0.01 USDT or 100 million USDT. So there's liquidity there and it's not getting used, and then where the price action is happening, there could be more liquidity. We could be using that liquidity from the edges and we're not using it. And that's pretty inefficient because that's making for more slippage. So big swaps are moving the price more than they realistically should. So in comes concentrated liquidity, which fixes that. What concentrated liquidity does is when a liquidity provider provides liquidity, they have to set the price range for the liquidity. So going back to the exact same example, instead of providing liquidity essentially from 0 to infinity, you could provide liquidity from 1,500 to 2,500. So now your liquidity is more concentrated. It's a lot more useful because it's a lot closer to the price action. And since you only make money when the price is within your range, then everybody is sort of wants to provide liquidity where they think the price is going to be. They want to provide liquidity close to price action. And that's great because now there's a lot more liquidity at price action and there's less slippage. So everything's fixed, right? Not so much. Because if we look at this entirely from a liquidity provider's point of view, it makes liquidity provision a lot more complicated because previously in V2, you pick the pool you're going to provide liquidity for, you provide liquidity, and that's it. And now with V3, you have to pick the pool, and now you actually have to make the most important decision, which is within what price range do I provide liquidity? And that's not all that trivial. So first we're going to talk about some of the risks of providing liquidity. Among them, platform risk, so something could go wrong with the smart contracts, and permanent loss. Maybe you provide tokens that throughout your liquidity provision lose value, and then opportunity costs, of course. Maybe you could have done something better with your tokens, made more money. So since there are risks in liquidity provision, then we kind of have to look at it as an investment, right? There's got to be some return on these risks for it to be worth doing. Like nobody's going to do this just to be nice. So normally when you think about an investment, you know what the risks are, hopefully, and you say, okay, how much return do I need to realistically want to take those risks? So you want to have an expected return to compare to these risks. And a big parameter whenever you compute expected returns is generally a historical return. Like that's a really good starting point. And so now we're going to look at how we would compute that for Uniswap. So for V2, it's really simple, right? Because the returns on these pools are just the fees that you're going to make from the swap. So in V2, it's simple because since everybody provides liquidity to the whole range, then whenever a swap happens, the fees for the swap just get distributed to everyone. So you just, take the fees divided by essentially the total amount of liquidity in the pool, and well, you get the return for that swap. And that's really straightforward. But for V3, it's a lot more complicated because not everyone provides liquidity for every swap. And the liquidity is also not constant. So how do you compute that? So first of all, because not everyone provides liquidity to the whole range, the liquidity is not constant, and you have to divide the pool, right, into different parts. Which luckily Uniswap already does that for us. Ticks our pools are divided into ticks, where each tick is 0.01% higher price than the previous tick. So good. Now we have ticks, and if you think about it, each tick is sort of its own investment vehicle. Where previously in V2 the whole pool was one investment, now in V3 each tick is its own investment because each tick could have its own liquidity and swaps happen at specific ticks. So it's the tick that gets the fees on its liquidity. So itself, it's kind of its own unit. So calculating tick returns. What we have to do is find for a swap what tick it took place at, how much fees there was. We divide it by the liquidity in the tick, and now we get the returns for that swap. which seems pretty straightforward. But thing is that swaps don't always happen at single ticks. So you could have a swap that starts at tick 0 and it ends at tick 4, right? And first of all, when we look at on-chain data and we look at how we know what tick swaps take place at, we look at swap events, and the swap event only tells you which tick the swap finishes at, which is already a problem. But let's say that we can look at previous swaps and we can infer that, well, if the previous swap finished at tick 0 and this one's finished at tick 4, then we know it started 0 and finished at 4, and that's good. But the problem is that when a swap happens across multiple ticks, what's realistically happening is that there are several swaps taking place. So a swap comes in, and the pool kind of looks at how much needs to be swapped and how much liquidity there's left going in that direction at this tick. And if the swap volume is bigger than the liquidity that's left at that tick, then it swaps as much liquidity as is left at that tick and then moves on to the next one, and so on and so forth. And because ticks, as we covered earlier, kind of vary in liquidity, then we don't know from the swap event how much of that swap happened at each of those ticks. So we don't know how to assign the fees of the swap to each tick, like how much goes to each tick. So that's where this concept of data discovery through backtesting comes about. So the concept is we essentially take a new pool and we look at the on-chain transactions that have happened with that pool, and we essentially recreate its history, transaction by transaction. And what we're trying to do essentially is take snapshots of its state at every point in time. That way, we always know how much liquidity is at every tick. And then when swaps take place, if it's a multi-tick swap, then we know how much liquidity is being used in each tick. We know what fees are going to each tick, and we can actually compute the tick returns for each swap for each tick. So that has quite a few applications. First of all, we can do time series return on ticks. So we can split this pool into ticks, and we now know what the returns are on every swap. We know when these swaps happen, so we can essentially, for any window, have a time series return on these ticks, which is great for getting a sense for what ticks are making money and how much money are they making. And then by reconstructing the state in that way, we essentially know what the liquidity is at every moment. So we know how the liquidity changes. We can kind of look at a time variance of the liquidity. We can compare it to swap volumes, and that can also give us a lot of intelligence as to how these pools behave, how the market behaves. And of course, it is a backtesting approach. So another nice part about it is that we can use this exact same infrastructure to actually backtest signal-based investment ideas. So let's say that we used the first part of the pool history to analyze the data. We came up with some idea on how we can trade these pools. Well, now we have the rest of the history of the pool that we can actually, mint the liquidity in the way that we think was a good idea, and we can run these real transactions over that time period and see how did we do. We thought our expected return was going to be X. How far off was it? And was that good? So thank you. Here's some information to reach me if you want to talk.
So we have some time for questions. Thanks for the interesting talk. Are there any questions from the audience? One is up there.
Thanks. Hey, Pablo.
Hey.
Question on, I guess, the tick. So are you rewarding, I guess, the liquidity providers who invest in the ticks that are more further out from the price, like greater than the ones who kind of, do you know what I'm trying to get to? Like, how are you creating an incentive system to reward the guys who take on the more risk?
Okay, so what happens is that whenever someone provides liquidity within a range, they're normally providing liquidity to several ticks, and it gets spread out pretty evenly. And when a swap happens at that tick, then the fees for that swap get distributed to everyone that provided liquidity to that tick, proportional to the amount of liquidity that they provided.
What if I provide liquidity though in like a tick that's like way outside the range of the price, right? And like I'm like on the edges there.
You see that, like that's why this data is useful, because you can kind of look at, so obviously you want to provide liquidity to ticks that get action, and like that's why this data is useful, because you use this data and you kind of see that, you know, this is where you should be providing liquidity. If you're providing liquidity like way out here, then your return is going to be zero. You're just, you know,
so I guess
waiting for a permanent loss.
So there's going to be no action, I guess, outside the heavy action ticks. Yeah.
Yeah, I mean,
okay, cool.
Absolutely.
I think there is another question there. Yes.
Yeah, I was wondering if you actually do this back testing, what kind of insight did you gain? Because I guess there's a certain trade-off between rebalancing often and like choosing smaller ranges, which costs more gas fees for all the rebalance actions, and like choosing broader ranges but rebalancing less often. So I was wondering what was like the insights that you gained there when doing these back tests?
I guess it depends on your strategy, right? Basically, that's the whole point of the back test. That you kind of see that if you were rebalancing a lot, like basically, like if you think about it, if you rebalance, like you better have made enough money before the rebalance, because otherwise it wasn't worth doing. And that's where the backtesting comes in, because maybe you come up with a strategy that on paper looks great, and like you think you cracked the code, and then when you actually try it, just like the gas fee set you up, like yeah, you were in range all the time, so technically you were getting returns for absolutely every swap, but you know the gas fees for actually burning the liquidity and then reminting it just killed all your returns. Maybe you even lost money.
Okay, thanks.
Is there any other question? If not, then let's thank Pablo for the great speech. Let's thank him again. And then we continue in about 15 minutes. I'm happy to welcome Pascal Brun. Pascal Brun is from Accurast, and he will talk about Universal Web 3 interoperability. I'm really looking forward. I also know Accurast quite well. I supervised a master student doing some projects for them, so really excited for this talk. Give a hand to Pascal Brun to welcome him.
Thank you. Hi, everyone. So, yeah, already thanks for the introduction. I'm Pascal, co-founder of Accurast, and it's actually very cool to be here because me and most of the team are based out of Switzerland. So it's cool to see events like these, back on home turf as well happening. Let's talk a bit about Accurast and what the universe in Web3 is and how universal interoperability kind of enables certain things. Might sound very buzzwordy on one side, I don't know. But let's drill down a bit in the term of also universal interoperability. If you or most of you probably, if you hear the word interoperability, you might think more towards cross-chain communication, bridging of assets, essentially connecting one Web3 ecosystem with another. So very focused terms of Web3 to Web3 interoperability. There are even protocols or so-called layer zeros like Polkadot or Cosmos that have kind of this inherent interoperability mechanism of cross-chain communication between the app chains within their ecosystem built in. But usually this essentially stops there, right? So it's not an inherent way of breaking out of these specific ecosystems. So with the universal interoperability, we approach this whole thing a bit more on a holistic point of view. So zooming out a bit and looking at what really interoperability means. Does it go beyond essentially only cross-chain communication, so between Web3 to Web3, what else can be included into this? And that's when we end up a bit at the current state of Web3 in general. If we are looking at this as well, it's usually we have applications that are built within the Web3 space, like DeFi applications that rely on certain off-chain data, for example. So you have price feeds of like a Bitcoin US dollar for a DeFi lending platform that needs to come on chain, right? So there's no inherent way of getting that data that exists outside of the Web3 world into the Web2 world. But also the cross-chain communication approach, right, that I've mentioned as well. You don't have an inherent way of communicating between these chains, right? It's not a given without any focus on like bridging assets, which we have seen also recently. There are not as secure approaches out there, most likely focusing on the user experience if it comes to bridging assets. But also in general, kind of having an easy way to communicate between these chains as well. And even if you're thinking about a bit more towards novel or upcoming approaches, such as AI, using a way to get access to, for example, a language learning model into the Web3 space, and as well having seamless access to IoT, for example, that's not there yet. So you have a lot of these shortcomings because many of these individual ecosystems that exist in Web3, they have a lot of unique value propositions. But without a way of inherently connecting all these worlds, essentially, meaning the Web3 world with the Web3 world, but also getting off-chain data into that, that space and the AI or IoT approaches as well. So you have kind of this vacuum that exists nowadays. But we think that this creates a huge opportunity for definitely Acrist, but as well as using Acrist as an enabler for the whole Web3 space in that regard. And I've touched a bit on the way of how these ecosystems are sometimes very isolated, right? So you have, for example, Polkadot that focuses on the parachain or app chain approach that gives you the ability to build for a certain use case. And that's also what we are leveraging here with Acrist. So having the given way of the Polkadot ecosystem for us to build specific for the need of Acrist, the protocol itself. And we get access to shared security with Acrist, as well as a communication layer with all the other parachains in that ecosystem. But looking outside of that, it's not easily possible to interact with a chain on Cosmos, for example, or on Ethereum, Tezos, and many others, right? It's also not easily accessible to get data onto these chains. So you have essentially a huge opportunity in that regard if you have a solution that is offering a good user experience to developers and that is also seamless. And this is what we are doing with Acrist. So the Acrist universe is essentially filling that vacuum between these various worlds. So having a way of interconnecting Web 2 to Web 3 through Acrist, through this platform that Acrist is, which is permissionless and decentralized at its core, right? So you don't have an approach in the middle that you need to rely on in terms of trust. And with this approach, what this essentially opens up is a vast number of use cases, right? So we can, on one hand, enable developers that want to build a DeFi platform, for example, that I've mentioned, and that need access to public APIs and these price feeds. If they're building on Cosmos or if they're building on Polkadot, Tezos and EVM chains, it doesn't really matter for them because they essentially can utilize the Acrist platform to get access to that. The same goes for then using the Acrist platform for these communications between the various chains. And also getting access to the more novel things like AI or IoT. So let's take a quick look. I mean, this sounds very high level. This sounds very promising, you might think. But how are you actually solving this? And there are a few components. So on one hand, this is one thing is focusing on the modular part. So the protocol itself is built that we can introduce these interoperability modules in the end. So you can have the enterprise module, for example, which gives you access to Web 2, where public or permissioned APIs live. You can also get access to off-chain computation through this. You have the Hyperdrive module, which is the mentioned cross-chain approach, as well as the Singularity and Mesh, which focus more on the AI and IoT side. So you have essentially a way with these modules to interconnect these various worlds with each other. And if we are looking at how this works out, essentially, how can we say that that Acrist is active in so many essentially verticals, right? So being able to have a more Oracle use case, but also being able to do this cross-chain communication. And everything boils down to, on one side, having this decentralized computational network where you have a lot of parties providing computational resources. And you have networks that are built up like these with validators that utilize, for example, trusted execution environments, things like that, that are built with like server hardware infrastructure, right? Which is not as accessible as if you think about a mobile device, because a Google Pixel phone, for example, I can buy in almost every country of this world. And if you further think about the security aspects of a mobile device, they are inherently portable, right? You have one, like everyone in here has one in their pocket, and you do e-banking on them. You have your crypto wallets on them, and still your device, even though it gets stolen or you lose it, your funds of your e-banking account are not immediately drained because of that, right? And this boils down essentially how these mobile operating systems were set up. So this goes for Android and iOS, that these have been built by Google and Apple with kind of sandboxing in mind, right? If you look at a Mac or Windows operating system, there you easily can kind of communicate between the applications. Here on the mobile operating system, this is very strictly given context to one application and not easily shared with these other apps running on the same device. And then even more interestingly, like most of these mobile devices nowadays, they come with a hardware security module, so a hardware chip on the device that essentially gives the access to this trusted execution environment, which means that you can run a context within this trusted execution environment even more securely than you would do that in any other way. So what we are doing here is we are on one hand leveraging these mobile devices that are very secure and accessible for essentially everything that we have seen previously that is related to fetching data from somewhere, or doing computation, or fetching data for a cross-chain operation. Everything happens within this trusted execution environment of these mobile devices. And as I've said, it's accessible. So what this means for Acrist itself is that anyone can participate. So this means you can get like a Google Pixel 4a, something like that. You take it out of the box, you scan a QR code, and within 5 minutes, this device is dedicated as what we call an Acrist processor. So a way of an infrastructure provider for this whole network. And the interesting thing is as well, you're being rewarded for that. So it's essentially you are becoming an infrastructure provider for Acrist, and this can scale essentially to the thousands and infinitely. And you receive rewards because these devices are then being used, or the computational resources of these devices that you are providing are being used by the other side, which is the consumer side of Acrist. So the developer of this DeFi platform that I've mentioned that says, okay, I need the price feeds for certain assets. I want this script to be run on these devices, and then the outputs given to my chain that I'm essentially developing on. So we have the computational resources that are provided, and then you are also earning essentially rewards. But now we have the one side, we have the processors, so these off-chain infrastructure providers that run these mobile devices, and on the other side you essentially have the demand as well, so the supply being the processors, and the demand on the other side of developers that want to have interactions, right? So that want to have this off-chain data being processed and brought on-chain, that want to have these various use cases. So what we are doing is we're not limiting anyone essentially, we're enabling them with a marketplace. So it's not that you have to come to me and say, hey, Pascal, I need this like verifiable random number on Cosmos, for example. It's not a centralized approach in any means, which means that it's completely self-service. So you as a developer that has interest of like, I need a certain computation being done, you can go onto this marketplace. You create what we call an Akrus job, where you say, I need effectively this job starting from tomorrow until the end of the year. I need it executed every 15 minutes, and I need this executed by 5 processors on the other side, and I'm willing to pay a certain amount for it, 1,000 USDT, for example, right? And then the marketplace, which is essentially the core of the Akrus protocol, matches this request of consumers automatically on the other side with the processors that have said, okay, these parameters match for me. So you have an automatic matchmaking between these. So you have the onboarding that is self-service on the processor side. You have the onboarding and like the seamless approach for developers, essentially requesting these resources on the consumer side. So let's talk also a bit about lowering the entry barriers for this, right? If a developer on the consumer side needs to write this request in even just Solidity, you have higher entry hurdles. So what this means is that if you want to have this also as a tool, for example, to give Web2 enterprises a way to venture into the Web3 space, they first need to hire someone with the knowledge of the whole Web3 tech stack, right? And this is here different. So what you need to know essentially as a consumer for getting the resources computed through the Akrus platform is only JavaScript. So you define this job that I've mentioned on the marketplace. You define in JavaScript code. For example, if it's a public API call where you're getting the data from, like you would do with just simple plain JavaScript. You can do computation, you can do certain algorithms, things like that. Whatever fits your use case that you need to have processed by an arbitrary amount of processors on the other side because you need the security, right? So you have really low entry hurdles to get essentially data processed and then being put on chain as well wherever you need it in the end. One thing that I've mentioned, forgot to mention on the marketplace, here we are, is also that given this trusted execution environment that we're utilizing, what we can essentially know for sure is that a script has been executed like it has been defined by the developer, because we can have a proof of execution submitted as well. So as soon as there is some tampering in between, the proof of execution would fail. But there is one thing that we cannot control through this verifiable approach, which is the uptime of processors on the other side, right? Your processor that you're running might go down because you don't have any internet connection, or your device might run out of power, whatever. For that side, we have worked together with the University of Zurich as well on a reputation system. So, which means that we have kind of these both ways covered, right? On one hand, the trustless approach in terms of verifiable execution, but also having a way to kind of measure how kind of up a processor was. If he had a certain downtime, then his reputation score would essentially negate, making it not as interesting to, on the other side, consumers to start even utilizing this processor in the end. Just quickly, kind of an outlook, maybe also an approach where we're standing at the moment. So we have been seeing this like enterprise, these modules, right? The hyperdrive, whatever. For now, what we're kind of the initial focus is especially on these, right? So on the enterprise side, you can already use this platform to, for example, do computation or fetch public or permissioned APIs. You can also use it for cross-chain communication, but we're further expanding these functionalities as well as the ecosystems that we will support. As of now, Acrist will become first a parachain on Kusama, so the incentivized testnet will launch within the next weeks. And later on, this is then as well intended for a launch on Polkadot as the public chain. But as interoperability is also at its core for Acrist, this does not mean that we are only serving the Dotsama ecosystem, right? Like we have seen before, you can have easily a way to communicate with all these other ecosystems as well. So this is what we are then focusing on integrating or supporting down the road. So yeah, I mean that would be it, kind of a high-level intro from our side in terms of Acrist. If you are a dev and want to play around with it, you can head to docs.acrist.com. Also, if you want to see how the onboarding process is and how you can in the future earn rewards by getting a dedicated mobile device like a Google Pixel phone, you can head over to console.acrist.com and do the onboarding of that. And yeah, also if you just want to participate in the community, head over to Acrist on Twitter, for example, or also Telegram. Thank you very much. I don't think we have time for questions, but I'm around here outside as well. We do? Okay. Okay, good. Very good. So anyone has a question? Yes.
So just so that we understand correctly here, the proof of execution means that some hardware that has been certified by some manufacturer executed this computation and signed the output. So it's not some cryptographic proof in the sense of a ZK proof or something like that. It's a trust-based proof, right?
Yes, so there, like you're saying correctly, in the end, by utilizing trusted execution environments for this and not ZK proofs at this stage, which is something that we are evaluating as well, we have some trust assumptions in the hardware manufacturers, right? So if we are utilizing for this first version, for example, Android devices, so for also Google Pixel phones or Samsung devices. So there are certain trust assumptions in these manufacturers. However, the thing there is that we are onboarding other solutions as well. So further down the road, there will be iOS devices supported, and there will be even some like server-based hardware supported as well. So you have kind of the trustless approach in that sense that you don't have to rely on one specific device from one specific manufacturer, if that answers your question. Thanks.
Are there any other questions? There is one.
Hi, thanks for the talk. I have a question. You mentioned there's a reputation system. Can you go more into detail how this is kind of secured so you cannot gain it?
Yes, that's a good question. And I'm not the one that has personally worked on it, so I cannot go into too much details. But there are certain events that you essentially get slashed in terms of your reputation if you have certain offline events, for example. So you have a certain score that is then essentially reduced, or if you fulfill a certain amount of jobs successfully, you will essentially earn more in terms of the reputation score. But we will publish more on this, on the reputation itself as well. So happy that you can also check that out as well.
Is there any other question? I think on the top. Sorry, you have to run a bit.
Get a cardio in.
Thank you. If there's a vulnerability in one of these hardware modules that is detected, what would be the reaction to make sure that this cannot be used by some predators?
Yeah, so you have essentially a way of then also on the protocol side of things detecting which devices run a certain version of the operating system. So you can on a protocol level also kind of exclude these devices and void their attestations. So you have a way to essentially control that as well.
So I would have also a final question maybe. Could you say a bit more on the marketplace, on the matching between consumers and the data provider?
Yeah.
How exactly does it work, or what is the intention or the mechanism there?
Yes, I mean the intention is that this completely works automated, right? So that no one has to interact essentially for this to be matched with anyone else. And so how it works is that both sides they define certain parameters. So on the processor side, you can, for example, define a certain job in terms of reputation score, in terms of assets, or how many jobs that you want to execute at the same time. And on the consumer side, you have a bit of more range in terms of defining requests, start, end dates, intervals, also probably most notably kind of the economic side of things, so how much you are willing to pay. Because then the processors can also say, I'm not even considering jobs that have a runtime of a month that are under 1,000 USD, for example, right? So you have kind of both ways specifying the parameters, and then based on that, the matching and assignment happens, and then the processors start to fulfill these and put the data on chain.
Okay, thanks a lot. Thanks Pascal for the interesting talk.
Thank you.
Yep. And then next up is a speaker that I know very well because he's also as crazy as me and is doing a PhD at the University of Zurich in the area of DeFi. So he is really an expert on DeFi. He will talk about DeFi use cases, design and attacks. So I'm happy to have Chris here. Please welcome Chris for his talk.
Here's it.
Here.
There's a sticker.
Okay. So hello, everybody. Thank you, Florian, for a very nice introduction. So my name is Chris Gogo, and I am one of the PhD candidates in blockchain, in DeFi, at the University of Zurich. And today I'm going to tell you more about the research project that we just finished and are about to publish a paper about it. I mean, there is a lot of hype around DeFi and especially tokenization. We can see a lot of big banks playing with DeFi, tokenizing financial assets. Practically every week there is a news. Some of them are using Uniswap, using Aave for the financial products they tokenize. And in my talk today, I will try to explain you why they are doing it. Here on this chart, you can see how much assets are being locked in DeFi. Actually, there are a lot of cases where, when in DeFi, we are using different terminology than in traditional finance, and TVL is one of such examples. It stands for total value locked. It's something like assets under management in traditional finance. And you can see that within just 2 years, it grew practically from 0 to over 150 billions. And then it dropped. It dropped typically because of the two things that happened. One was Terra Luna, a crash that actually triggered a lot of other things later. And then you can see that at the end of last year, there was FTX crash, but the market almost recovered from that. Another interesting thing is, when we look at which blockchains are the largest and where the DeFi today actually located is, I mean, it's of course Ethereum, and Tron, Binance, these are layer 1 blockchains, but other chains, Arbitrum, Polygon, they are layer 2s. Arbitrum is optimistic rollup. And I mean, over the last 2 days here, we were talking a lot about zero-knowledge rollups. And I believe that when we meet next time in a few months or 1 year, we simply see one of those zero-knowledge rollups getting to the top of this list. And simply what we did at university, we look at all of those assets that are being locked in DeFi, and we looked how they are being allocated to which DeFi protocols. We simply look at the protocols that are covering almost 90% of all those assets that are in DeFi, and analyze what are the design patterns, what are the risks, and what you should be careful about when you are using it. Generally, we noticed that all DeFi actually comes down to 3 types of the protocols, and there is really nothing more. So one group of the DeFi protocols are liquidity pools. These are the marketplaces that are matching demand side with the supply side. They are synthetic assets or synthetic tokens, and they are aggregators. And there is nothing more. Our hypothesis is that everything in DeFi is actually falling into one of those 3 categories. And then when we look at the DeFi risk, I mean, there is a lot of talking about, that DeFi is being hacked. There are, I mean, a lot of different risks. But those DeFi risks are also driven only by 3 factors. By one of those DeFi categories, by the tokens we are using, and also how we are using those protocols. And I'm going to show you how actually it's working in practice. So what actually DeFi is? So DeFi is the general term which is describing all of the financial applications that are using a blockchain for their security. I mean, this term is very close to CeFi, which stands for centralized finance. And CeFi, like for example, some crypto banks or maybe exchanges, I mean, they also having blockchain-related business model. They have blockchain-related services, but they do not rely on the blockchain for security and integrity. And simply we at university, we assume that when you have a wallet and you are connecting to different protocols with your wallet, with your private keys, this is a defining factor of DeFi. And then those DeFi protocols, they can be governed in a very different way, with DAO or without DAO, or when there is a DAO, the DAO can be more or less centralized or decentralized. And here you can actually see what things are possible today within DeFi. I mean, the most basic value proposition is the trading. When you are having two tokens, like I know MakerDAO and maybe USDC, and you are simply swapping one token into each other. Then when we have in DeFi those trading protocols, they are called decentralized exchanges, then we also need aggregators that will be quickly finding for us the best trading rates. If, for example, we are missing some tokens to buy another one, we can go to lending protocols. And with lending protocols like Aave or Compound, we can borrow one type of the tokens, typically stable coins, using another tokens like Ethereum, for example, as a collateral. There are also some DeFi protocols that are working similar to asset managers. These are yield farming protocols or liquid staking that are doing a little more sophisticated financial services, but they are making our work easier. And the last category that, it's being discussed whether it's a part of DeFi or not, these are bridges and the wrapped tokens. They are simply allowing you, for example, on Ethereum, having a wrapped Solana or wrapped Bitcoin, and get exposure to those, cryptocurrencies also on Ethereum blockchain. But the important thing is, I will be talking more about that later, is to understand they are the financial products. Having wrapped Solana or wrapped Bitcoin is very different from having actual Bitcoin or actual Solana. Like some people learn the hard way. Here you can see actually all those categories that we analyzed in our research. Actually, this is a screenshot from the end of last year. Right now, there is one change, is that liquid staking actually became the second largest DeFi category. It took over lending. And when you look at those 6 categories, as I mentioned, they are covering almost 90% of all of the assets that are in DeFi. And the first 2 categories that you can see here, decentralized exchanges and the lending protocols, this is Uniswap and Aave, for example, they are liquidity pools. They are marketplaces that are matching the demand side with the supply side. For example, for Uniswap, on one side you are having liquidity providers, on the other side you are having guys that want to buy or sell tokens. When it comes to lending, on one side you have guys that want to, for example, borrow. On the other side, those that want to lend. And those smart contracts are linking those two sides. The second group of DeFi categories are synthetic assets or synthetic tokens. These are DeFi protocols that are issuing or creating some new form of the tokens that are having special properties. For example, in case of the stable coins, their value is equal to typically $1 or $1 franc. There can also be bridges and wrap tokens or liquid staking protocols. And then later in my talk I will show you how those synthetic tokens are working. They are a little similar to derivatives in a traditional finance, but not exactly the same. And the last category, which is actually super interesting, is yield farming. And yield farming are aggregators. These are the protocols that are simply connecting with other DeFi protocols and providing liquidity to them. So maybe now let's start from the end, and let's start from looking at yield farming protocols. I mean, those of you that have a background in finance, they know that when you have, for example, exchange, you need to have the first people that will put the first orders on the exchange. And those orders are mock-up orders. They are brought by so-called liquidity providers, market makers. And those guys, they simply create the first demand or the first supply in a traditional finance or also in DeFi, so that you can seamlessly use those DeFi protocols. And in DeFi, simply guys that are doing market making, they are being called yield farmers, and the protocols that are doing market makings are being called yield farming protocols. Here, such what yield farming protocols are doing, it's like when you have, for example, Aave or Compound. This is the very simple example. I mean, you can go there and, for example, you can, against your Ethereum, you can buy some USDC, for example. And so in order for you to be able to borrow those USDC, somebody else must actually bring them to the lending protocol. And the guys that are bringing it, these are those yield farming protocols. And yield farming protocols are looking at different interest rates protocols that are simply checking for you where the rates are the highest and automatically allocating your tokens to them. They can do the same thing using the leverage. That's the second most popular strategy. Or they can also go and do some liquidity providing at decentralized exchanges. And actually the third strategy is currently growing the fastest, especially with the Uniswap version 3 and those new version of decentralized exchanges. I mean, maybe it's a little sad for those protocols to call them aggregators, because mathematically they are solving a very complex optimization problem. You might think about them like some robo-advisors in a traditional finance that are simply automatically looking for the best investment opportunities and allocating your tokens. You can do those yield farming by yourself directly at different protocols, or you can simply use those aggregators. The second category, synthetic assets, I mean, I believe it's the most interesting, because I assume practically all of you used some stable coins. I mean, maybe you used DAI, maybe you used USDC. So stable coins are synthetic assets that are trying to keep the value always equal to $1. There are another types of the synthetic assets. These are, for example, wrap tokens, like wrap Bitcoin on Ethereum, that is trying to keep the value always equal to 1 Bitcoin. And recently, there are plenty of liquid staking protocols that are doing something a little more sophisticated, and they are trying to keep their value to the value of the stake Ethereum plus the staking awards. But the mechanics is always the same. You have a token, you have a protocol that is simply trying to keep the value of the token to the target. And all those protocols, synthetic tokens, are working the same way, or maybe almost all. They are simply keeping reserves, they are keeping a treasury in order to keep that peg. So, for example, stable coins, they are building a reserves of a traditional fiat money or another crypto assets. Liquid staking protocols, they should have some stake Ethereum. Wrap Bitcoin is having some Bitcoins on the Bitcoin blockchain. Maybe it will become a little more easier to understand when we look at how stablecoins are working. So the most popular are fiat-backed stablecoins. That means some people might argue they are not really a part of a DeFi, they are more part of the CeFi, because the reserves they are keeping, they are simply keeping them in traditional banks. And here example is the USDT or USDC. Another type of the crypto of stablecoins are crypto-backed stablecoins like MakerDAO or Liquidity that are using another tokens in their reserves. They are not keeping any reserves in a traditional banking system. And there was quite cool innovation that it turned out doesn't work, and these were algorithmic stable coins like Terra. And then, I mean, when you look at this chart, here you can see in the blue line the value of the Terra. It's USDT. You can see that at the beginning or for a long period of time, the value was really equal or almost equal to $1. But what actually started to happen at the end of the May 2020, I think, the value started to go down much below. And the reason was simply the protocol couldn't provide enough treasury to defend the value of that stable coin. Actually, what Terra and Luna was doing, below you can see the value of Luna, which was the token of the blockchain on which USDT was issued. They were using the native token of their blockchain as their collateral. It's something like a traditional bank would be building reserves using equities of that bank. So Terra did something similar. They were using their own governance tokens as their reserves. And as the stablecoin demand started growing, that simply systems start to fall apart. But the important thing is, Terra was doing it in a very open and transparent way, so that everybody knew, and also Terra was not hiding it, that they are using their own governance token as a collateral. And I mean, some people early on exited from their investments, others simply kept it in their portfolio. Another example of actually a stablecoin that was losing the peg is USDC. And it happened quite recently in March this year. It's an example of a stablecoin that value should be equal to $1. You can see that typically it is equal, but when the Silicon Valley Bank became insolvent, that stablecoin got problems. And those problems were caused by the fact that they were keeping something like $3 billion in Silicon Valley Bank. And those 3 billions were representing around 10% of their treasury. And here you can see how actually market quickly adapted. When the stablecoin was at risk to lose 10% of their treasury, the value immediately dropped by 10% to 90 cents instead of $1. But then, when at the end of the weekend, it was clear that the government is going to back up, and those treasury is safe, the value, the peg simply came back to $1. And this is how stablecoins are working. They can be permanently depegged, like it happened for Terra. It can be temporary depeg. But the important thing is the same thing with depegging can happen to a token, to wrapped Bitcoin. And actually that happened on Solana last year, when the wrapped Bitcoin on Solana was losing a peg for some time. But later, it managed to come back. And when you are buying those wrapped tokens from bridges, you need to be aware that you are not having native tokens, but you are having some synthetic assets that can, in a very extreme market situation, actually lose the value. And this applies also to staking. Right now, it's very popular, especially with the current upgrade on Ethereum, to do a staking, which is being considered a relatively safe investment. On Ethereum, the staking awards are rather high, 5%, but you need to lock it. I mean, before you need to lock it until there is an upgrade. Now, it might be 1 day. But the issue is that those liquid staking tokens, they are also synthetic assets. And they are doing their best to simply be as equal as possible to the staking awards. But they are like stable coins. So they are having, let's say, a better and worse days, or better and worse weeks when they are closer or farther from their target. And on this chart, you can see that actually last year, there were, during that big market turmoil, both the Lido and Rocket Pool actually were traded below the staking awards. But at the end of this year and beginning of this year, it recovered. So what you can see on this chart, this is like on the 1st of January 2022, you are having 1 Ethereum, 1 Ether. And then you can put that 1 Ether into staking. And then you can see that you would have something like 1.055 Ether right now in April. But then we also calculated how much you would make from that 1 Ether if you would buy the Lido on the 1st of January 22, and how much Ether you would have if you would buy Rocket Pool. And you can see that there are really some differences. And those differences are actually bigger on the Ethereum, I assume because there were no withdrawals possible. When it comes to other chains like Solana or Binance, their liquid staking protocols are working quite well. But the important thing is about, especially wrap tokens, is when you buy them. Because when you buy them in a moment, then you are when they are undervalued, and you are selling them when they are overvalued, then actually you are making a great deal. And especially to liquid staking tokens like Rocket Pool or Frax, it's the day really matters when you bought it. On this chart, you can see a simulation. How much you would simply make money if you would invest that 1 Ether on the 1st of January this year. So if on the 1st of January you would invest 1 Ether into staking, you can see where you would get. And then if the same amount of Ether you would put into Coinbase or Lido, then you would get a little more, which is quite surprising that Coinbase delivered the best performance. And Frax and Rocket Pool got not the best time. Actually, you would lose even more. Then you would just keep that one Ethereum in your wallet. So I mean, please remember that those liquid staking tokens, they are a little similar to derivative products in the traditional finance. And they are doing their best to keep the peg to their target, but it's not, you can't take it for granted that peg will be always delivered. As you can see, I mean, some protocols are doing better job, some are doing a worse job in getting to that peg. I mean, our expectations are that now when it's possible to unstake the Ethereum, those discrepancies will get smaller. Because on another blockchains where you stake only, and when you lock only for 2, 3 days or even 30 days, simply there are no such big discrepancies as on Ethereum. So don't worry too much about that chart if you have Rocket Pool or Frax. And then, let's go to the actually the most interesting categories, which are the lending protocols and the decentralized exchanges. The lending protocols like Aave, they are actually using a lot of mathematics. I mean, some people say that smart contracts are not contracts; they are not smart. So interest rate protocols and DEXs are example of smart contracts that are quite smart. And they are using simply mathematics to determine the interest rates. So when you want to borrow some DAI or some another stable coin from Aave or Compound, there is simply a mathematical formula. It's the third one. It's that kinking rates model, simply determining how much interest rates you are going to pay. And also a lot of big banks that are doing some pilots, like JP Morgan, for example, in Singapore. They tokenize Japanese yen, Singaporean dollar, but they also fork those interest rate protocols. They fork Uniswap. They were using those DeFi protocols simply to trade those tokenized assets between each other. And here the advantage is that you know upfront what is going to happen, how much interest rates you are going to pay. It's very transparent because this is simply a mathematics. There is no a banker deciding on anything. And then the biggest category, and also I think one of the biggest innovations in DeFi are decentralized exchanges. So when you think about exchanges, there is something like a central limit order book. So when you think about, or when we look at the, for example, Swiss stock exchange, that stock exchange is keeping simply a list of the guys that want to buy some shares and list of the guys that want to sell them. And it's trying to match those buyers with sellers. And that solution is called order book or a central limit order book because there is one place where those order books are being kept. Order books are difficult to implement in DeFi because storing them in the blockchain is quite expensive. And for that reason, actually Uniswap invented quite a smart idea called automated market makers, short AMM, which are also mathematical formulas that are simply deciding how much you pay for buying or selling some tokens. And when you look at those formulas, you can see them here. The most popular one is the second, is the constant product market maker. This is the formula used by the Uniswap version 2. And then Curve and Balancer came up with a little more sophisticated formulas, that constant mean and a stable swap invariant. And in those formulas, you are simply looking at the reserves. X and Y are reserves of the tokens that you are swapping. So for example, you want to swap Ethereum for USDC, then X is how much Ethereum you have in your reserves, for example, 100 tokens, and Y is how much reserves of USDC you have in your tokens. And simply just looking at how big your reserves are, those automated market makers are deciding on the price that you can you need to pay. And there is no need to have that order book anymore. There was, a lot of talk about that yesterday. And you can think that buying and selling at DEXs is a little like going on this curve. It's unfortunately coming with new types of the risks, like slippage and impermanent loss. Because when the reserves of some tokens are small, then you might pay quite a lot, quite a high spread for exchanging something in a decentralized exchange. And also when you want to be a yield farmer or a liquidity provider to a decentralized exchange, and the tokens are very volatile, then actually your profit will not be high if the trading is not high enough. So in general, now I'm coming to the conclusions. You can see behind me like a big map of all of those DeFi protocols that are there. Not sure if I can. No, doesn't work. So, but interesting thing is below, because we also look at the centralized finance systems, where you have those different systems, like a centralized finance that is having a blockchain settlement, and centralized finance without it. And then, for example, you can see here that we classified fiat-backed stablecoins, for example, as a blockchain. Is a CeFi with the blockchain settlement. I mean, also interesting things are about liquid staking, how they can be implemented, and those different ways, like how Lido or, for example, Rocket Pool are working, because there are very different ways how the rewards from the token are distributed to those token owners. And now, actually, I want to show you very quickly what are the biggest risks in DeFi. So what we did, we simply look at those types of the DeFi protocols. We don't have here yield farming, because yield farming is like a building investment strategies that is reliant on those protocols. That's why, it's not listed here, because it's inheriting the risk. And there you have very different types of the risk, from like a low level related to the blockchain infrastructure, to the DeFi specific, like some liquidation, slippage, and impairment loss. And actually, the good thing is there is no need to be afraid of all those things, because they depend on how you are using those DeFi protocols. When you are just using Uniswap to buy or sell some tokens, you are just a service customers, and you are having a different risk exposure than, for example, somebody who is liquidity provider or so-called yield farmer at Uniswap and Aave. There are also some arbitrageurs that are simply looking at the price differences between different protocols. They also have different risk exposure. And the DeFi protocols, we politely named as the government users. So guys that are simply holding the governance tokens that want the token to appreciate value. So now we made simply that table even more complex. And you can see here that when you look at the infrastructure layer attacks, and for example, Oracle attacks, I mean, some DEXs like Uniswap, for example, is independent of the Oracle attack. It can be a source of Oracle attack, but it's not a victim of Oracle attack. Actually, for the DEX, it's quite good when it's a source of the Oracle attack, because they are making a lot of money from fees. And when maybe there is only one category, these are those hacking attacks. We call them a smart contract attacks, because when this has happened with the DeFi protocol, then all of the stakeholders are being equally affected. Then there are MEF attacks that are happening quite often. Everybody knows about them, but luckily their impact is on every trade is relatively small. And I mean, something that also important is that blockchain attack, and this is what happened, for example, with Terra and Luna last year, when we just had a situation when one of the largest blockchain, it was the 8th largest blockchain out there, simply within 1 week disappeared. So we called such situation a blockchain attack. I mean, so far it just happened once. And typically, when you work with the largest, well-established blockchains, you are resistant. You should be resistant to that. There is a lot of research done, especially on decentralized exchanges, and what are the risks there. And it's important to know that, for example, slippage is something that is affecting you when you are buying or selling some tokens at those exchanges. Whereas impairment loss is something that is affecting yield farmers on the decentralized exchanges. Also, for example, DPEG risk, like DPEG of a liquid staking protocol or a stable coin. It might happen only when you are buying or selling those tokens. When you are trading another tokens, you are simply not affected by that. And here there are like a lot of details, but DeFi is simply part of the science. There is a lot of computer science, mathematics, and I mean all of those risks can be quantifiable, they can be estimated. And there are more and more professional crypto or DeFi asset managers. They are simply doing it. Okay, so what we decided to do right now, I mean, there were a lot of talks about layer 2s and especially zero-knowledge based layer 2s. And right now, a lot of DeFi protocols are being deployed there. Like, for example, Uniswap. Uniswap is practically present on every layer 2 and on the Ethereum. But when you are doing it that way, then simply the way you are managing your liquidity is super inefficient. And yeah, you are leading to liquidity fragmentation, which is leading to higher slippage and higher costs. And yeah, we want to research how those protocols can be managed in a better way. And then we are going to continue the research on the liquid staking and on the other type of the tokens like stablecoins, Solana, Bitcoin. And the last but not least, there are new types of the bridges that are working a little like decentralized exchanges on a few blockchains, and they are allowing you to avoid using synthetic tokens, but directly swap the tokens for native tokens from one blockchain to the other. Yeah, I mean, if you're interested in reading into DeFi, these are the papers I recommend. They are typically looking exactly into single types of the protocols. There are, most of the work on the is done on the DEXs, as they are mostly used. And also, I mean, if you like what I was talking about, you're welcome to join our site event. It will be on Wednesday, and we are organizing a practical workshop when together with one of the crypto asset manager, we will be showing you exactly how you can do different DeFi strategies on Ethereum testnet. It will be followed by some discussions. And also in general, in Zurich, we are having a DeFi asset managers community doing monthly meetups when we are discussing different protocols, risk, opportunities. And also, if you are around, you are welcome to join those meetups. And thank you.
Thanks a lot, Chris, for all these insights. So we have a bit time for questions. There's the mic.
Thanks a lot for the presentation. Before I ask my question, definitely go and visit the event. I've been to pretty much each of them so far, and they're really great people. If you're interested in DeFi, should definitely join in. And my question to you, Chris, we were talking about Uniswap and DEXs. Now that it's like possible or people are allowed to fork Uniswap v3, what is your opinion on, do you think that's kind of going to boost the whole concentrated liquidity topic? Do you have like a view on what might change now that we're seeing all of these forks on Ethereum and layer 2s potentially, whatever?
I mean, that's a good question. Maybe the first thing is Uniswap version 3 is quite a cool thing because it's allowing you to use the liquidity in a more efficient way. A lot of tokens are first going to version 2 to discover the price, then they are going to version 3. I mean, to be honest, I also think that version 3 is so difficult to use that it's practically impossible for a person who is not an asset manager to use it, and then it's better to work together with the yield farming protocols. And I think also for that reason, I don't think those forks will be successful. Because to be successful, you need to be integrated with a lot of yield farming protocols, because when you don't have liquidity, then you will not have users. And in blockchain, at least in DeFi, we can already see a little of that network effect. That there are big blockchains, big protocols attracting more users and more money.
Any other question? Yes, we have two up there.
So there's one particular risk in DeFi which I'm wondering where you would categorize it, which is fairly common, that there's a very special lending protocol out there the flash loans, where you take out the loan for one transaction and it's risk-free. From the point of view of the lender, it's risk-free because if it's not profitable, then the transaction will simply revert. And it is envisioned that arbitrage opportunities are going to be harvested even without. So those who spot the arbitrage opportunities can harvest them even without their own capital because they can take out a flash loan. But they're also used for a kind of attack when some lending protocol uses an automated market maker as their price oracle, but that automated market maker has low liquidity, so its price can be moved with a flash loan, and then there's a synthetic arbitrage opportunity which is harvested. And this is, this happens. A lot of funds gets, well, you can call it stolen, you can call it harvested. So I'm wondering how does this kind of activity fit into your categorization?
Yes, that's a very good question. Unfortunately, I can't go back to that slide with those risks. And indeed, we didn't list their flash loans separately because flash loans are a mechanism that are making other DeFi attacks more aggressive, more profitable. You can do the MEF attacks, you can, as you mentioned, or some arbitrage things, simply with the flash loans, more on a bigger scale. So I don't see them as a separate category. It's more a tool which is making the other attacks far more profitable on a bigger scale.
Okay, thanks a lot. I'm sure there are many more questions, but Chris will stay around. You can also talk to him outside. Thanks again for the great presentation. Give Chris a hand again.
Thank you.
So next up, we have a lightning talk, a very short talk by Georges, the product lead of Gnosis Hashi, who will talk about securing bridges by distributing trust. Please welcome Georges.
Try mouth, yeah.
For people. All right. Do you hear me good? Yeah. So I want to talk to you about the concept of additive security for cross-chain bridging, and Hash is a framework we're implementing that does exactly that. So first of all, why do we need that? Essentially, bridge hacks have been quite a lot. Only in 2022, there were 2 billion, and out of the top 5 worst hacks ever happened, four of them have affected bridges, and not a particular type of bridge, but many different kind of security mechanisms. So for one thing, we can be sure that there is 100% secure bridge does not exist. All of them have trade-offs. Before we go to the framework, there's some layer definitions. So we can split bridges in 3 layers, essentially. So there's a transport layer. This can be an off-chain component, such as a relayer, that transfers the state root of one chain to the other. Then there is the verification layer, which is the most important one, and the toughest one, the one that we're going to focus on, which is ensuring that the state root that you brought from the remote chain is essentially correct. And then there is different types of verification, ZK Lite clients, MPC, multisigs, and stuff. And then there's, of course, the execution layer, which is given a correct state root, do something with it, right? Send some tokens or perform any kind of computation on it. We're searching for the holy grail, for the best and most secure bridge mechanism, right? And then we've seen there are 3 general categories. One is the fully trusted setup, multi-sig, committee-based and stuff. Then there's the optimistic one, like Nomad, maybe you've heard of it, and the new type, the ZK Lite client-based one. But what we've seen, the root cause for hacks were not essentially related to the bridge mechanism, right? They were more related to some human errors, compromised private keys, social engineering, or even smart contract bugs. So then we came up with the following idea, which is, if you know, like if you heard from the hardware times, redundant array of independent drives, where you have 2 hard drives storing essentially the same things, and if one fails, you have the second one or third one if it's a failover. And we thought to apply this mechanism on bridges, right? So we can have you can have many types of security mechanisms, and if one fails, you have redundancy on the others. So yeah, what is Hashi now and the additive security approach? The main goal here is to distribute trust for bridges on the mechanism level. So every bridge so far has relied on one specific bridge mechanism, and we want to change that. We don't want to rely on one specific security mechanism. We also want to standardize on the lowest level, which is the the block hash. And yeah, I was going to imagine this kind of mechanism prioritizes security over latency and cost. So this is a lot slower, of course, and a lot more expensive. But in order to compromise such a mechanism, you need to hack multiple bridges in parallel at the same time. So here there is a clear trade of security over latency and cost. The main goal of this framework is diversification. You may have heard the Ethereum protocol client diversification for the reasons that in case there's a zero-day bug on one, you can have failover to other mechanisms. The same thing we want to do here, especially on the verification layer. So we want to implement different kind of ZK Lite clients, different kind of mechanisms on the verification layer, and of course on the execution layer as well, although it's not that crucial. And yeah, and this is just to give you a visual on how this actually looks like. So Hashi is like now, first version is already out. And the most important part is, shows essentially how a token bridge would work. Like, so one side is Ethereum, the other side is another chain, Gnosis chain in this case. And the interesting part is you can see different kind of, the orange boxes are adapters, so different kind of bridges. Wormhole, maybe you've heard of it. AMB is a bridge implementation of the Gnosis chain. Different kind of adapters, so Telepathy is a ZK Lite client by Synclab, ZK Bridge by another team. And essentially we are aggregating all of this into Hashi, and we have some governance module on top that will decide if this is secure or not. And yeah, then you can feel secure to release the tokens on the other side because you're secured essentially by 4 or 5 different bridges and not that just one. And yeah, that was it. If you want to learn more, just reach out to me or check on Gnosis website. Thank you very much.
Thank you very much. We would directly jump into the next talk. So next up is actually a crypto veteran, I would almost say, because Lucius Meiser founded the Bitcoin Association Switzerland back in 2013. And now he is the chairman at Bitcoin Swiss. On a small side note, he's also one of the crazy guys doing a PhD at the University of Zurich, and he's here to talk about Frankencoin. Please welcome Lucius.
Thank you. So, welcome to my presentation on the Frankencoin. So this is a PhD project, or started as a PhD project, but I also want to push this into real life to make it a network, to make it live on the Ethereum network, and to create an Oracle-free, collateralized, decentralized Swiss franc stablecoin. So I think there's quite a few things in there that make this a unique project with a real chance of becoming something that is relevant. So first, so I have these 3 points. I have a vision. I talk a little about the properties of the Frankencoin, and then I describe how it works. So the vision is nothing smaller than to democratize the creation of money. So today, money creation is done through the central bank with the help of the commercial banks. And the commercial bank, they multiply the money supply through their credit system. And the problem is this is a very centralized system. And at the same time, it's something very important. So whoever controls the allocation of money also controls the allocation of resources in the real economy. And this is not only through the interest rates, it's also through the capital requirements. For example, if capital requirements for government bonds are very low, banks can leverage a lot on government bonds and not invest or create money as much for startups or for other projects. And this has a real consequence. So what we observe in practice is that the regulation, the capital requirements, they push banks towards creating money for real estate and government bonds and to neglect small businesses or startups or more risky projects, even though they would be more beneficial to the economy overall if they receive the money. And this can change if we decentralize the creation of money, if anyone can create money. And this should unlock a lot of value if the economist and economic theory is right. So the question is, can we create a decentralized, fully backed stablecoin that does not depend on oracles and is open to any collateral? So these are the two requirements that so far have not been fulfilled very well. We will see a comparison later, and these are the main challenges I aim to tackle with the Frankencoin. So, by the way, it doesn't have to be Swiss franc, so this is just the first version. There could also be a copy of it with dollars or euros and so on. So, but here in Switzerland, we should have a strong Swiss franc on the blockchain, so that's why I started with that. So, but stablecoins are out there. So there's we've seen different types before, and I think it's a great time to start a new stablecoin because the centralized ones, they are kind of boring. They don't solve this economic problem. They are helpful, but they are not where we want to go in the end. Then there's a few decentralized ones, most notably DAI, which is a very interesting project. I think it's one of the greatest DeFi projects out there. One problem there is centralization, so it's de facto governed by a relatively small number of people, and it's also actually not that decentralized because most of its reserves are in USDC. And my favorite project on this list is besides Frankencoin, is LUSD, which did many things very well. Their main weakness, which is shared with DAI, is their dependency on the Chainlink Oracle, which can be manipulated anytime by the admins of Chainlink. So this is not that decentralized, actually, and I wanted to get rid of that dependency. Also, liquidity is limited to Ether as a collateral, which causes everyone who mints liquid US dollars to suffer from the opportunity cost of not being able to stake these Ether. So I hope to create something more flexible. And there's one deployed version out there, but it won't be the last. So at the moment there's a code competition running on Code Arena. I think there's 3 days left, where if you find bugs, you can get a nice bug bounty. So, yes, so I mentioned these properties. It should be oracle-free, collateralized. I don't believe in algorithmic stablecoins. They often have a weakness that they collapse eventually if people lose trust, like it happened with Ironcoin and Terra and so on. And I also think it should be completely decentralized so that it's truly democratic and it cannot be manipulated by a centralized entity. If we go a little deeper into the system, you will see that there's actually 2 tokens. So one is the stablecoin itself, and like many other projects, there's also a governance token, or a token that represents part. So this is like the share of, if this was a bank, if the whole Frankencoin system was a bank, one would be the deposit token, which is stable, and the other one would be the shares or the equity capital of the bank. And similar to the shares of a bank, you can also speculate with that. If you believe in a system, you can buy the pool shares. You will suffer if there are losses, and you will make profits if there are gains. So how does that work? So what I did as part of my research, I have one paper that is called the Continuous Capital Corporation, where I looked into AMMs for automatically issue and redeem capital of a company. And I found some solution that is optimal under a wide range of circumstances that can lead to the optimal capital allocation. And this is based in the end, so that I won't go deep into mathematics, but in the end, what you get here for this system is a function where you say the market cap is proportional to the reserve, and the reserve is the equity capital in this case, and the price and supply, of course, when you multiply them, they must lead to the market cap, and the price climbs with the squared cubic root of the reserve, and supply goes up with the cubic root of the reserve. So if reserves go up by a factor of 1,000, then supply goes up by a factor of 10, and the price goes up by a factor of 100. And this allows for a dynamic issuance and redemption of these pool shares. And if you put in money, your money is a little at risk because it's used to cover losses, like a bank's balance sheet. And if you sell them, you can take money out, and the profits and the losses also accumulate in that pool. So this is very similar to shares. Also, you get some voting rights with these shares. So if we dig a little deeper, we can look at it like a bank. So we can say the whole Frankencoin system has assets and liabilities. So, and on the liability side, there's all the Frankencoins in circulation, because everyone who owns a Frankencoin basically has a claim towards the system saying, I want to have 1 Swiss franc back at some point in time. Also, there's some reserves and equity capital. So there's a mint reserve, which I will mention later in more detail, which is kind of debt or Fremdkapital. So, and there's equity capital, which is the value of the system if you would liquidate it. On the asset side, you have so some people who provide collateral and mint tokens, they have to return these tokens. And the number of tokens they have minted and need to return, that's in this example 80 million. That's what they owe the system, basically. Then there might be some, we have a stablecoin bridge, there might be some other stablecoins locked in that bridge for conversion. And then there's the reserve that is used to absorb losses. And so this is more or less the balance sheet. And if the system makes profits, equity goes up. If the system makes losses, equity goes down, and the pool shareholders are poorer. So if you look at it more technically, there's a number of smart contracts. So each of these boxes is one of the most essential smart contracts in the system. There's 2 ERC20 tokens. So the Frankencoin and the pool shares. And the Frankencoin is actually very modular. So anyone can propose a new mint plugin. So this is to make it future-proof. Maybe you have a different idea than I did so far. So I so far had 2 ideas for minting plugins. One is the stablecoin bridge, where you can supply 1 crypto franc and mint the Frankencoin. The crypto franc is the Swiss franc stablecoin from Bitcoin Swiss. So we trust that stablecoin up to a certain limit, and anyone who provides a crypto franc can get a Frankencoin, and vice versa, as long as there are crypto francs left in the bridge. So this is a very simple AMM that's fixed to a one-to-one conversion. Then there's the collateralized minting hub, which contains all the logic for the collateralized minting with this novel auction oracle-free liquidation mechanism. But if you have a different idea on how Frankencoins should be minted, you are free to propose, to suggest a new minter, a new smart contract that then has the power to mint and burn Frankencoins arbitrarily. Of course, if you do that in a way that is not beneficial for the system, then hopefully the shareholders step in and veto your proposal. And that's part of the governance, so it's not a vote, it's just a veto. Anyone who has 3% of the voting power can veto any proposal. So, and the veto power comes from holding pool shares. And the same veto power you can also use to veto new types of collateral. So the minting hub also recognizes the veto power of the pool shareholders. And if someone creates a new position with a completely new collateral, that can be vetoed by the pool shareholders. But once it's approved and you can start minting. So how does that work? Let's make an example. So let's say, and here a lot of brain cycles went into it, making this really attack-proof. This is also a core part of my Frankencoin paper, where I look at it from a game theoretic perspective with decision trees, and I show it payoff matrices and so on, to show that this is really solid. Because there's a few problems with liquidations in the existing protocols. The first problem is they often depend on Oracle. And even if you get rid of the Oracle and say, we look at an exchange, there is the problem of price manipulation. And even if you do an auction, like in the DAI system, there's sometimes an auction under certain circumstances, there's a risk of price manipulation, that someone who does not want to get liquidated bids a too high price or things like that. So you need to design the system carefully in a way that is not attackable by someone who wants to manipulate it. And the solution I've come up with here is that we don't depend on anything external, we just use this auction mechanism. So for example, Alice opens a position and says, I want to have wrapped Ether as a collateral. I claim that these wrapped Ether are worth 1,500 Swiss francs each. And when you propose a position, you also need to propose a reasonable reserve ratio. This is like the haircut when you do collateralized lending. Yes, when you do collateralized minting. So in this case, maybe 20%. This means that when she gets liquidated and the market price is only 10% below what she said is the liquidation price, then we are still good. This is kind of a reserve buffer to absorb price shocks. And so when she does that, when she opens a position, she pays a minting fee or a proposal fee to make sure the system doesn't get spammed. Then if no one vetoes her position, she is free to use it for as long as the position is valid. This is also a parameter, can be 2 years, can be 1 year, whatever makes sense for Alice. So she mints 150,000 crypto Frankencoins, and out of that she receives 120,000, and 30,000 is automatically put aside into the so-called minter's reserve. This is used if there's a liquidation below the liquidation price. So now prices start to fall, and Bob says this is not worth, this collateral is not worth 1,500 Swiss francs per Ether anymore. So I challenge that. So and this is one of the key factors. When he starts a challenge, he has also put some collateral at risk and say, here's 100 wrapped Ether of my own. And now the auction, depending on who wins it or how high the price gets, the auction is about getting Alice's or Bob's wrapped Ether or collateral. So in one case, if the market price is still above 1,500 Swiss francs per Ether, the bidder gets Bob's wrapped Ether, and Bob gets the bidder's bid, and Alice is unaffected. So that means that as long as the market price is higher than 1,500, all is fine for Alice, and Bob gets to sell his wrapped Ether maybe below market price, maybe market price is even 1,600, 700, then Bob has made a loss and sold his wrapped Ether below the market price. So this is the case where the challenge is averted. But there's also a case where the challenge is successful. For example, the highest bid is only 130,000 crypto Frankencoin. In that case, the challenge is considered successful because the challenge has shown that the market price is below the liquidation price. And in this case, the challenger gets his 100 wrapped Ether back and a reward of 2% of the whole capital at risk, which is 3,000 Frankencoin. The bidder gets to buy 100 wrapped Ether from Alice, and his bid goes to the reserve. Also, Alice's minter reserve of 30,000 is allocated to reserve. So this is potentially a lot to gain for the equity holders, but we need to cover the loss from that as well. So basically there's a loss of 120,000, which we don't get back. So this gives a profit and for the system of, let me see if this is correct. Yes, should be 27. Yes. So there was a debt. No, there was a debt of 150,000. But I think you're right. Could be 27 because we got 30,000 back, and 130,000 is 160 together, and 3,000 goes to the challenger. Then it's 27,000 profits left. You're right. So yes. And Alice gets to keep whatever Frankencoins she has minted. And so this is the basic system. And there's a lot of small, subtle difficulties that could happen. For example, what happens if Alice makes a very high bid to fool the system? Then she just overpays. And it's very expensive. And the system is structured that even if she overpays to end the challenge, she cannot immediately withdraw everything and close the position. There's an opportunity first for the challenger to repeat it. So it can be repeated, and Alice will suffer infinite losses over time if she manipulates the system. So, and there's also other things that are thought of. For example, you can make a much smaller challenge. You can only challenge 10% of the whole position, then everything is scaled down. This is to make sure that you even can challenge the system if you don't have 100 wrapped Ether. There can be multiple challenges in parallel and so on. So I hope that every conceivable use case is actually covered. If you look at this of course, from a risk perspective, then there's this challenge period. So this challenge can run from between whatever is specified in this position, between 1 day or 10 days. So, and if in this period the price drops too low, then of course we have a risk that we have to cover a loss. Also, there's cases, especially if you use an exotic collateral, if you use the shares of a chocolate factory, for example, the tokenized shares of a chocolate factory, and the factory burns down, then the value of the shares, they go from 100 to 0. And then you have no chance at liquidating at a good price. And in these cases, the system covers a loss, and then you need to have some overview over all the positions and see how the risks balances out. And this is basically what the bank does. So your bank needs to know that what its risks are and how they are balanced, and if how the different risks are correlated. And this will be one of the harder and more difficult part in the long run for the governance to get right, to make sure that the risks are in balance and there's no bank run with a bankruptcy like you've seen in the real world. The main difference to the real world, of course, is that we have full transparency here. So no one exactly knows, even today, what is on the balance sheet of Credit Suisse. But here with the Frankencoin system, at any given point in time, we have full transparency and know all the collateral, we know all the assets, all the liabilities, and this would create a lot of trust, I would hope, and it would also allow an attacker to step in time and to challenge all the positions if the attacker notices that the value drops below. So we have built a front end for that. So this is on frankencoin.com. There's 2 screenshots. If you would like to join this project, let me know. Especially welcome would be someone to cover the front end and take ownership of that. But overall, I think this would be a very interesting opportunity. So we are a distributed team. I do a little bit. There's a few others, but there's no formal company or so behind. The idea is that the incentives in the end will make sure that the system works. And that's it. So if you have questions, let me know.
Thank you very much for the talk. So we have a bit of time for questions. Maybe there is one. Oh sorry, you can start.
Well, thank you for the presentation. Fascinating project. I really liked it. It seems like you're aiming at fixing MakerDAO. So it seems like MakerDAO was one of the major inspirations behind your project. And what you call a stablecoin bridge is very similar to the PSM in MakerDAO. And the PSM, like during the USDC scare that you have shown, it also proved to be a major weakness of the MakerDAO because it also made the price of DAI to collapse together with USDC, even though less than half of their reserves were in USDC. Because of the PSM, the price went all the way to USDC's price. And it seems like you have introduced the same vulnerability. Like, why do you need the stablecoin bridge? So that's my first question. Couldn't it work without the stablecoin bridge? And the second question that I have is with the particular choice of the stablecoin, the crypto franc, which is prepared for the situation, which is not the case now, but was the case like 2 years ago, that the interest rate on the franc was negative. And because of that, if you put Swiss franc in a bank, you're actually earning a negative interest rate, and the crypto franc also did the same. And if you're using, if that were the case again, then what you could do is you could take your crypto franc, which is depreciating effectively because your balance is decreasing, and get the Frankencoin, which doesn't have that problem, and kind of shift the loss onto somebody else. So these are my two questions. Like, how are you dealing with this problem?
So the first question, the answer is why are we doing this? Because it's very convenient. It allows users to get in and out easily. And of course, there's a risk. So there's also a limit with each stablecoin bridge. You specify what is the limit, up to how much can you deposit there. But of course, it's a risk. Then the other question regarding the crypto franc. So I built this system under the assumption that interest rates won't turn negative again. So it works well with positive rates, but under negative rates, everything is very strange and complicated. So I just said, I assume that this doesn't happen.
Great. So I think we have for one short question, and then after that we will set up the follow-up or the following panel.
Yeah, short question. So about the example you presented, the second point was assuming no one is vetoing. So I wanted to ask a little bit more in detail how the veto works. Is again with the 3% of the votes or the voting power, or is there also some negative incentive not to veto in a bad way, like for instance to censor some specific positions? And you can imagine that someone wants to uses collateral some specific token, and then you can identify and you say, I don't want this position, I will just veto it. So is there some fee to veto? Is it easy to veto? How does it work?
So if I understand correctly, the question is, can positions be abused to create Frankencoin with any collateral as an attack? Or?
No, I mean, the second point was, in the algorithm, let's say, it was said, no one is vetoing. So I just want to know more details on who is this no one that can veto. And
anyone can veto. So yes, so if you propose a new position, people who own 3% of the pool share votes, they can veto that position. And here, it's actually not just 3% of the balance of all pool shares, it's a time-weighted voting. So if you have held 10 shares for 10 days, you have the same voting power as someone else who held 5 shares for 20 days. This is to make sure that someone with a flash clone cannot manipulate the system. Okay. And then there's another, but this is one of the spots where it's still under construction, because this governance is very hard. I want to have so there's a few very important elements. One is, I don't want to have votes. I don't want to have explicit governance because that also creates responsibility. I want a veto-based governance because then, and this is a legal consideration, if you do nothing, no one can accuse you of having done something. Like in the legal system, if you actively kill someone, that is punished much harder than if you are just a bystander and watch someone drowning, right? So that it's kind of legal protection to say no one did anything, and it's only if you step in and veto and prevent something from happening, then also you're not liable for the whole system. So this is one consideration. And also, and this is even more important, I would say, it's much more usable if the system is designed in a way that if everyone behaves well, then you don't need to organize votes and step in and do anything. You can just sit there and watch it happen. So the system is designed that you only need to step in and veto when something bad happens, and if the threat of vetoing is credible enough, then no one will do anything bad.
Thank you.
Thanks a lot. So again, a round of applause to Lucius. And you will stay with us because we have now a panel on the Swiss blockchain community and ecosystem. We will shortly set the stage up. Yeah, it's on now. Yeah. You can I will quickly say some words and then I will hand over to you. Yeah, I will just say some words about them quickly. Okay, so I'm very happy to have this Swiss blockchain community panel here. I'm not saying much about the speakers' affiliation because they will introduce themselves in the panel. I just want to share some ways how I personally could profit from the knowledge of the speakers that we have here. So first of all, Lucius, that you've heard just before, I actually took a course with him at the University of Zurich. So he's a brilliant economist, and I could learn a lot about how the economy is working. So this was really insightful. Then we have Shiraz there. Shiraz, he basically knows everyone in the Swiss crypto space. I think that's no understatement. And he also knows a lot about the whole community and the ecosystem, and he helped me teaching bachelor students and telling them how the whole crypto system, how crypto ecosystem has evolved. Alexander, on the other hand, I met you today the first time, but you published a book in 2019 on Crypto Nation. I bought this and I immediately read it. I was really fascinated by this very interesting and great book at that time. So I'm very happy to have all of you three here. I'm also very happy to have Victor here from the Swiss NFT Association who will moderate the panel. So please, a big round of applause to the panelists and to the panel.
Yeah, thank you everybody for joining on Sunday afternoon for the last day of the Ethereum conference. Just short words to myself as well. I'm co-founder and vice president of the Swiss NFT Association, but also representing Bein Crypto, a crypto media company for which this conference has partnered up to do organic outreach. Yes, so all of you, as we heard, you're heavily involved in the crypto ecosystem with various projects, you're advisors or you founded companies yourself. Could each of you give a quick intro of what you want to focus on and what you have done in the past? Maybe starting.
Yes, so you've heard me before. I make it short. So I'm involved with Bitcoin Swiss, Bitcoin Association Switzerland, with Aktienrat, which is a company that tokenizes shares of Swiss companies. and with the Swiss Blockchain Federation, and as a PhD at the University of Zurich.
Great, thanks a lot. Alex, what about you?
It's great to sit next to Lutius. It is really one of the OGs. It's been around since 2013. If you check YouTube videos of Bitcoin Association of the good old days, I wasn't there. I'll join a bit later, but it's worth watching. So he has seen everything. And I think myself, I'm a bit in the same vein because I've been working in finance, but I've been a member of parliament for 7 years here in Switzerland. I've been in the army for 16 years, a very Swiss thing. And nowadays I'm working with different startups. I'm also president of Home of Blockchain.Swiss, which is promoting the Swiss ecosystem abroad. And I guess by listing all of that, it shows that I'm quite old. You're much younger than I am. And I think my big thing is, and my big passion is policy. And that sounds not very sexy, maybe to some of you, but hopefully I can elaborate why I do think that policy and technologies, and not only Bitcoin or crypto, but other technologies, AI, is really key, and it will shape the future of how we live. If we don't pay attention, it might not be such a good future. So that's why I'm here.
Great, yeah, definitely. We can go into the policy as well. What about you, Shiran?
Yeah, fantastic. Maybe complimenting Alexandra there, bringing a little bit of the youth to the panel, potentially. Having been involved in the Crypto Valley ecosystem now for the past 6-7 years, I held various different roles, but 2 that I hold at the moment. So being the co-executive director of the Crypto Valley Association, we host a lot of events, webinars, networking activities. So any education that you're looking for, Crypto Valley Association is there always to help. And I'm also the managing partner of Stone Partners, one of the leading 360-degree service providers in Europe, where we help essentially companies to scale and enter into the Web3 space. So yeah, I'm looking forward to speaking more about the blockchain ecosystem in Switzerland.
Awesome. Yeah, let's kick it off with the first question. So what are Switzerland USPs for the blockchain ecosystem? What differentiates it to the global market?
So maybe I start, yes. So we have some good advantages and some disadvantages. But one of the main advantages where we should make much more marketing about is we have really solid laws for the storage of crypto assets. So if you store crypto assets with Bitcoin Swiss, for example, and we do it right and we know how to do it, then you have a direct legal claim onto your Bitcoins and other crypto assets. So regardless of what happens with us, the Bitcoins are yours. So the law basically says, not your keys, still your Bitcoins. And this is different in other countries. For example, if you store Bitcoins with Coinbase and Coinbase goes bankrupt and the IRS says Coinbase still owes us taxes, then maybe IRS will get your Bitcoins to get the tax liability. Who knows? It's unclear, but in Switzerland we have cleared that. And I think this is a very important advantage that we have and that we don't use leverage enough.
Okay, so we have a clear policy in the country. And then, Alex, you were saying that you're promoting Switzerland also abroad. What would you say?
Actually, just talking about my own book, we're going to publish, and you know, Lutz, we're going to publish the first digital asset custody report. And Bitcoin Swiss is in it as well. And I think custody is at the origination of everything else that will follow. If you cannot safekeep your crypto, everything else doesn't make sense. And we just, we found out the hard way with the FTX and Coinbase as well. And Switzerland really has an advantage, and it's still a complicated issue. And again, coming back also, Lutius has been instrumental in drafting this DLT law and the custody. So you know a lot about that. And it's a very good example how policy creates a new ecosystem. So sometimes in this community, people say regulation is bad. We don't want that. But here it's a clear example. If you have good policy and a good framework, certainty of law, then you can create adoption. So I do think Switzerland has been very good in adjusting the framework, but also a regulator that has been, listening to the community. I mean, I remember very well when the ICO guidelines came out. That was in early 2018, and the Swiss regulator back then, he went on a roadshow. He went to Ticino, he went to Geneva, to Zug, and explained that to the community. I haven't heard of any other regulator in the world who has ever left their offices to meet. In the US, the regulator will send you a letter saying you provide by Friday, and if you're not, you go to jail. So the Swiss ecosystem has always been at arm's length, and I think it's a cultural aspect, but it's also the way Switzerland from a very grassroots federal level works, and it has been a good fit with blockchain technology so far.
Yeah, fantastic. I think to add on to that, I think it is really this level of stability that you get in Switzerland. The ability for you as an entrepreneur to be able to grow your business here without maybe the laws changing every other day, or without there being, let's say, one body that can just one day to another just change everything within the environment. And if you look at, let's say, one of the fables of Jean de La Fontaine, you know, it's slow and steady does win the race. You know, if you look at the hare and the tortoise, I do believe that Switzerland has had some years of advance on some other countries, having like had Ethereum being founded here in a lot of, let's say, the early days. But I think that Switzerland has always kind of taken their time to set up the various laws, to build the ecosystem, and has never gone too far ahead of itself. Whereas you look at other countries back in the day, be it, let's say, Malta, or be it other regions that have really tried to fast forward a lot of Switzerland that took a lot of its time to build up. And the fact that we've been advancing slowly but surely has, I think, created a lot of its accumulated success so far.
Mm-hmm. And Lucius, you were mentioning also maybe some negative drawbacks. What would something be in that area?
Yes. So one of the strengths of the Swiss system is a principle-based legal system. So that the law is much less detailed, or is supposed to be much less detailed than in other countries, and that gives more freedom for the executive and for judges and for scholars to create the right interpretation of the law. And this freedom can be used for good and for bad. And what I see a little is FINMA tends to interpret it on the more restrictive side. So there's one thing that we also criticize from Swiss Blockchain Federation, for example. They say if a Swiss bank issues a stablecoin, then they essentially need to identify every single holder, so they basically enforce the whitelisting. And I think this is very destructive, because a stablecoin, in order to survive, needs to be freely transferable. Maybe you can do a blacklisting like that have in the Tether or so. This I think might be a good solution, but you need to build it on the premise that the users are good, and the users should be able to freely use it before, and not have to register in advance with a centralized entity, because then you destroy the advantage of the blockchain technology again. And I think here there's a lot of work to be done. But another risk, of course, is that we don't actually have that much freedom and political willpower to deviate from international norms. So Switzerland, and I think that this is a good strategy overall, Switzerland always says we need international norms, all the countries need to adhere to the same standards, and this helps us as a small country to survive. If everyone adheres to the law and common standards, then we are protected from the power play of big countries to a certain degree. But that means that we, as a strategy, always implement all the international regulations very quickly, even though if they are nonsense. And we have seen some nonsense rules recently coming, for example, from the Basel Committee, which is very crypto hostile. So they created capital requirements like completely, it cannot be justified with mathematical risk models. They say, for example, a bank can have at most a crypto exposure of at most 1% of its tier 1 capital, which is complete nonsense. So all the tier 1 capital of all US banks together is 2,000 billion. 1% of that is 20 billion. So essentially they say on all the balance sheets of all the American banks together, there can be at most 20 billion of crypto. Otherwise it's too risky. And this is, I don't know, it's a political attack against crypto, because obviously they don't like it. And now we have this difficult situation that there is adverse malevolent laws coming in, or standards coming in, and we have this clash of policies. On the one hand, we should have the rule of law, we should have freedom, we should be freedom of economic freedom to do business in whatever way you like, as long as it's in compliance with all the good, with the reasonable regulation. And on the other hand, we have this principle to implement all the international standards. And there's a big clash here, and I'm afraid that our government will simply say we implement the international standards even if they are completely stupid.
And maybe you two, are you, the companies that you're working with, are you creating regulations, or are you in contact with the government to oppose these regulations that will be set in place that would be negative for crypto?
The Swiss Blockchain Federation has working groups that is in contact with the regulator, and the Bank for the International Settlement as well. But I think maybe just to take one step back, because the panel is blockchain, and I know Lucius, I think that there's a lot that is applying to crypto. And what I have been seeing in recent weeks or months, I think if you talk about blockchain is foundational technology that allows different use cases. Crypto was the first one, Bitcoin, and it has many, Ethereum and all that. So there's a lot of built on that. But what I have been seeing, and where Switzerland at least is, I think, quite at the forefront, is when it comes to tokenization of real-world assets. And I mean, your company do that as well, Octanaut, with SME shares or with digital bonds. And the Swiss National Bank is gearing up for a first live CBDC trial for digital bonds. So there's a lot, and that's simply, it's a different regulatory framework. And you can also see that in the EU, because the EU has this new MiCA guideline, which is about crypto. So anything that's sort of, Bitcoin and Ethereum, Dogecoin, all those things. And in MiFID, they now make amendments for real-world assets. So if you're going to transact bonds on the blockchain, there's different sets of regulatory. And I think thirdly, and maybe Cheryl has also more to say about that, everything that is Web3, NFTs, creative economy, that's, again, a completely different ecosystem that doesn't have the same challenges. So I think it really depends on what sector you look at. And I think historically Switzerland, with its financial center, has a lot of touch points with the crypto side of things and with Bitcoinization and all that. But I hope that Switzerland can sort of reach out and not only be strong in there, but also when it comes to tokenization of real world assets. There have been recently Lugano, the city of Lugano, created the first digital bond. So there's a lot of experiments as well. And also in the Web3 space. And maybe just one negative thing about the Swiss ecosystem, and it's a conundrum in the whole developing, in dev world or software development world. You don't need to be anywhere actually to develop tech anymore. And I think what we've been seeing here, sort of the thriving startup ecosystem, it's probably not in Switzerland. We have some interesting startups, but because of the living cost here, I mean, people are developing. In Asia is very strong, even US is very strong, you got Eastern Europe is very strong. So I think, as we've seen in other sectors, like developing a thriving startup ecosystem with developers and entrepreneurs, I'm not sure if Switzerland is the strongest here, and there's room for improvement.
Mm-hmm. Definitely.
Yeah, and I think speaking towards some more of the challenges of Switzerland, I mean, I'm definitely a big Swiss maxi when I go abroad, but we have to be neutral sometimes and kind of evaluate some of the critical points. I think the main one for me is access. Access on, let's say, the HR perspective, the people, a little bit to what Alexandra was saying, and then kind of, let's say, the capital side, where we all know that Switzerland is quite an expensive country as well. So without the appropriate funding, let's say, be it in a seed stage, private sale, etc., it is quite hard for some entities to be able to come to Switzerland to be able to incorporate or even to kind of, let's say, start shop. The same goes, I think, with the human side of things. If you have a big team, it's very hard to bring a lot of your team members here, be it for, let's say, visa problems. I mean, I know that we're going to discuss a little bit about other jurisdictions as well, like Dubai and the likes, but I think that's definitely one difficulty as well, where we do say that Switzerland is open to the world, but it is difficult as well to access that for some individuals around the world as well. So yeah, the people side of Switzerland can be a little bit difficult at times, and then also, let's say, the fact that Switzerland is an expensive country, but then when you look at value, I think it does provide the value for that expense that you're paying for, but it's not always at the access of everyone.
How do you see it with the global dynamic? So US is cracking down more or less on crypto, and then also in Europe, other countries are coming up, like Germany, for example. There's a lot of things happening there, France as well, and you mentioned Eastern Europe, but also in Asian countries. How do you see the dynamics evolving now with US being more regulated, or fear of US being more regulated?
I think literally with MiCA and also what's happening in Germany, KfW is now doing digital bonds. So the Germans have really caught up to this opportunity of creating, I mean, they have this digitales Wertpapiergesetz, whatever they translate into English. So they were sort of following suit of what Switzerland has been doing. And it's a bigger market, so they're driving that. And then you've got other countries. I was recently in Serbia, and they also have a new blockchain or crypto law, which was very interesting because in that law, I didn't read it entirely, but coming back to what Lutzer says, Switzerland has a principle-based approach, and the Serbians decided they're going to write the content table of the white paper into the law. So in the law, it says exactly what the white paper needs to look like. And I think, when we have the discussions, I mean, the legal framework is key, but there's different aspects. There's the HR aspect, there's the compliance, there's the tax aspect. Switzerland sort of has a bit of a lead because we have more experience. But we're sort of bumping into the same issues we have often. You know, we're a small country. The home market isn't that big. So if bigger markets come online, like Germany or the UK now, trying to be more crypto friendly, let's see. So we're still in the race. And I think like everywhere else, Switzerland has to sort of think about where are our strengths, where can we focus on, where can we have a lead, and where maybe other countries are just more attractive. You know, and I think this is still in development.
Yeah, definitely. And just to bounce on that point, I think Switzerland is one close to now, it's come close to a decade, that it's one of the most innovative country in the world. And I think that really happens at the grassroots side of things. But then we do face a certain brain drain when it comes to the fundraising. If you're going for a Series A, it's much easier to do so out of Switzerland, be it in the Americas or in other regions of the world. And I do believe that maybe we can counteract that now with some of the things happening in those areas, that due to, let's say, the regulatory frameworks of Switzerland, Europe as a whole, we can bring back some of, let's say, that brain that kind of went to maybe the Silicon Valley or other areas of the world and bring it back to this region. So I definitely believe that it is Europe's time to shine now.
Mm-hmm. Yeah, for example, the Post Finance is now offering to their customers that they can buy Bitcoin or Ethereum with a partnership with Signum. Do you see this as a positive development, or will this draw more and more people to use blockchain technology?
Definitely, this is very positive. So it makes crypto more accessible. Of course, it means that companies like Bitcoin Swiss need to think about where can they still add value if everyone already has crypto with their own banks. But there's plenty of opportunities, especially in DeFi, where we can be pioneers and offer access.
And do you think this will drive the Swiss ecosystem forward if we look at it from a competitive state, for example, inside of Europe?
Yes, it certainly will drive adoption. It could also help for crypto being used as a payment currency, which is, I think this was the original idea behind Bitcoin, peer-to-peer cash system.
Yeah.
But it's not used that much for payments. It's mostly used for DeFi, which is also fine, but it's not. There's still a lot of untapped potential for payments.
Did you want to add anything on that?
Yeah, I mean, regarding the retail side, I think it is great, or at least I hope it is. You know, if you go outside of this kind of, let's say, room, or to a certain extent maybe an echo chamber, sometimes you go out and get your train, you speak to anyone about crypto, they're going to have a negative connotation towards it. At least most people, they might say it's scammy, they might say I'm not too sure if I trust it, etc. So I think and I hope that Post Finance and the bodies around there are bringing out educational programs around that offering, because just being able to buy an asset, and it depends on how you look at, be it Ethereum or Bitcoin, but just being able to buy an asset class that is volatile is important to be able to have the certain education of understanding the risk assessment of what you're buying into, so that we don't end up getting into a new, let's say, bull run where retail is buying in heavily again, and then it goes down and they kind of say, well, I was able to buy this at Post Finance, this is a scam, etc. So then being able to understand what they're actually getting into, I think, is very important. But ultimately, it is good that there is that access.
Yeah, you were talking about a good point there, education. So to educate also the masses or the individuals. Are you yourself working on this with CVA or Storm, for example?
Definitely. Within the Crypto Value Association, I think that is the ethos of the association, is to be able to bring further integrity to the space. We have started an international expansion as well. Due to the pandemic, doing a lot of webinars, a lot of events online. We do see it as being quite important. We have working groups that are able to accommodate to the niches of, let's say, the blockchain world, be it from a regulatory standpoint, investor working groups, cybersecurity, etc. So we always do try to be as inclusive as possible. But I think, you know, we've been going on about education for the past, let's say, 7 years that I've been involved in the space. I think it always is quite difficult to be able to grasp for various individuals. I think it has been difficult for us to be able to give that certain level of education. A lot of individuals are asking me sometimes, okay, but when is blockchain going to have its ChatGPT moment? And then I kind of refer to Bitcoin. I was like, well, look, it has all this access. It has done some of that. But I think we still need to be able to provide that certain tangible use cases potentially, and that education through maybe different means. Maybe Post Finance is a mean there where you associate cryptocurrencies with a trusted brand already, and that kind of helps to for individuals to kind of lower maybe their guard and be like, okay, maybe this is something that I should start exploring. And then potentially there are other ways, such as, let's say, the University of Zurich, a lot of things that they're doing, and the likes.
Mm. And on a national level, like Alex, for example, you recently joined the Smart City board to help out with that development in Zurich, correct? So is that a hint of what's going to happen in the future?
Actually, the smart city engagement is because I'm working with AI companies as well, confusingly. The cities in that sense have no crypto policy or blockchain policy yet. But maybe just zooming out again on your question, because I think the international comparison is interesting, and where I think post-finance is really a strong signal of how Switzerland has been approaching the topic. The Swiss government and the Swiss regulator said back going to, the ICO guidelines even before, I think the FINMA opened a fintech desk in 2015. It's not only for crypto, but they had a fintech desk, say, hey, there's new developments happening, we want to understand. And the Swiss regulator always had the approach, we're going to give licenses if you adhere to the rules. So in Switzerland, if you think about it, we have crypto banks, we have Swiss registered crypto funds, we have brokers, you can have the depositories or custodians, you have a lot of different licenses type. And the approach always has been in Switzerland, those are the rules. You can even have a discussion where we're happy to discuss. Bitcoin Swiss had a not so successful discussion with the regulator about the banking license, but at least there is discussion going on. And I think that was always the strength of Switzerland. If you compare it with the US, where even nowadays the two regulators, SEC and CFTC, are still discussing or arguing who's in charge, obviously that doesn't make for a good framework. Or if you compare with Singapore, which has had this discussion before, Singapore when they came out with regulation, they said, oh, we understand Bitcoin is payment, so we're going to give payment licenses. So they only gave out payment licenses, sort of cross-border payments. And they haven't given any banking license, they haven't given any fund license. And what you have seen is now with 3 Arrows and some other accidents, if you as a regulator don't let innovation happen, then it might happen, it might still happen, but not in a good way. And I think, and that's also maybe looking at the negative side again. I mean, if POS Finance, hopefully, I have no doubts, with Signum, they have a very robust setup, but coming back to what Cher says, obviously the moment there's a big fallout, there's political action. If you don't believe me, just look at what happened with Credit Suisse. They just had a session this week. So I think the risk from a regulator or from a policy side is how much regulation do you let happen, and saying basically those are the rules. If you want to play according, then we give you a license. How much prosecution or sort of prevention you want to do, and what do you do in the case if something goes really bad? Touching wood, I think there hasn't been a massive fallout so far in Switzerland. But I do believe one has to be careful when one sets up, the post-finance. I know they've been working at it for more than 3 years in different configurations. So on one hand, you can say, hey, it has taken so long. This is not good for innovation. On the other hand, if something then goes wrong and post-finance is sort of semi-government owned, that would send a really bad signal. So I'm just trying again, a bit of my policy angle, where you have to balance those two sides, where the community wants to go fast, and maybe from a political voice, sometimes you got to say you got to be more careful. I do think up to now it can be debated that Switzerland has struck quite a good balance. Not always. Also, when it comes to travel rules, there's sometimes a bit of an overreach, but let's see. And I think last but not least, I think with MiCA coming into place and other countries coming online, this will create, again, more competitive pressure and will make it also more acceptable in a broad term. So one of the positive things, I think, this year, despite what happened with FTX, I haven't heard anyone saying crypto should be banned anymore. I think everyone sort of has accepted that it's here to stay. But we need to keep working on the framework. So I think, overall it's positive, but regulation and policy obviously slows things down. That's the idea of policy. but it's not liked by everyone. And getting that balance right, maybe also, I think you're more active in the Middle East. I've never been. I get a lot of requests. I mean, Dubai at the moment seems the place to go when you want to go fast. I don't know, maybe that's an interesting topic. Even I struggle with, is that good or is that bad? I don't know. Do you?
Yeah, it is a difficult one, and I'll definitely touch upon that. And just to close what you were saying before, and if you look at like the way in which Switzerland has adopted crypto, I think it's really been kind of, let's say, a top down, right? And let's say the down being, let's say, the retail, and I'm very happy again that they are getting to that point. But I do believe that we've missed a little bit of a layer there, whereby we work with a lot of innovative companies, startups, etc. And it is still very hard today for startups to get a crypto bank account. We do parade SEBA, Signa, Merki, etc., but we all do know that they do have certain capital requirements, and it is quite difficult for young startups to get bank accounts with them. So I would have seen it as being much more helpful or even fruitful for the ecosystem if PostFinance would have said, you know what, we're opening accounts for startups that might not have significant funding. If they pass the appropriate due diligence, they can get access to bank accounts. And some might say that that's actually today it is possible, but we have seen that it is a big struggle. And so potentially with small to medium-sized businesses being able to open crypto bank accounts in an easier way or in a more democratized way, it would allow then for the retail audiences to be able to then use their digital assets, crypto assets within, be it online or in a retail format. So maybe that layer, in my opinion, could have been filled a little bit better, but potentially my colleagues here have something to add on that front.
Yes, there's often very basic things that are not easy. Or if one of the founders has an American passport, also very hard to get a bank account. There's things like that should be fundamentally, it's basic infrastructure of a country, and it's interestingly still very complicated, do very basic things, and this is a long-term problem. Also, when I talk to someone with a crypto project, say one of the problems is at least 50% of the brain cycles go into legal matters when you do a crypto project, and he says it's way more, maybe 80%, and this is bad. This means that 80% of the resources are essentially wasted. They are not used for creating something, they're just used to navigate the legal system. And only 20%, or I'm not that pessimistic, maybe 50% goes into actually building a useful product. And this shows that there is still a lot of potential to make better laws, and this concerns everyone. This does not only concern crypto. So there's many areas that are over-regulated, where every step feels like walking in a tar pit, where you're held back by a lot of rules and regulations. And interestingly, it's not only government regulation, it's also within large companies. That's why large companies cannot really innovate. Like Google or Facebook, they struggle with innovation. They have to acquire innovation because they are so large, they have so many internal rules and regulations that it's very hard to move freely.
So with aspect of innovation and regulation, what would you propose? Is it better to innovate or to understand the regulation and then safely start your company?
So there's two angles. One is the macro angle. As a country, we should make it as easy as possible to create a company, because innovation comes from the small entities, not from the big ones. So they should be as free as possible to create things and to focus on product development and so on. And for a company, if you create a startup, you cannot get around having a holistic view. And ideally, you have someone who in the same brain unifies the legal, the economic, and the technical perspective. Of course, this is the ideal case, and in practice, you need to distribute often. But it adds a lot of complexity that you have to cover all three angles. And you can have the best technical product. If you have no clue about the economics or the legal angle, then you have a problem. So you need all three.
And with what you mentioned before, that the Credit Suisse collapsed recently, and other banks in the United States, and then before that crypto entities like FTX, Circle, and so on. I mean, that's kind of an indicator that there would be more regulation rather than less to prevent these things from happening. How do you see that outlook in Switzerland? Will it cause ripple effects? What happened to Credit Suisse?
Maybe not for crypto or blockchain directly, but clearly the financial system has now a good name. No one likes bankers. I'm not sure crypto people are more like than bankers or not, but it's sort of, I think the problem with finance is, I once asked Mark Branson, the former CEO of FINMA, why do we need regulation in finance? And he gave a very clever answer, and he said, it's very easy to run away with other people's money. And it's true, we've seen it with FTX. Unfortunately, it is true. And sort of, I think, one of the challenges of blockchain, but it's not only blockchain, like I said, I mentioned, I'm also active in AI, and I think AI goes very much in the same bucket. If something goes wrong at those systems, because there's such scale and such speed, the fallout can be really bad. And whenever there's a big fallout, and that's sort of anonymously across the world, whenever there's a big fallout, politicians will jump up and say, this is bad, we need to regulate, we need to kill it, we need to stop it. Credit Suisse, we see it live here. I've seen it with, if you Google it, the Monetary Authority after the Three Arrows disaster, they came up, we're going to explain why we still like crypto, but in what way, because they've been very open and positive before about crypto, and now the reality is, to what I'm talking to people there, they're really tightening the screws. So the challenge when it comes to innovation is, you want to let it happen and grow, because you can't always regulate beforehand, because sometimes it's very hard to know what's happening. At the same time, you need to prevent really big fallouts that is impacting a lot of people. So a lot of companies have been adopting sandboxes. They're known in UK, in Singapore, Switzerland is sort of the fintech license. But I think we haven't been that strong. So I would like, if I had a wish, we could see more sandboxes where we're saying, we contain it, you can play around, and we watch it, and we learn. And last but not least, one point I'd like to make, because often, to what I stated before, when you have conferences like these, people say regulators are bad, regulation is bad, it kills innovation, we need to. But on one hand, you have this fallout problem. The other thing, I was at the OECD Blockchain Policy Forum last October, and there was IMF, FATF was there, World Bank, OECD was there, and they literally said, we don't understand it. We literally don't know what's going on. And it's very hard to police for us. So you have, when it comes to education, it's not about education of the users. It's really hard. And I recently was at a panel with the FINMA about NFTs. People ask, what is an NFT? And FINMA said, we don't know. And it's like, NFT is a word. So what they do is you have to present the white paper. They read the white paper, and then they come to a conclusion, you have a discussion with them, but it's actually very hard to understand. And sometimes when you talk to crypto people, the lingo is a bit bewildering. It's not always that clear when you look at, I have a long list of funny quotes where people talk about that. So I think you need to sort of strike a balance between also educating the regulator, because the regulator at the end of the day has the responsibility, or should have the responsibility, to protect the wider society from big fallouts while allowing innovation. Obviously, when you start up, the only thing you think about is innovation. I want to go to market. You don't think about society. But coming back, AI, it's not a topic here, but I think what is happening in AI at the moment is it's a seminal moment in tech and humankind, and it's very hard to understand. Even for politicians, you had contact with politicians in Bern. How many understand blockchain? Most people don't understand blockchain. So when there's this mistrust, obviously, the natural reaction is we want to stop this. We don't understand it, And I think it's about us. It's for all of us. We need to find a balance in society of agreeing what kind of innovation we want. And that's very hard. I don't know, that was a long answer to your but I'm really, I can tell, I'm sort of passionate about it, and that you're in the room, it's your future.
Yes. It also means that you have to innovate responsibly. So you have to make sure that what you do is actually useful and not just taking away someone else's money. And this is, I think, this is also how we win the hearts and minds of the public, if we can deliver actual value and not just another way to rip someone off. And so as a small example, when I designed the Frankencoin system, I made sure that the economic equilibrium is in a state where about a third of all Frankencoins in circulation are in the reserve. which is a lot. This is much more than the 10% Tier 1 capital that the banks have today. So it is a much higher, more safe capital requirement that I have kind of built in. Of course, there could be a competitor who says, I copy the whole protocol and have a different requirement. But I think it's something that we should strive for to make sure that what we do delivers value. And then we can also win on the public and the regulatory front, because it's very easy to attack crypto if it's mostly used for ransomware.
And yeah, let's zoom in also onto the country level. So we have different hotspots for the blockchain ecosystem in Switzerland. So like Zug, Zurich is coming up. Geneva is also quite active. Maybe Shiraz, what's going on in Geneva and how do you see it different?
Yeah, okay. I mean, I have a little bit of a controversial kind of one to this point, and I hope, let's say, the panelists will maybe give another side of the coin. Is that I believe, a common thread of innovation is kind of stay foolish, stay hungry, right? And crypto's been around, or blockchain within Switzerland has been around for quite some time. And if we look at, let's say, the foundational layers of where things came to be it in, let's say, the Zug area, I do believe that maybe, let's say, Zug as a region has become not complacent, but they have a lot of requests. They are very well known now, and I think they are less hungry than they maybe once were. And I think that can be a good thing as well, because it's allowed other areas of Switzerland to expand, be it, of course, let's say by proxy Zurich, but also Lugano with the Plan B Forum. We've always had, let's say, Neuchâtel with the Bitcoin Maxis, and now actually Geneva as well. And of course, to a certain extent, I'm biased because I come from, let's say, that region, but I do believe that the French-speaking part of Switzerland has not maybe have gotten so much attention on that front, and it's something that I'm very much looking forward to building up, because within Geneva there is a very important industry, or many different important industries, from, let's say, the NGO perspective. There's a lot of watchmaking, there's a lot of large enterprises, etc. And I do believe that if we can create more consensus around, let's say, Switzerland as a whole, and not just, let's say, the Crypto Valley being known as Zug, but let's say the Crypto Valley being the whole of Switzerland, potentially as well bridging, let's say, Liechtenstein. Within that, I think it's going to create a lot of prosperous outcomes. And yeah, very much looking forward to building that out some more.
And what about you two? Do you have a favorite city or a specific stereotype or preference? Or how do you see it in Switzerland?
Within Switzerland?
Yeah, within Switzerland.
It depends a bit what angle. I've been involved with a few companies who want to come to Switzerland. Obviously, first they don't know. Everyone knows Zug, so that's always popping up. So I think that's the de facto setting for anyone. And then, I mean, Lucerne has been trying very hard to attract companies. Zurich has just advantage. I mean, some of the crypto companies are here, or blockchain companies, because it's just the best place to live. Not everyone wants to live in Zug. I mean, Ticino now has this Tether support initiative with this co-working space. So there. And I think at the end of the day, coming back to what I said initially, it's the beauty about Switzerland is this grassroots approach that is very much, it's decentralized, very much like the blockchain idea. And if you think about it, and if the cantons, I mean, the city, I give an example, the city of Lugano issued this digital bond. It was actually the city of Lugano who also started Plan B. It was not even the canton, it was the city. So the beauty about Switzerland is that every canton can try out. And if something sticks, then other cantons will come and try to copy it. Now, Zug is now active, but now, for example, Geneva, the canton of Geneva now is in discussion. And so a lot of them are now waking up to that fact. And again, even within Switzerland, you got different tax regimes, you got different, rents, or even when it comes to visas, it's very hard in Zurich. Zug, I don't know, I have no concrete experience, but maybe you go to another canton and then there's different visa quotas. So again, it's a very dynamic situation. But it can also be a bit bewildering to foreigners, because they go just to, if you go to Dubai or to Singapore, it's basically one city. But I think this is, in this pluralism, Switzerland can test different concepts. And Zug has a very good reputation, but I still remember, it's a bit of a funny story, when Plan B announced last year they're going to go ahead, they had a meeting with the canton of Zug, the finance department, and there was a lot of media reception about this Plan B. It made it in global headlines. And one of the headlines was, now you can pay with Bitcoin at McDonald's. And then I had to listen for about 10 minutes that, Zug, obviously you can do that much longer, you can pay taxes. So Zug was really pissed that Lugano got this, publicity. And I even had to tell them, well, you know that, Lucius, because of Bitcoin Swiss, you can even pay with your credit cards in Bitcoin through the terminals. You can do that already. I bought a bicycle helmet last year as a publicity stunt. But anyhow, so it's sometimes when you look at the cantons, this is a good dynamic in Switzerland, because if someone pops up and does something so successful, it literally can piss off other cantons, and they start then moving ahead. And I think it's overall still a positive dynamic, because if something then takes root, they become more vocal, and hopefully coming back to the national politics also then tell their representative, hey, we need to look into that. We can't just kill it. And I think coming back what I said before, no one now is saying we want to kill Bitcoin. And also one of the few positive things out of the US, what I'm seeing, you see literally adoption when it comes to big financial institution. From exchanges, NASDAQ is working on tokenization programs. You got the big Wall Street firms coming. It's not always, fully forced adoption, but I think it has reached a level where everyone thinks it's not going to go away. It's not going to get killed. I do believe that Americans, as they've always done, they will sort out. They'll put a few people in jail for the rest of their life and make it very public. But they'll catch up again. And I think, again, I'm really enthusiastic at the moment, because Europe, with MiCA that's coming in force next year, has decided to create the framework. And if you look back at historically, the Swiss Financial Center always had the challenge how to access the European market. And actually, we've done quite well. The banks are still around. Well, one less, one less. But overall, we've done. And I hope that this is a skill the Swiss have. We're actually very good in making bridges and building bridges. And Singapore is another point. Among the top 10 financial institutions in Singapore, 6 are Swiss. So we actually, it's our strength. Because we are small, we need to build bridges, we need to go abroad. And I think this spirit gives us an advantage overall, despite all the negative things that exist. So I'm still positive. It's a good location to start.
Very nice, yeah. And taking everything as a whole, what we talked about some negative and then also a lot of positive points. What's your feeling, Lucius? Are you more bearish, bullish?
I am very bullish. I'm optimistic. I see a lot of value being created. So that's what I criticized before, that maybe we should focus more on value. But there is value. And once I was in a panel with a German policymaker who said there's no value in blockchain. It's only financial applications, these ICOs and these things. But there is value in financial applications. So maybe we don't use blockchain to do some logistics, because there's always friction when you connect it to real world. But being able to finance things is essential for an economy to thrive. And if we have innovation in financing projects, be that through tokenized assets, through DeFi, through completely decentralized organizations, so there's so much innovation out there. Uniswap has now more trading volume than Coinbase, I've seen. Mm-hmm. And it can compete with the Swiss stock exchange, which is crazy. So there's a lot of value being created, a lot of economic activity, and this makes me very hopeful.
Great. What about you, Shirans? What's your outlook?
Yeah, I think bouncing on what Lucius and Alexander were saying, I think due to the competition, but the healthy competition of Switzerland, and due to, let's say, that mini sandbox that it does create, I'm very bullish for Switzerland as a whole, very bullish for crypto as well, as we've seen this year. I think we have learned from some of our mistakes, and I think it's going to be a really great year ahead. Quite bullish.
Great. Did you want to add anything, Alex? Or you're also bullish?
I want to ask Lucius if he's ever been not bullish, but since I know he's been bullish. But I think there's a lot happening beneath there. And coming back to what I said, don't look just at crypto. I think crypto is always the bubbly, the speculative, sometimes the unsavory bit of the whole system. But the tokenization of assets, I give you an example of a company I'm involved in. One of the biggest markets in the world is the capital markets for bonds. This is where governments and states and cities refinance them. This market is still nowadays a so-called OTC market, over the counter. There's no central settlement system. And why is that a problem? Because last time in 2007-8, we had the financial crisis. It literally took the banks weeks to figure out what kind of counterparty positions they have. So this is a very old system. I do believe in payment. I know you mentioned that payment sort of works nowadays, but there are massive markets out there that run on legacy infrastructure. And if blockchain just enables better transparency from a risk point of view, this is actually good for society. And the company I'm involved in, it's a Luxembourg-based or Portuguese, and they now have a lot of traction by regulators, because the regulators are saying, we're afraid, because interest rates are now going up. If 2007-8 happens again, the same disaster will happen. We literally don't know what the counterparty positions are. So I think that's a very positive thing. And on a very fundamental point of view, I've been in this space for 7 years. I think the best thing is that I see all those people here listening to we're talking about monetary policy, capital markets, technology, policy, regulation. I've been recently to an event that said, I think the regulators, even the Bank of International Settlement and Augustin Carsten, should be happy that so many young people now thinking about the financial system again. Because it's not this abstract thing that happens, that banks do. We should all be involved because it has real world implications in how we live. So on that, I have to be bullish. And it's great because it exists, and I always, as I've said that before on another occasion, if the Bank for International Settlement or OECD, if you presented back in 2008 the Bitcoin white paper to them, they would have said, no, we don't want that. They would never have said yes to this idea. But it happened, and it's out there, and because of that, they now have to respond. And I think this is overall a good trend for society. So it's out of the box. Let's have a discussion about it. And we can have different views, and different countries will have different applications or rules, and that's a good thing. I believe in competition overall, and this is what is happening.
This is excellent. I think people sometimes don't think it's much more efficient if you centralize, if everyone decides in one point in Brussels for all of Europe or in FATF for all of the world. But this is not good. If you have a regulatory monoculture, then you cannot innovate anymore. Then you can never figure out if there would be maybe different rules that would enable for more growth and more innovation. So it's very, very important, especially for a sector that is young, to enable different approaches and to allow different approaches. And that's also one of the reasons why I think it's harmful when the Bank of International Settlement tries too early to create binding rules for all countries at the same time, because then we lose this innovative power.
Yeah, thank you very much, gentlemen. We'll take the last minutes to also take some questions from the audience. But first off, thank you very much for your great answers and for the amazing panel. Thank you.
Thanks. Give some round of applause to the panel at this point. Then we have some time for a few questions.
All the way on the top, we have one.
I see. It's a very decentralized seating order.
Thank you very much for the very interesting conversation and discussion. I'm a PhD student at HSG. And I'm studying the adoption, in one of the papers that I'm writing, I'm studying the adoption of DLT technologies. And what what I find interesting is that corporate adoption of distributed ledgers is I feel like lagging maybe a bit behind. And I see a strong case with immutability of transactions and the transparency, why we don't see a move of corporations trying to maybe have their accounting on chain. And I was wondering why that is. Thanks.
I can give the enterprise side of things, as we've worked with quite a few. And I think they just struggle to be able to get things through their internal processes in time for it still to be relevant. This space moves very, very quickly, and you need to be able to adapt quite quickly to the markets. You mentioned let's say, putting accounting on chain, but if you look at other sides of DLT, let's say blockchain, being able to have use cases such as, let's say, the NFT side of things, the metaverse side, etc. I know that a lot of companies want to get things through. They hire various firms for strategies, try to work things out, but by the time they have the approval, actually it becomes a little bit irrelevant. So I know that there are a lot of firms that have or actually most firms, I believe, let's say within, be it the S&P 500 or the likes, have had at one point a blockchain-based project in the works and are still probably working on it, or have just decided, look, this is a bit too complicated for us to innovate. We might just, let's say, acquire a firm that has been able to successfully do it and then integrate it into our processes. But that's the perspective that I've had.
Is that good, or did you want to add anything?
Next question.
Next question.
Thank you so much. Amazing panel. The best one for me in the past 3 days. Curious, because I haven't really heard this during these 3 days. Network states and hashtag decentralized Switzerland, like best practices shared on a maybe digital citizenship level, something like that. Any conversations in the ecosystem around that network states? Thank you.
I can try one angle, maybe Lucius can add up, but I think it all is centering, one of the biggest problems you're seeing in DeFi, in general, when you want digital adoption in a decentralized fashion, is identity. And once you dig into that, I mean, in Switzerland, we had a vote about an EID, and that was not approved, and we're working now on iteration number 2. And I think, to me, this is one of the most interesting bits of this entire blockchain discussion that's happening when it comes to identity. Because if you want to, whatever you want to do online, you need to make sure whoever is voting or taking decisions is the person she is or he is. So, and I think there's zero knowledge proof. There's different startups trying to tackle that. And interesting, I had a panel on the WEF in January, and it's a big question for refugees, for the UN. The UN is really desperate to try to figure out how do you create identity online. So I think we're at the very beginning. We have to crack the identity bit, and it's one of the most fascinating sectors, I think, personally, because it really is about humans and digital identities. How do you merge that? And not only for us here, but for refugees, people without passports, highly fascinating. So I think we're early stage in that, but interesting.
Thank you. Do we have time for one more? Good. Okay, one more.
Thank you. So I was wondering, recently the New York Attorney General talked about Ethereum maybe, or hinted at it being called a security. So, talking about Switzerland wanting to support innovation and taking kind of care of the mass and the risks. Many people feel like in US it's not that way. It's kind of like the regulation and the government against innovation and blockchain and all the other topics. Like, what are your thoughts on that? And is Switzerland different than US in that sense? Or, what are your thoughts? And also, what are the risks of Ethereum becoming a security for the whole blockchain ecosystem?
So if that would happen, that would be devastating, because securities are completely differently regulated from currencies, which is kind of a strange thing, but it's like that in the law. So if something is a currency, it's easy to transfer, it's easy to create a company that trades it. If something is a security, then you need a whole exchange, which is very tough, very hard regulated. You need a lot of capital. It's almost impossible to do it as a startup. So this is actually bad regulation, because there's no good place to put crypto in there. Crypto often, like the Ethereum token, is not a pure currency. So I agree with this attorney general. It serves an investment purpose. But if you just say it's a security, then you destroy its value or a lot of the potential, because it doesn't fit in there as well. And the European Union did actually something quite good. I'm often very critical of them, but I think it's good with the MiCA regulation. It's a statement to say it's something different. It's not a security, it's not a currency, it's something in between with new modes of investments and financing. And Switzerland, of course, is now in a spot where we need to decide, do we copy the Americans or the European Union? And traditionally, it's not. Sometimes we copy the US, sometimes the European Union. I would guess that we would side more with the European Union, because our legal system is more similar to that. But we don't have this legal framework of MiCA, so it's. I would be very surprised if they would suddenly say Ether is a security. But the other tokens are more at risk.
I think just picking back, it's one of the biggest conundrums out there. What is a coin? Because if you look at it from a very, non-tech perspective, it's just code, it's algorithm, and a coin can be all sorts of things. I mean, I've seen coins they can do staking, they can pay interest, you can voting, governance, utility, you can do anything. And if you buy an Apple share, it's an Apple share tomorrow. It's in a week, it's an Apple share. It's not going to come and be a US dollar or become something else. But in a coin, anything can be programmed. Switzerland at least has an ICO guideline where the government or the regulator is trying to figure out what it is. And MiCA now creates this virtual asset definition, but it's the same problem. And then Serbia as well, they have different categories. I think everyone is struggling with what it is. And the US is, I mean, I think they only agree that Bitcoin is not a security, the CSC and the CFTC. And for everything else, even the regulators, they fight about what it is. But I understand, because a coin, technically, I mean, Ethereum can be a lot of different things, from NFT to utility token to security and payment. It can be all of that. The question is, how do you label it? And I think that's the most fascinating aspect. Yeah,
I was just going to say, I think the approaches are different between, let's say, the US and Switzerland. Switzerland has always been open to communicating with the public through, let's say, non-action letters, being able to communicate directly with FINMA and be like, hey, this is what I'm trying to build up. What do you think? And I think with, let's say, the SEC or with the US, it's been a little bit like whack-a-mole. If you're a little bit too loud and you pop up too much on their radar, then you get whacked. So I think they do need to approach things maybe a little bit more in a collaborative sense. And I think, as Alex was mentioning before, I think they will slowly but surely get their act together. But I think, Switzerland as a whole has great measures in place for these things.
Thank you very much.
All right. Thanks a lot again for the question first and the great panel, also for the moderation, Victor. That was fantastic. Give another hand to our great panelists down here. So next up will be the announcement of the winner of the hackathon and the conference closing. So stay tuned while we set up the stage. Thanks a lot.
Hello, hello. Hello. The time has come. So finally, we came to the conclusion, or the judges of the hackathon came to the conclusion, and we also concluded all of the talks. I hope you enjoyed the weekend here. I mean, frankly, you all have my respect for wanting to sit in an academic conference room on a rainy Sunday. Well, claps to you for being here. I'll just tell you a few words of like what is to be expected now. Claudio will say some closing remarks. Afterwards, we will hear of the hackathon crew who will announce the winners of the hackathon. Then I will just mention this is a community conference. It wouldn't happen without a community, so I want to invite you to other community conferences happening in the near future in Europe. And then finally, we'll just take a picture with the production crew, the university students, all of the hackers, and anyone from the attendees who wants to be here with us on stage, because again, this wouldn't happen without you, is invited. So that's roughly the schedule for this session. And now handing over to Claudio.
Thank you very much. Thank you very much. Thank you, everybody. It was a fantastic first experience with this Ethereum Zurich conference. As I said in the opening, it was very strange that a platform that is so closely connected to this country never had the opportunity to, for the community to gather together, and we are really thankful to the people from the Institute of Crypto Anarchy, the people from Duct Tape Productions, and the people from Pwn that enabled this thing to happen. So I really want to thank them for all the careful organization and the management of this. It was a lot of work. So let us please begin. I also want to thank you all because it was, as it was said before, this is something that is bringing together the community. And I think that you did great. There was a lot of interest in this conference, and there was a fantastic range of activities inside. We had more than 100 presentations, but we also had a very nice set of side events, some of them also with the community of the University of Zurich. So thank you very much for all the time, people, and thank you for being here. I hope that we will welcome you again at the University of Zurich with something else in the near future. Thank you so much.
Okay, hello again. So the hackers have emerged from the hack house, some of them for the first time since Friday. So now this is the moment that they've all been working towards. In total, we had 71 hackers that spent the last 46 hours working on 16 submissions. It was a lot of work, a lot of sweat, and there are going to be some rewards. So we are going to go through this backwards, which means that we're going to start from the bounties, and we had 4 sponsor bounties. The first 2, to my knowledge, are going to be announced later because the sponsors still need to go through the submissions, make sure that they pick the right ones. It falls to me to announce the third one from API 3. And Ben from API 3 had to leave for the airport already. But it's my pleasure and honor to mention that the first announced winner today is Predict Flow. And they got the second prize for this particular bounty, which is $250. Is Predict Flow in the house? Do you see them? Yeah. So, congratulations, and just a couple of sentences about what your project is.
My project about create
prediction market, but with tools from sponsors. It's AP3 and Gelato, and it helps to build predict market more efficient way.
Awesome, thank you very much. So the first prize of the two in the API 3 bounty goes to, actually it's $750, and it goes to Fanta Crypto. So where's Fanta Crypto? So is this another solo hacker, or you had a remote team?
I was with another friend of mine.
Sweet, yeah. So what's your project?
So basically our project was about building a paper trading competition on chain. So people, could compete with other friends on chain, and also there is of course a winner. So the winner wins everything inside the pool basically. That's it.
Thank you very much. Congratulations. Right, and now we are going to move to the last one, which was a bit of a later edition. Okay, I need to stand in the middle. But I'll get someone else to stand here with me, and it's going to be Naim from Pawn, who is going to tell us who won the bounty.
Hi guys, kudos to everybody participating in the hackathon. The 1,000 DAI Pawn bounty goes to Liquidation Station. So come down and tell us about your project.
Congrats. Didn't expect that, my man. Thank you very much. Well, Liquidation Station is a decentralized multi-agent system designed to realign the incentives involved with liquidating underwater positions on the OVX protocol. We're looking to effectively remove the moats involved and the kind of data silos that you get with individuals, how do I put this, hoarding their own competitive advantage. We're looking to use the autonomous stack to effectively allow us to implement a co-ownable artificial intelligence that will intelligently liquidate positions based on consensus between multiple cooperating as opposed to competing parties. And that's our project.
So congratulations, and thanks to Naim. Naim was also one of our judges. We had 5 in total. So as we are moving on to the judges' favorite project, I'm going to invite Mario Havel from Ethereum Foundation and Parallelpolis to tell us which project was their favorite.
Thank you very much. Somebody's scared already. Thank you so much. It's my honor to be here on behalf of the all judges. And of course, it was tough decisions. I would like to say a huge thanks to all of the hackers here, to all of the folks who've been working hard. Let's give it applause. Yeah, all the hackers. Because I believe everybody's been working really hard over the past 3 days. It was not easy to decide on one winner here, or our favorite. But so we chose a project which really surprised us with innovation, with something which we haven't seen elsewhere, and also demonstrated potential, one of the potential implementations or use cases of this. And I'm not going to tease you much more. It was the CAFI consensus. So folks, congrats. Woo! Thank you so much for all of your work. Can you tell us a bit about the project, please?
Right, so hello, we are Caffeine Consensus, and we love coffee. So what is one of the biggest problems for adoption from large enterprises and government organizations? It is that it is too many blockers for them to interact with the public blockchain. But we have a huge opportunity with account abstraction and ERC 4337, where we can use the existing public key infrastructure that these enterprises already have in place to be able to interact with Ethereum blockchain. And so we chose to test this test this solution against the use case to verify a green and clean supply chain for coffee, because coffee is what fueled this hackathon project. Thank you so much.
So before you go, just a quick question. Someone else is going to answer this. How did you find the hackathon? You?
The question was how I find the hackathon. Yeah. It was actually amazing. I met a lot of friends that I already made the last year. It had fun tracks, fun technologies to work, like we did on the gap intersection. So I really liked it.
Thank you very much, and congratulations. I'll try to not walk as much. I'm gonna step aside soon because the not necessarily main prize, but the one that you all had a say in, was done through a quadratic vote. So to announce these 3 prizes, I'm gonna ask Dr. Nick to come up here from Factory DAO, and we are using the system you are using the system to do the vote. So it was pretty close, I think, right?
It was very close, actually. You can look at the vote if you want. I'm sure some of you might even know this if you were watching the countdown. But yeah, actually very close. We had one kind of clearish winner, and second and third place, and even third and fourth were very, very, very close indeed. So we had about 86 voters, about 1,300 votes were cast, 8,000 voice credits. And this is genuinely a public vote. So this is why we had the public presentation the other day. And yes, our third place was open source. Come down, open source. Incredibly happy to see DAOs in there, and a really great use case. So please tell everyone.
Thank you, guys. So we're the secret sauce. Yes, let's go here. Absolutely, absolutely. Yes, absolutely. So thanks a lot. We are the secret sauce of open source ecosystems. So our mission is to address the funding and the sustainability of open source software by turning Git repos into DAOs with their own token, creating people's developer contributions into a liquid asset. So yeah, guys, thanks a lot. Thanks for the team, and hope you see you soon. Cheers.
Wonderful, thank you very much. So open source had 113 votes and beat Liquidation Station by 2 votes, which is incredibly close for a quadratic vote. With about 4 more votes on 117, the second place prize was Caffeine Consensus. 2 prizes. I think this was the wonderful groovy presentation you gave on the Saturday. But yeah, please say something different than you did last time.
This was very fun. And thank you so much to the organizers. This was a great event, and we learned a lot. I think we used the whole Friday just brainstorming different ideas. And so, yeah. Anything else, Izzy?
I was already talking.
Yeah.
All right, thank you so much.
Wonderful, thank you, thank you, thank you. Okay, and actually a very clear winner in first place in the public vote was swaps.es. Well done, guys, well done. Congratulations. Who's going to be?
Thanks a lot.
Thank you. Thanks everyone for voting. This is really exciting. Thanks to the organizer. This was an awesome first event in Zurich. I'm really happy to be here. I live in Zurich, so I'm really happy such events are happening here. Thanks again. Maybe an applause for the organizers. Yeah, so our project is building again on account abstraction, which you can notice is a very popular topic. We built a swap protocol. We hope to have it fully functional by the end of this day, hopefully. It's almost functional. It's pretty cool because it should allow you to trade based on account abstraction wallets, and soon it will allow you to trade from wallet to wallet without having a different smart contract in the middle for settlement at all. So we hope that this will let you swap your NFTs with your friends. If you're an institution, maybe do huge trades without having to worry about compliance. And actually, we don't really know how many use cases this could have, but we're excited about it.
Thanks very much. Well done to the winners, everyone. Here we go.
So yeah, thanks to Dr. Nick, and congrats. Congrats not just to the winners, but also to all the other projects that were submitted. Maybe some that were not submitted, but hopefully are like stepping stones to some future projects that maybe we'll hear at another event at some point, or maybe, I don't know, somewhere else in the crypto world. So, now what? Couple of things, I'll get out of here quickly, but I realized that there is a cool POAP for this event that not many people, maybe not everybody knows about. So yeah, just to let you know that we do have it, come find me or someone else to get it. And then I guess there's time to relax. Take some time to digest like what you've done this weekend, what you've learned this weekend, the people that don't literally digest the people that you've met. Yeah, just, take a breath, but not necessarily for too long, because the last thing I want to share with you is something that is close to my heart because it happens in my hometown, which is Prague, and it's the Prague Blockchain Week. Yeah, sure. Why not? Why not? So yeah, I see some phones out already. There's the QR code that's going to take you to this website, and you'll see all these cool events and more that we have there pretty soon, in a couple of weeks, basically. So I hope to see all of you there. And with this, thank you very much, and I'll hand this back to Joseph.
So this was pretty much it. Again, like if you like this, there's more things to come. So I'm going to mention them quickly. But first, just for the openness, so you know some of the numbers about the event. It took roughly 6 months to get ready. Thanks to the collaboration with the University of Zurich, this like piece of like getting the venue was super easy. They were a huge help. There were over 800 tickets. I think like 800 tickets were given out for free to attendees, speakers, the volunteers. Roughly, I think like 35 tickets were sold in the last week, because we usually want to ensure that providing like so many tickets for free, we actually have people showing up. Well, thank you who purchased these tickets. Like next time, hopefully this will push you to sign up sooner. Out of the 835 people, something over 500, I think like 520 actually showed up here at the conference. So thanks everybody who did, despite the weather, despite it being a weekend. And yeah, what's next? So the first thing that we'd like to promote is by someone who has actually supported us here. It's ETH-DAM. It's happening by the end of May, 20th and 21st in Amsterdam. The second one by the organizers that were here, Maria and Matteo, Spaghetti ETH, happening also by the end of May, 24th and 26th. You already heard of the Prague Blockchain Week. Then the two events that are kind of crucial for us because it's essentially the same production organizing these is Prague DeFi Summit. So if you're in like TradFi or DeFi and essentially just want to meet and talk about like regulations, talk about like how to interlink these two words, please submit your talk or just like show up to this one. Then that's essentially our signature thing. It's ETH Prague. ETH Prague is happening for the second time. It has grown. So last year was roughly 600 people. Half of that was were hackers. We had over like 50 projects to submit. This year we actually had to book a second venue to the first one to just accommodate the hackers. So the hackers will have their own venue for 500 people. They will have full catering just like taken care of. So if this is to the hackers and also to the attendees that kind of like witnessed the hacking part and were considering actually participating next time, submit your applications to ETH Prague. There is a curation process, essentially just like to get a gist of like if you're a developer, if you're a product person, we want to have a good mixture of attendees. So definitely please check out ETH Prague. And yeah, Claudio would also want to introduce some of the events happening here.
Thank you very much. With respect to events that we are organizing at the University of Zurich or the University of Zurich organizes, we have Chain Science coming in mid-June in Boston, Massachusetts. We have a call for papers. It is centered around cryptoeconomics and blockchain analytics, natural sciences approaches actually to blockchains, not only technical aspects of this. And we have a special track as well of AI applied to blockchain-based systems. Then next is, many of you are here in Zurich. You know that one of the largest art conferences in the world is Art Basel. Art Basel is preceded 1 week before by Zurich Art Weekend, and Zurich Art Weekend will be opened by an event on NFTs, a crypto art actually, that is going to be the opening event of the Zurich Art Weekend. So if you are interested in participating on it, you can search us online. I do not have the QR code, but you will be very easily find it. It will be in the main building of the university, so a couple of blocks downwards. Thank you, Joseph.
Amazing, thank you. And the last but not least, also by people who were actually here among us, we're talking here about the projects they're working on. ETH Warsaw happening towards the end of summer, so might be another good opportunity to hang out with the crowd. So this is really it. I want to thank you, the audience, the participants who were here. So please, one last round of applause for this occasion. As PON and the Institute of Cryptonarchy, I also want to thank again to Claudio, the University of Zurich, the Blockchain Center. I want to thank to Florian and Sebastian. I actually want to invite you to come down here for the picture. So please do come. I want to thank the production crew, Stanley and his crew, handling. Oh, just like please come down. Just I'm pulling you in. And Nadia as well, that were part of the team. The duct tape production, Dan, Vojta, Camilla, the stage manager here, Tree, who took care of the hackathon, Jacob again, please. Aniko, please come on stage as well. There's a lot more people around here. I want to invite all of the hackers to join us here as well. All of the volunteers that help with this event, so you can spot all of the faces that participated on this. All of the sponsors, thank you Sentiment, thank you Near, Swarm, Octon, Tenderly, and Nethermind. Also thanks Galaxis, Starkware, Ovix, and the ecosystem support program of the Ethereum Foundation. And thanks to the Ethereum Enterprise Alliance for bringing interesting speakers and helping out SMC. So please, Tom, if you're here, show up. And yeah, again, if anyone wants to be on this closing picture, and this is like after this we all leave the room, we move to the cafeteria to where the booths are, and we close this up. If you want to be here with us to take the picture, please. Sure. Yeah. Yeah. Did I forget anyone? Did I forget? And also, I'm a little alpha. The abbreviation of the event name is EZ. There's like many things that can be hidden behind it. So definitely keep an eye out. Like watch us on Twitter, and there should be more announcement coming in a few months about like what's next here in Switzerland. So thanks again, and ciao.